and just go straight PowerShell. Majority of things work. Some things are a little bit weird, especially if you go into the deeper dive stuff. But for the most part, you can go to GitHub or even search on Google for PowerShell core, and you'll see there's several different supported platforms, including Windows, because it is actually a separate, different version. So like I said, it works slightly differently, but most people won't notice the difference until you start going to the deeper dive stuff. What I'll go ahead and demonstrate for you, like I see, unfortunately I didn't get time to record a video, but there's three different, I'm demonstrating the Docker, Ubuntu, and Mac, and it's actually very easy to do these installations. Docker is probably by far the easiest, simply because you can download the Docker installer, install it on your computer, and then simply just do docker run -rm, which is basically remove the Docker container, IT VMware /power CLI core. Now what that does essentially is it downloads the Docker container from the Docker repository, does this all automatically, so as long as they have internet connection, that's all you really need to do. Once you do, it immediately throws you into the Power CLI prompt. The cool thing with the Docker container is that you can do a get module and list available. And what VMware has done, and I'm just listing a subset here because it's like a really long list, they pre-built essentially a Docker container running Photon with all the Power CLI stuff. So if you want to get up and running, boom, that's your easiest way to get into it. Now, if you want something a little bit more native to the operating system that you're running on, so Ubuntu or Mac, for instance, the instructions all lay it out. Basically, you have a couple different ways you can do it. You can download the package, which is essentially like an executable or MSI in Windows terms, install it that way, or you can use package managers that are typically available in Ubuntu, in CentOS. So Ubuntu is like apt-get, CentOS is yum, and you basically just type in the apt-get and say apt-get PowerShell, downloads everything from Microsoft, and installs it for you. And as you can see here, and I have the modules already installed, and I'll go into the next slide of just installing the modules yourselves. But same thing with Mac. Mac has an unofficial package manager called Brew, and the Microsoft actually recommends you use the package managers because it ends up being a lot easier to do upgrades and whatnot. It's simply just typing in your package manager apt-get sudo or not sudo, yum or brew, and just say brew update PowerShell, and it'll update it all for you. So as you can see here, I downloaded in Ubuntu pwsh to run PowerShell core, and then I can do a git module, and I have it all there. Same thing with macOS, brew cask install, run pwsh, and now I'm in my PowerShell window, and I can run git list a module and have all my modules. The one module that doesn't quite work with Power CLI core yet is the SRM module, although I'm understanding that they're continuously iterating and probably will get that feature functionality out there. So on the Linux and Mac side, it's, like I said, it's not as easy as a Docker container. You have to actually run it. So on the Mac side, you basically, Mac or Linux, you just run pwsh, launches your shell, your PowerShell. And then from there, PowerShell Gallery is available, and there's a command called install module. You just simply say install module vmware.powercli, and I added PowerNSX because this was listed as an NSX category. And that'll install both modules for you. Once you have those modules downloaded, then you can just simply connect and do whatever you want. One of the cool things, though, if you really wanted to mess around with Docker and make your own Docker container, you can actually look at the example that VMware provides on how they built their Photon container. And it's actually pretty simple. So I actually made a Docker container file, running Ubuntu, just because I was curious on see if I could do it. And yeah, you basically just put it together, and it's almost like literally putting together a shell script of download Ubuntu, here are the packages needed to run PowerShell, and run PowerShell, and it's done. and now you have your own personal customized Docker container. And I have the list, the Dockerfile example there. It's kind of cool because Alan and Jake Robinson are the ones that wrote a lot of that Dockerfile, so you can see what kind of workarounds they had to do to make it work on Photon. So it's a really good example to look at. Here are all the references that I have. As far as the switches are concerned in Docker, I had a real hard time trying to understand why the switches are the way they are. And I do have that on my blog, so if you just look for Docker, you can actually find it. And it'll list out exactly what each individual switch means and what they do. And then, there's the Power NSX repository. It is open source. It is all based on PowerShell. So you can actually, if you find something wrong with like a Power NSX type of commandlet, you can download the entire source, make your changes, push them back up so that they'll go ahead and implement it into Power NSX. Now, Power NSX is NSX for data center only, or NSXV. But it's probably the closest. It's definitely a lot easier than the NSXT stuff. So if you're using that, cool. And it is open source. Definitely recommend going and doing that. I actually pushed one myself because there was some SSL validation problems I was dealing with. And they're pretty active on it. So they're always looking at the pushes and comments and whatnot. One of the biggest things, and I don't have it on here, one of the biggest things, so if you've never used or if you use PowerShell, right, you have to typically go in, you have to RDP through a system, right, and run PowerShell to get some information. One of the cool things with PowerShell Core is, since you could put on a Linux system, you could technically just run PuTTY from your iPhone or whatnot, SSH into that box, and run PowerShell, right? So then you can get all your information and do all kinds of things without actually having to RDP onto like a small iPhone. So it's really cool for like day 2 operations and whatnot that like, oh, you need that information? Or you can be having your scripts hosted on there and just run it. Other things, and I've been playing around with this later and I'll post it on my blog, and there was already an example out there, but a guy made a REST API endpoint with PowerShell that runs a PowerShell script if you do like a get or if you do a get against it. So it's a really cool example. There's all kinds of security things, code injection, all kinds of stuff, but for exploratory purposes, it was kind of interesting. So I kind of worked with that model, and I needed to do like something like I needed to get a JSON input in order to run my script so I can get a bunch of variables and whatnot. So I made I used that, and I made it so that you can do a get or a post, and if you posted a JSON, it would take all the variables and run that script with the variables that were provided to me. One of the other cool aspects of it, and like I said, I'll post this on my blog. I don't have it here because I wasn't sure if I could do an interactive demo, so I was going to do an interactive demo. But if you wanted to get information on demand, so one of the things I used to do in the past, I used to use IIS and PowerShell, a scheduled PowerShell script to basically produce an HTML file, so that way people can see like the environment. With this, it's kind of cool. I can just run that script to run basically the endpoint, and if you just went to that server URL, you could essentially, a get is essentially just, you're just calling a website. You could essentially I could put my report script in there so it would run on demand the minute you would go there, rather than it being like a scheduled thing. So kind of a little cool thing to play with. I definitely recommend looking at it, especially with Linux being available. You can kind of get rid of your Windows licensing, so you don't have to deal with that type of stuff, if you have to deal with it. Some people don't, but that's pretty much all I had. Make sure you're filling out your surveys so you can win a card or whatever. Does anybody have any questions related to PowerShell Core or even VirtuStream? I'm not trying to go into VirtuStream talk, but if you want some of that.
Hi. So my name's Craig Waters. I'm a product manager for Pure Storage, and I'm not going to talk about Pure at all today, but what I want to do is I just want to give you like an introduction to NVMe. I use it quite a lot in my job day to day, and I just wanted to kind of give you some background on it. So this isn't going to be a product pitch, it's just more going to be around what's NVMe, what is it about, why is everyone talking about it, what the benefits are, and really like to kind of give you some insight into how you'd use it, how it could be of interest to you in your organization moving forward. So I've got to start, I've got a bit of a taxonomy picture here, so I've got to start around just kind of determine some of the terms that are typically used and what they translate to when we talk about NVMe. So, you know, like typically there's like three kind of like transports that are used, like SATA, SAS, PCIe, or it could be like Rocky or something like that. And they kind of like equate to a command set. So you're probably really familiar with AHCI. That's typically what a boot partition on your server would run from. You've obviously got then SCSI, you know, traditional storage transport, and then we've got this new guy at the bottom here, NVMe, and really they're the kind of if you like, the translation of terms for when we talk about command sets versus transports. Yeah. So in this case, you know, we're going to talk a lot about NVMe replacing SCSI, and then PCIe or one of these NVMe over fabric terms replacing SAS. So just want to kind of get that really clear, yeah. So why NVMe, right? So you're probably going to find that pretty much any device you use today, you know, phone, laptop, all those consumer grade products already use NVMe. It's already been utilized, yeah. What's interesting is that now NVMe is kind of hitting the enterprise space, and that's kind of unusual because normally it's the other way around. Normally these kind of technologies are tried and tested in the enterprise before they become consumer grade products. So that's kind of an interesting kind of change to what you normally see. I'm not going to go into why that is at this point in time, but you probably got a few opinions on that. Really, the value that NVMe is kind of bringing to you is this concept of parallelization of I/O. I've got some more slides to kind of talk about that a bit more, so I'm not going to kind of cover it too much, but that's kind of the real big difference with NVMe is that we're traditionally with these serial products, you've got a single channel that you're running I/O through. With NVMe, it's a parallelization of that I/O, and that kind of brings out a ton of kind of benefits, yeah. And really, the other piece really is around this idea of like, there's a bunch of new technologies that are being used right now that traditionally haven't been considered when the likes of SCSI and stuff came into play, you know. So, you know, multi-core CPUs is a good example, you know, high density SSDs, you know, flash is like, you know, we can get some really high density now in flash. How do we drive the performance out of something that's really dense, you know, what the challenges are around that. We've also got some, you know, new memory phase change technologies like 3D Crosspoint, although even they're having, you know, kind of some stumbling around being adopted in the market right now. And then also, you know, a good enabler for this is around the very last one, around high-speed interconnects. So, you know, we're seeing networks now, you know, supporting 50, 100 gig Ethernet. You know, it's much faster and much more larger bandwidth than some of the traditional storage transports, about 100 meg, 1 gig, those sort of things, yeah. So NVMe, I think really kind of what's important to kind of consider with NVMe is that it's bridging this kind of price point. You've got this gap between, you know, your spinning Rust and DRAM. And we've seen SSDs kind of proliferate into this space, and really NVMe is an enabler for that. Because what's going to happen is that as SSDs get bigger, it's going to become just like spindles on spinning Rust. And what I mean by that is that as the capacities get larger, the actual performance of the drive is going to reduce, yeah? And you can see, I've got an example here of like, you know, where we start off at really high IOPS at a small capacity. As the drive actually gets larger, then you can see that the high IOPS actually reduce considerably. And that's really the problem with SSD in its current form, where it's been encapsulated in, and you know, pretty much fooling the controller into thinking that it's accessing a spinning disk. When in actual fact, what we're doing is we're using the controller to kind of, the firmware on the controller to actually kind of fool the underlying system into thinking that it's a spinning drive, when it's not, it's actually SSD. So there's a massive bottleneck brewing here. And this is what I mean by this, is that, you know, with a SATA storage architecture, it's a single channel in SAS connecting all these SSDs. And that coupled with the size of drives, it's quite a while ago now, but Seagate kind of announced a 60 terabyte SSD. It's awesome from a density perspective, but the performance of that, you can see there, it's 400 times slower per gigabyte, yeah? So, how's that going to work, yeah? And what I've done here is I've kind of shown basically what the components that make up the flash translation layer from the flash device itself through to the controller. And you can see here over SCSI, there's a lot of translation that's going on here further down in the block layer. And this kind of equates to more than half times the amount of milliseconds for that I/O to be driven. Now, you look at that and you think, well, microseconds, what's like 2.8 versus 6? It doesn't seem much. But when you parallelize that over hundreds and thousands of I/O commands, all of a sudden that latency becomes super important. So what I wanted to do was kind of show the comparison between a traditional kind of storage architecture and then what NVMe kind of provides as an example. And you can see here, like the challenge with SATA is you have this single queue. There's one channel and one queue for all those SSDs to share. And that's kind of where you're going to see this bottleneck occurring. Whereas from an SSD, I'm going to just come straight over here. From an SSD perspective, you actually have a direct memory mapping from the core of a CPU all the way through to the SSD, the NAND flash chips that are on the SSD itself. So you've got that direct one-to-one mapping, and it basically means that you can parallelize I/O across all those SSDs at the same time, better utilizing the cores on your processors to actually drive I/O in your infrastructure. Yeah? So that's kind of an architecture for PCIe, which is direct attach storage. But what about if I want to use remote, like if I want to use NVMe over Fabrics, for example? So really what NVMe over Fabrics kind of brings is that it really eliminates this kind of idea of the outside the box penalty. And what I mean by that is that with DAS, I'm bringing the CPU to the storage directly. And that means we can get ultra low latency when that I/O is being transmitted between, when a process is being completed on the CPU and then how that's being flushed out to disk. Whereas with NVMe over Fabrics, we're actually adding about 10 microseconds on top of that process. So even though we're going over a fabric, we're actually not changing the performance of that I/O at all, yeah? And the other kind of key consideration here as well is that when you're using technologies like RDMA, you're actually reducing the amount of CPU. So that CPU that you're using to drive your hypervisor and your virtual machines, it's dedicated to running those workloads. It's not actually being used to drive the I/O of your VMs onto the storage system as well. So there's a huge benefit that you can gain from that processing being offloaded into your, either your NIC or your HBA onto the storage system, as opposed to it being utilizing CPU that's running on your server itself, yeah? And then the third one there is just kind of showing, like a parallel architecture where you've got applications and servers using NVMe to drive the performance out of the storage and out of the flash modules that you're running on your storage system itself, yeah? So you're getting parallelization all the way through the stack. It's not just from from the host to the storage array, but it's also within the storage array to the flash drives themselves as well. So RDMA, remote direct memory access. What that means is that, what we kind of showed in the last slide is that the CPU on your hypervisor, on your operating system, is not being used to drive I/O performance. It's actually being taken out of the equation completely. And instead what's happening is that I/O is being driven directly from the end storage device. Now, NVMe over Fabrics comes in a couple of flavors right now. InfiniBand, we're not kind of seeing that much at this point in time. First off, it was kind of considered to be a good transport for, you're actually seeing stuff around TCP as well, which is kind of becoming quite interesting. But predominantly, there's kind of two main kind of contenders for NVMe over Fabrics. And so the first is Rocky, which is RDMA over Converged Ethernet. So that's using your standard Ethernet adapter. It's taking advantage of things like 10, 40, 50, 100 gig Ethernet. And then the second one is Fiber Channel over NVMe. So that's, again, it's taking advantage of new, performance technologies around Fibre Channel for 32 gig E, those sort of things as well. But they're kind of the two main ones. The interesting thing with Rocky is that a version 2 of Rocky was announced fairly recently, and that supports basically routing of NVMe traffic. So Rocky version 1 was just like a direct attached device, so you'd have your server connected to a top of rack switch, which would then in turn be connected to your storage array. Whereas with V2, you can actually route that traffic, so it can actually have multiple hops. So it's kind of layer 3 versus layer 2, that kind of thing. So I wanted to just kind of show you what the packet of a NVMe kind of traffic looks like, and then also show you how you identify it, because it's actually quite familiar when you see NVMe being used. But I think it's quite interesting. They have the concept of a capsule, and you can see here, you've got local NVMe, which is like using you've got your NVMe transport, which is using a local bus through memory into a PCIe connection, and then you've kind of got your NVMe over fabrics on the right there. So again, it's encapsulated, but it's kind of different in how it actually is presented versus Fibre Channel, versus InfiniBand, Rocky, and iWorks, another implementation as well. But like I said, with NVMe over fabrics, typically it's Rocky that's been the predominant one for Ethernet, and then obviously Fibre Channel for Fibre Channel as well. But if anyone using iSCSI in the vSphere implementation at the moment? Okay, so everybody knows what an IQN is, yeah? Okay, so when NVMe is supported in vSphere, for example, you actually see it listed as an NQN. Okay, and it's kind of managed and configured exactly the same way as iSCSI. Just the difference is that it's got an N at the beginning instead of an I. So the things that you do today when you're dealing with IQNs and iSCSI will continue to be the same things when you're dealing with NVMe over fabrics with Ethernet. Similar to like if you were doing NVMe and it was Fibre Channel, you'd be dealing with WWNs and those sort of things. So those things don't change, and that's what's kind of really important with this, is that it's a change in protocol, but the transports are actually very similar still. There's no real change to how you do Fibre Channel. There's no real change how you do Ethernet. It's just it's just the drivers that are running on either your storage system or on the hypervisor that kind of determines and supports NVMe as a protocol, yeah? So the similar diagram as what I had before for PCIe. I just wanted to show it with NVMe over fabrics, and you can see again, similar constraints around SAS and SATA being like a single queue. In this instance, we've got multiple HPAs, but again, they're kind of accessing SSDs in a single queue, and then we have a single queue up into for each of them into the actual CPUs. And then again, with NVMe over fabrics, we have that connectivity from the host into the network medium, be it Fibre Channel or Ethernet. But we have that parallelization again. That every single CPU core has a direct correlation to an NV RAM module within that SSD or within whatever that storage device is that you're using. Yeah, it's a massive parallelization that you're getting from that interconnect. Yeah. What NVMe over fabrics does, because okay, so it's really cool to see all this, but it's kind of like, well, what's the point of this? What's the value of this? So what you see today is you see like traditional DAS architectures being used, particularly for scale-out applications. So if you're doing things like analytics, like Hadoop clusters, those sort of things, you'll typically find that this is the architecture that's used. But the challenge with this style of architecture is that you're having to scale compute and storage together. And you can see the example here is like with a DAS system, I've got many SSDs or many storage devices on a per node basis that I'm having to manage and maintain. And they're coupled to the CPUs on each of those nodes. So if I'm scaling capacity, I've got to scale CPU at the same time. I've got no choice, yeah? Whereas what NVMe over fabrics can do, because we've like eliminated that out of the box kind of performance constraint around having a shared fabric, it basically means, and I'm sorry there's a pure storage array there, that wasn't intentional, but it's to show that you can have a shared storage system that can drive exactly the same amount of performance, and you get all the benefits of a shared storage system. So you get all your your data services, your snapshotting, all those kind of capabilities. And it basically means then that with a shared storage system, I could have multiple Hadoop clusters or multiple DAS-based clusters that I would traditionally use with DAS, but I'm getting that shared storage availability. I'm getting all the benefits of shared storage and not having to manage the application on a per instance basis, yeah. So just to kind of consolidate and kind of finalize and just recap on these benefits. So NVMe, there's three kind of big things here. One is the performance, obviously, higher throughput, lower latency. The other is freeing up your CPU cores in your compute nodes. So some of those CPUs can actually be used to consolidate further. It can give you more density in the compute, but also it means you maybe need to buy less CPU as well. So maybe you don't need as many many compute nodes as you're running today based upon SATA and SAS constructs using serial. And then the last one, which this is inevitable. This is going to happen. Like SSDs are just going to get bigger. That's all that's going to happen. Yeah. So it's really important to adopt things like NVMe to kind of be able to provide that, so that you don't get a similar situation. So with SATA SSDs today, we're actually coming to this point where you're having to go and bundle, a bunch of SATA SSDs, similar to how you'd bundle a bunch of hard drives in spindles to get the spindle count to get the performance out. That's beginning to happen now with SATA SSDs as you kind of drive larger scale capacity, yeah? Whereas with NVMe, you could have a really small subset of drives, like 5 or 10 drives, and you can provide the performance all you need. You don't have to have that spindle count similar to spinning Rust. So that's it. Thanks very much. If you've got any questions, I'm happy to have a chat. I'm just going to stand over here, but appreciate you having a listen, yeah? And vBrownBag rocks, and I'm really happy to be presenting today. So thank you, yeah?
Hello, and thank you for attending. Today we're going to talk to you about the VMware Center for Advanced Learning Advanced Architecture course. But first, before we get into that, I'll give you a little bit of background about us. My name is Damon Bear. I'm a Senior Solutions Architect for Scalar Decisions. I'm a vExpert for 4 years and a vExpert NSX for 2008. I'm based out of Canada, and I work for a company called Scalar Decisions. I'm also vMUG leader for Toronto. And
so I'm Jonathan Copeland. I'm also a senior solution architect. I work for Connection IT, and I'm based out of the San Antonio area. I've been a VMware vExpert for the last 7 years and a vExpert for NSX for the last 3 years. And so I cover a number of various areas, including all about the data center.
Great. So the first thing we can talk about is the Advanced Architecture course and what it is. It was created as an initiative by VMware to create a standard process and methodology that can be used by both VMware internal staff as well as partners, so that we have a consistent approach when dealing with customers, that we can translate business problems into actual solutions. Now, this consisted of a 2-week intensive course, and when I say intensive, I mean it was really intensive. It was 12-hour days where we would do a full day in class and sessions, and then after that we would do some work in the evenings as well over dinner. We did this over the course of 2 weeks. So just to give you an idea of the people that went down there, were senior architects from various partners around the world, as well as senior architects within VMware from all different business units. So we had people that came in from overseas, from Saudi Arabia, from
everywhere but
Asia.
APJ.
Dive into the entire portfolio of SDDC, EUC, PKS, everything you can imagine, everything that VMware does, we dove into it. And we had the product owners and the lead engineers from each one of these different business units that came and actually talked about it. And they talked about things that you don't normally see in marketing or regular education classes. So it was really great to get access to this top level tier of people. We also did some live fire training, and one thing that we did, which was really good, is we went through a process of mapping out business problems over to actual solutions that we can employ. And the method that this is the method that we use. First, defining the business problem, determining what that business problem is in terms of an IT problem, then figuring out what IT capability is needed to overcome these issues, then come with a business outcome. The key thing about this is that product was not the main thing. So it's not like we had a solution and we were trying to find a problem. It was understanding the overall business problem and then turning that into a solution. Then whatever came out in the end is what was the best fit for the customer. So there was three pillars of business relationship from IT to business. First, there's the infrastructure provider, where you drive efficiencies, reduce CapEx. And then there's a business partner, where you accelerate growth and you start working a lot closer with the business. And then once you reach a certain level, then you can support a digital enterprise, where you can create new business models and really do things that are groundbreaking. Now, some important things about this is that in order to reach the next level of business partnership, you need to ensure that certain dependencies are met. And I'll talk about these over here before I go to that. So, as you increase the capabilities of each one of these pillars, whether there's an infrastructure provider, or a business partner, or digital enterprise, you need to meet a certain amount of prerequisites. So, for instance, with the infrastructure provider, first you need to ensure that you have virtualized everything. Then you've created a private cloud environment. Once you hit that level, then you can provide infrastructure as a service. But if you haven't reached a certain level of maturity as an infrastructure provider, you cannot advance to that next level of business partner or to support digital enterprise. One of the big issues that the companies have is they have a great vision of what they want to do with their business, but they haven't gone through this dependency mapping process, so there's no way that they'd be able to achieve their vision. So through the advanced architecture course, it really helped us map out how to get from the business problem, mapping out the dependencies, over to the actual business solution.
And one of the interesting things when you're talking about this, because we weren't talking about product within this, it allowed us to really talk about those capabilities and maturity within each of those pieces of the business, and not focus upon how does this product deliver it, which allowed us to focus on what is the best of breed within each one of those and bring that in. So if you were missing a specific area, you could go deeper into that and mature that and then move on, because each of our businesses need to move to a certain digital economy. We know that no matter if we're a manufacturing business or anything, but we had to get to a certain level to be able to deliver that. And so this helps us map that out.
And one of the great things about mapping this out when you're working with clients is that it allows you to build a long-term roadmap, so that you can say that in order to achieve these capabilities, these are the things that you need to do within your organization. These are the technologies that you need to be comfortable with, and have the support infrastructure for that.
And on the bottom there, you notice that it's actually got several things that are underpinnings. So there's some foundational levels that go all the way across that you must have. So you must be able to support your end users with the consumer side of things, whether they're internal users or external users, but you also have to make sure that all of that has security baked in. And so we've seen that within the VMworld conference this week, how they're saying security is intrinsic. This was actually well before that. We've been talking about that. Even without a solution or without a product there, this is focused on security at the base.
So taking this back over to our internal companies and working with customers, some things that the customers are saying once we take this approach are that they've never looked at IT this way before, or they can't believe that we've actually come up with a strategy and solution without leading first with a product. So it's really changed the way that we've approached our dealings with customers, and the way that customers are able to achieve their solution goals. So, Jonathan, maybe you can talk about...
Yeah, so recently, just less than a month ago, I actually went to a customer. We've delivered this a couple of times now, who sat with a customer for about 4 hours, no charge for the customer, because it's a VMware program that we're doing. We go in, we ask for two things. We ask for two groups. The IT group, some IT managers, with some of their teams. We develop a list of what their IT problems are and a list about their IT outcomes or projects that they want to do. We then rank those. It's very interesting. You think about, well, we've already got a ranking, but maybe there's not really a true consensus within your team. So we do a blind voting method within our organization to do this, allowing each team member to vote without their influence of others and without influence of their manager, which is very important because sometimes we form opinions based upon what others do too. And so by doing this, we actually re-rank that and show what the top of mind thought is. After that, we've had this situation where we go in and we bring the C-level executives in and they list us and give a list of their business outcomes and business objectives for the organization as a whole. We rank those and break those down into two things. Is this project or outcome a revenue generating project, or is it a cost avoidance project? Those are the two R's that you want to focus on because almost everything can be broken down to one of those two. After that, we can map those back to the various IT projects. By doing so, we allow the IT organization to see what is this project and why is it such a focus by the organization? Why am I getting pressure to do this? It may seem logical to many of us, but many in IT don't understand how that maps up to the business. And then when we do that, we show them that this project is generating revenue, this one may be doing cost avoidance, and then we do another vote round. What are the most important based upon cost avoidance or revenue generation? And if we think cost avoidance might be the most important, realistically it's not. If you talk to a business individual, revenue generation is the key to survival in any business. And so we focus and help re-rank those IT projects that we did at the very beginning back to which ones primarily support revenue generation. And then later down in the line, we put down the cost avoidance ones. After that, we follow up with a follow-up round and re-rank them based upon what might have to come first. Because we know there are certain things that have to be done in order to do follow-on projects. So we might change the order slightly based upon those foundational or prerequisite projects. What this does is it provides a roadmap to your internal IT organization and to your business organization saying, these are the things we're going to do, a timeline we're going to do them in, and how they're going to support the organization. And it fosters communication between both sides because sometimes, realistically, neither one communicates their goals very well.
Yeah, one of the main reasons why projects or initiatives fail is because you don't have alignment between IT and the various business units as well as overall management. If you have alignment between them, then there's a good chance that you're going to have the funding, the buy-in, and the success of the project. However, if you have one area that wants to do revenue generation, the other one that wants to do cost avoidance, then you're going to have a battle and you're going to have a failed initiative.
Yeah, and one of the things that really came out of the Cal AAC course was involved with this was refocusing on when we deliver projects and project presentations as IT and as architects, not to focus so much on the features or the items that we're doing, but to really focus upon how the business value is being delivered within that. It's a change of mindset for all of us as IT folks. We have to think business first, IT second, because feeds, speeds, features, widgets are cool, but really we're getting paid because of the other.
Yeah, now this is just a brief intro to the AAC, but if you want to follow up a little bit more in depth, there's actually another session that's going to be happening tomorrow with TJ Vatsa at 10:45 a.m. So I strongly encourage you to go over there. He was one of the main
he's a principal consulting architect for VMware. So TJ and Mitesh Panacholi are two of the two that led the discussion within this. And this is really how VMware is doing this themselves within their own organization.
Yeah.
So questions, comments, thoughts? Is this something new to everybody? Should it be something we are all involved in? you have to have a certain depth of knowledge. So they were inviting folks who have a certain level of depth. You may have to have VCP or better in some of these, not all. For instance, in my team, we had some that were end user compute specialists and some that were NSX. Other teams were cloud heavy.
Yep.
So it does not that you have to have a specific, and the nice thing is when we're doing this, we actually delivered a presentation as a project together as a team. And so you see how team dynamics work on that too. So that really helps you see when you come in as a consultant, or you're coming in and bringing in other pieces of your own organization as a team to be able to develop that teamwork very quickly.
Yeah, and another thing about the presentation that we did for the executives down there, because we had a number of VMware execs that actually came in to watch our presentations, which was a little bit nerve-wracking, but it was also exciting as well. Is that we had a certain area of focus that we did based on the skill sets of our team. However, we had to map out work streams and phases for all the different parts of a large-scale comprehensive solution, so that we could associate estimated timelines and a level of effort and work with those, but we would drill into a specific area and then really map out the detailed design solution for that.
Yeah, and it was interesting talking with the teams after. Some really focused on how to do architecture as architecture. And so we might get into this discussion. Are you trying to do this VCDX style architecture, or are you trying to do a business architecture? And sometimes we're really needing to put on more of a business hat. That's really what this course is helping us focus on. And what this other thing that VMware actually said is that it's interesting that they found that customers have bought product and have never delivered product that they bought into their own organizations because they did not have a true solution for it. This is what this is really to help us do, and finally and finish up and do that, get those things implemented to support the business.
Yeah.
Anything else? Any other questions?
I think it happens every quarter.
Well, I have an update.
Oh, do you? Okay.
I have an update. Yesterday in one of the courses that TJ was actually talking about, and this is going all the way up to Pat Gelsinger. So they have refunded this with additional dollars for partners to be able to be in this. I think they said they have an additional $1 million, and they're going to start delivering this every month to partners and others. It has been every quarter, but they're going to be pushing this out even further, including shadowing for those people who actually go through the course. We've actually been involved in it and continuing to have communication through the Microsoft Teams workspace with the VMware teams that we were working with. So that's very nice. Yeah. It felt like we're actually somewhat connected at the hip with VMware.
How many people do you think we had over there? It was like 40 or so?
I think the count in our class was 26. It was 15 PSO and 11 partners. Thank y'all. We appreciate it.
Yeah. If you want to follow up with us.
Hello and good afternoon to everyone. How many of you, this is your first VMworld? Yeah? Are you enjoying it? Yeah, it's not my first, but I'm still enjoying it. How many in the audience are at your fifth VMworld? Anybody? Outstanding. Thank you for continuing to come. It's a pretty good time, right? Everybody's having a good time, right? So my name is Dale McKay. I am an NSX TAS. If you are unfamiliar with the TAS program, please see me afterwards. I'll be glad to explain it to you. This is definitely not a presentation about the TAS program. It's a presentation about BGP best practices with NSX. How many people in the audience have deployed NSX? Okay, great. How many of you operate NSX with BGP? Okay. How many of you have a network staff that is unlimited resources and is the best network staff that you've ever had the chance to work with? How many are going to raise your hands on that one? Nobody? All right. I kind of thought that might be the case. This BGP little lecture is specifically aimed at those organizations that don't have triple CCIEs working for them, that maybe need a little bit of distilling in terms of what are the BGP best practices. That's what I'm going to cover. So we will talk about those best practices, and we'll take a little look at some of the BGP configuration that you might find in your environment. What we're not going to talk about is I'm not going to teach you the BGP protocol. That would be a lot longer than we have in this session. We're also not going to talk in depth about a leaf and spine architecture. How many of you implemented leaf and spine when you implemented NSX? All right, I'm going to ask you a few questions about that in just a minute, but we're not going to go in depth into the leaf and spine, nor will we talk about multi-protocol BGP. We also won't talk about BGP with IPv6. So those are the things we're not going to talk about. Having said that, let's talk a little bit about this particular presentation. What I did was I looked at the VVD 4.2 documents. And I know if you keep track of VVD, you may say, well, 4.3 is out. Okay, guilty. I haven't updated this presentation since 4.3 came out. But what I did was I looked at 4.2 and I tried to distill down what it was that somebody would need to know about BGP out of that document. One of the first things that we need to talk about, a lot of people raised their hands when I said, did you implement a leaf and spine architecture? How many of you implemented a layer 3 leaf and spine architecture? Okay, 1, 2, all right, 3. What we mean by leaf and spine, or layer 3 at leaf and spine, is obviously the fact that the layer 2 domain terminates at the top of the rack switch. Is that the only way you can do leaf and spine? Absolutely not. But for the purpose of this presentation, that's going to be our focus, is going to be on a layer 3 leaf and spine architecture. We're also going to make sure that we talk about dynamic routing protocols. Obviously, we're here to talk about BGP, but you also know that OSPF could be used. That might be possible. And you can see some of the guiding principles in this layer 3 leaf and spine architecture. We're going to advertise a small set of prefixes. Everybody's okay with that term prefix? If you're doing BGP, you ought to know what that means. We're going to have equal cost paths to the other racks. The switch is going to provide the default gateway or be the termination point for our layer 2 domain at the top of the rack switch. We'll probably have some 802.1q trunks. And like I said, for the rest of this particular session, we're going to assume that this is a layer 3 topology. Everybody okay with this so far? I didn't lose anybody yet? Any questions? Everybody's good? All right. First thing that you need to do when you're going to use BGP with NSX, particularly in the software-defined data center, is you need to make that decision. Are you going to have layer 2 or layer 3? And if you need some additional material to help you make that decision, I put the RFC numbers in there, RFC 7938. That would be a good one for you to go and read. A couple of things to point out about BGP. A lot of people are pretty familiar with OSPF. They like OSPF, but OSPF does have some issues. And one of them is the fact that you need to design for area 0, or you have to implement virtual links, right? Virtual links get complicated. It's something else to break. With BGP, obviously, we don't have that requirement to design for area 0. I've worked with customers that had OSPF. It's a workable situation for sure, but if you're designing this in a greenfield environment, why would you do that? In my opinion, there'd be no good reason for you to do that. Another thing, and this is probably one of the more important points of my entire presentation, is that you need to go in and adjust the BGP timers. Now, you're going to hear me mention some other important parts here in a few minutes, but this one's pretty important because by default, you can see that the Cisco values, and this assumes that we're using Cisco top-of-the-rack switches or Cisco spine switches. The keep alive timer is at 60, and this is again, recommendation right out of VVD 4.2 that from the top of the rack switch to the ESG, if you look at the bottom set of values there, we take that 60 number and we drop it down to 4. That's a pretty significant change. If you don't do that, what's going to happen is as you have changes, your network is going to lag in terms of digesting those changes and adjusting to those changes. So that's a pretty important thing. You can see that there's actually 2 different sets of values. There's a set of values between the top of the rack and the ESGs, and then there's also a different set of values between the UDLR and the ESG. Everybody's okay with those terms, right? Edge Service Gateway, Universal Distributed Logical Router. Everybody knows what those mean, right? All right, good. Next, if you're going to do BGP, it's probably worth you understanding how loop avoidance works in BGP. Is everybody familiar with loop avoidance? Because loops are bad, right? We've always known that, whether it's layer 2 and we're doing spanning tree, or whether it's layer 3 and we're trying to prevent routing loops. Loops are bad. How does the BGP protocol handle that? Well, that depends on whether we're talking about eBGP or iBGP. Everybody's okay with that term, right? External or internal, right? It's just simply who's my neighbor is what that comes down to. Is my neighbor external to my AS or is it internal to my AS? You can see that in an external BGP environment, I'm looking for my AS path. If I see my AS path, I know there's a problem because I shouldn't be seeing my AS path coming back to me. In iBGP, you can see what BGP, and this is directly out of the RFC. You know, this is not me sitting there typing it, this is directly out of the RFC. In iBGP, we're not going to redistribute routing information contained in that update message to other internal peers. If you worked with BGP, you know this is one of the early things that you learn about dealing with EGP is loop avoidance. But it's something that bears repeating in terms of understanding how BGP is going to work with NSX. Another thing that we need to talk about is the need to use filters. Notice, and this slide might be the one slide. I know I sat in a lot of the sessions, and man, the cameras come up, everybody takes a picture of the slide. Thank you, Jason. This might be the particular slide that you want to take a picture of. This probably summarizes the whole presentation almost in one slide. First, if you're going to do BGP peering, one of the most important things that you can do is to do those steps that I have listed there. Define what prefixes need to be announced. Use good summarization techniques. You know, good summarization techniques. Some of the people in the audience have heard me give a subnet lecture. If you're having a problem with summarization, I'll be glad to give you that subnet lecture on the side, teach you how to subnet visually. You'll never need a subnet calculator again. It's a little math trick. Where does that calculate in? That calculates into being able to summarize. If you can't summarize, you're going to have a problem. So make sure you do good summarization techniques. And lastly, you want to define filters at every eBGP peer. That's going to be important. If you don't filter, you can see, I talked about it can have some disastrous consequences. Why? Because you're going to get routes that you don't need into the routing table, and some of the routes are going to probably not direct traffic where you want it to go. Again, this is one of the more important slides of the presentation. Do not distribute BGP prefixes into an iBGP. Don't do it. I mean, think about what we're trying to do here. We're not trying to tell the VMs or the host that are inside of that iBGP, we're not trying to tell them all about the outside. We don't need to announce to them every route that's in BGP. We simply need to tell them where do they need to go to get out of that environment. All right, so if you have that mindset, that'll serve you well. Also, don't distribute IGBP routes into BGP. Again, same thing. I don't need to advertise to the world what my internal addresses are. I don't even need to advertise much beyond my next neighbor what those addresses are. And lastly, don't use an IBGP. Everybody's okay with IGP, right? Everybody knows what I'm talking about, Interior Gateway Protocol. Don't use an IGP to carry EBGP prefixes. In other words, don't do route redistribution. It's pretty simple. Let's take a look at some of the filters that you might need to apply. Those of you that did NSX, you raised your hand and said you were doing it, and you said you were doing it BGP. Did you apply route filters? They look like this at the Cisco level. So when you, I'm not going to walk you through every line, but when you look at this filter, we're essentially allowing one single prefix out, which is exactly what we want to do. We don't need to allow a bunch of prefixes out, we just need to allow that one. Next, coming in, this is a filter that's going to filter out all the prefixes except those that I want to come into my environment. You can see what those are: the 225.50.0.0 on the 16, the 61.237.64.0 on the 18, and then the 81.250.128.0 on the 17. Everything else gets denied. That's the type of filtering, coherent, understandable filtering that needs to be done to make BGP be efficient in your environment. If you're not doing filters today, when you leave here, go home and put filters in, please. It's going to make things a lot simpler and it's going to work a lot better. How can you verify some of this? Well, in this particular case, I'm logged into ESG. Those of you that work with BGP, whether it's virtual or physical, know what to look for, right? You're going to look for BGP state of established. All right, that's the word that you want to see there, is established. If I'm in the UDLR, again, what is it that I'm looking for? That word established. I think most of us came from a physical networking background. I know I did. This isn't any different than what we would see if we were doing this in a physical environment. It's still going to be established. We're still going to have a routing table. It's going to look like this, right? Everybody should be familiar with this, those of you that have a networking background. The 20 is the admin distance for a BGP-derived route. And you can see also by the B in that first column that it tells me that that route was derived from BGP. I wish I had a gift to give away. Anybody tell me what that C route means down there? Connected, absolutely. And it has an admin distance of 0, which is what we would expect to see. Notice that we're doing this, in this particular case, we're doing this from the UDLR, but you can also do it from the ESG. Last, let's take a look at what this overall picture now should look like. And this is right out of the VVD documentation. Remember, the VVD documentation is a two-site premise for that documentation. And you can see that we have our cores and we have our top of the racks. You know, if we look at the top of the rack switches, it says EBGP to the core. So that should tell you something. You can see, I don't know if the pointer will work. No, you can see right here that this has an AS number, and what's not written is yet a different AS number. How do I know that's going to be a different AS number? Because we're doing EBGP. Definition of EBGP is 2 different AS numbers. We're also doing EBGP, sorry, to the ESGs. So again, what's that tell you? That tells you that this AS number is going to be different than this AS number. Again, definition of eBGP. We're going to do default originate to the ESGs. Everybody should be comfortable with that, right? We're going to advertise default route to the ESGs, and then we may do some route maps to do some specific traffic steering. Everybody's good with route maps also, right? Assuming, right? Let's take a look at the ESGs. We're going to do, from an ESG perspective, we're going to do eBGP to the top of the rack. We're going to do iBGP with the UDLRs. So again, that'll tell you something about how you're going to break out your AS numbers. And then we're going to advertise a static summary route for those UDLR subnets. We can also redistribute the connected routes. And then lastly, if we go down and we look at the UDLR, this is where we're going to do iBGP with the ESGs. That makes sense. We're going to put a higher weight depending upon which site we want to favor. And then we're going to redistribute the connected routes and also deny the UDLR subnets between those two sites, right? All right, any questions from anyone? Yes, Melvin. Yes. Yeah, here, let me go back. So her question was timers. And here's the value on the timers. All right. What? I can't hear you.
Sorry, are those the recommended values? Because it says default values.
All right, so these are the default values for, say, your top of the rack switch. That's the default Cisco values. This is between the UDLR and the ESGs. And then this would be between the top of the rack, the Ciscos, and the ESGs. So obviously you're going to adjust your Cisco timers, and then you're also going to go in and adjust the timers on the ESG. Yes, those are recommended right out of the VVD 4.2 documentation. Again, that's what we're doing with BGP is because we decrease the timer value so much, we now make BGP much more of a higher performing protocol than maybe what it was before, where we waited 180 seconds before we declared something down. All right, any more questions? Great, thank you very much. Hope you guys enjoy the rest of the show. Thank you.
Hi, my name is David Klee, and this is Database, Virtual Disks, and You. So a little bit about me. I'm lucky enough to be a Microsoft Data Platform MVP and a VMware vExpert. I run Heraflux Technologies, a niche consulting company around how databases and infrastructure, and in this case is virtualization, really come together and in some cases don't play nice. We do a lot of performance tuning, and what you're getting is some of the consulting that we normally do, and you're getting it for free. There we go. Okay, first of all, let's start with the four main food groups of IT. So bottom line, there we go. The CPU, there we go. That's not working. There we go. CPU, memory, disk, and hopefully all of you are going to be on flash storage at this point, so may spinning rest in pieces. So all flash, and then networking. So the bottom line, this is really all virtualization is. It's compute resources and queues for how to get there. So what we're going to do right now, we're going to focus just on the disk. Here's the interesting scenario. When you get to all flash, is the storage the primary bottleneck to performance at that point? Maybe, maybe not. It all depends on how you're using it. But what we need to do is we need to go figure this out. Have you ever had a scenario where a DBA comes to you and says, the databases are running slow, it's always storage, and at the end of the day, they're showing you metrics that are just plain off from what you're seeing at the storage? This is real stuff. The problem is, You're both right. There's a lot of stuff in between the storage layer and the database layer. And what we need to do is really map out each one of these layers, because if any one of them are misconfigured or having challenges, it's a bottleneck. And from that point back, it's just going to stack up. And the symptom of this is high latency. So let's take a normal database stack. So database file, no big deal. We've got the database query engine itself. That actually goes and figures out where the thing is at on storage. The storage engine goes and retrieves it. We have to go through the operating system in order to do this. And in the operating system, we've got disk controllers. And in this case, SCSI controllers. Now, let's say you followed best practices and you want to use a paravirtual SCSI controller and we keep it off the C drive. There's your standard database practices. This is Microsoft SQL Server for an example. Operating system, data, logs, temp. Pretty standard stuff. So you follow best practices, and those are all daisy-chained off of the PV SCSI controller, and you still get anomalous performance results. The SAN is showing one thing, the database layer is showing 10, 20, 100 times higher. Why? Why are they so different? Well, you throw in a hypervisor in there and it gets even more interesting. So what do? Bottom line, we got to start monitoring this stuff. We got to start monitoring the placement of these things as well, because there's individual queues associated with all of these different options. So if I've got a database, a normal DBA practice is to start spreading out the workload. Multiple files. The files are organized into file groups. Maybe I'll have transaction logs in there. This is normal stuff from a database admin perspective in order to gain flexibility, ease of recovery, performance, things like that. Okay, well, at most, you've got 4 paravirtual SCSI controllers that you can use. In this case, I got 5 disks. What's going where and why? Uh-oh, we got transaction logs hanging out. If you start to go scale these things out, where do you put it? And now it all depends on the workload. I can't give you where this thing should go. But now, are things really heavily active on one drive at night and transaction logs are really busy during the day? Or are they really evenly balanced and we just need to pick one and start to gauge and monitor? So it's up to you. Monitor, understand your workload, understand what it's doing as far as just a good operational baseline, and you can start to balance and put competing workloads separated, put similar workloads or stuff that won't conflict with each other, put those together and scale them out that way. So now, what do we do when we see really interesting symptoms of all of this performance challenges? So let's take that diagram, let's kind of zoom in a little bit now at the hypervisor layer. This is what you have access to right now through ESX Top. So inside the VMware ESXi storage engine, you've got the virtual machine itself. VMware calls it a world. If you look at the disk metrics, you can find the G average or guest average. Our warnings for warnings and critical for Microsoft SQL Server and really anything OLTP workloads, 25 milliseconds on read, 10% or 10 milliseconds on write. If you can stay under those, chances are that the database workload is not really significantly storage bottlenecked and that performance is going to continue on as normal. At the virtual disk layer itself, you do have the VMware kernel that this thing has to traverse. If you find kernel time greater than 1 millisecond, something's not right, and you need to go drill into this. And then VMware has the perspective. It can actually see the storage at the other end of the connection. It doesn't know what's in between there, but it can actually manage this, and that's D average. If you turn around and take a look, this is latency at the device driver itself. With this, if that isn't even close to what the guest average is at, you may have a bottleneck somewhere inside the VMware storage engine itself. A lot of times, though, these particular things will actually be fairly similar. The VMware kernel time will be very low. And then the D average here will actually line up very similar to what the storage layer at the SAN, from their measurements, their point of view, is actually going to show you. You've also got the ability to track command aborts per second. If that's greater than really 0, well, something's not right. And we may have a faulty path, we may have something really wonky under the hood, and you need to go deal with that. Now, those are the symptoms. Now, what about the root causes of this thing? Guest disk queue length. Inside the ESXi storage stack, you've got the WQ length, or the world queue length. That's basically the virtual machine and all its dependencies. You've got the adapter queue length. You've got the device, basically per data store queue length. All of these different areas you can go track inside ESX Top and start to see if you've got bottlenecks inside these different layers. And then you've got any, so HBAs, network adapters, things like that. You can go track that from the switching layer. And then the storage itself, you do also have the storage queue length. which that's basically how VMware sees the storage. But again, you can take this and go to the perspective of the SAN and put the numbers side by side. If they don't line up, something's not right in the middle, and you can see what's in the middle there. It's basically your interconnects. It gets more and more straightforward the deeper you dive into this. If you want the specific metrics to go monitor for this stuff, at the virtual machine layer, it's the operating system disk queue. You've got the virtual adapter QDev. Inside the ESXi layer, storage VM kernel queues, and a big one, DSNRO, or disk sched num rec outstanding. Say that 3 times fast, right? At the HBA, you've got the per path QDev. You've also got the adapter QDev. And inside the fabric and networking, whatever you've got there, link speed, full duplex, half duplex, subnetting, all the overhead that goes involved there when latencies back and forth. And then the storage itself, you have the LUN queue depth on the storage, the latency at the disk pool once it gets out of the controller. You got the array service processors. Are they overloaded? How are those things doing? You got HBA target queues. There's just so many stacks and so many layers in here, but it's not as bad as it seems. There are some pretty common areas that we can actually go tailor and tune. So one, how many of you know about changing the pair virtual controller queue depth? So a few. By default, the LSI logic queue depth inside Windows has a queue depth of 32 and you can't change it. It's there for compatibility's sake, not necessarily performance. If you turn around and look at the pair virtual controller, you have a default queue depth of 64, so double the queue depth. But with a registry setting, which is right here, you can actually turn around and override that and bump this all the way up to 254. Do I recommend going all the way up that high? No. Do I recommend changing this until you go test? No. You need to test this and validate that in your environment, your storage layer and your interconnects and everything in between are actually able to accommodate these differences. Most of the time, if you're on flash or flash hybrid storage, I find a pretty good sweet spot at a queue depth of 128 here. But again, test this. Do not just blindly apply these changes because it may backfire on you. There's a KB article that shows you how to do this in both Linux and Windows. And what you're going to find is that in the event that you go change a lot of this stuff, it might not do better because there's one here that not many people know about, DSNRO. So let's say I've got 3 virtual machines. Now, you're following best practices. I got the C drive on the LSI controller, 32 QDEV. I'm using the pair virtual SCSI controller, QDEV of 64. Maybe I've overridden it, maybe I haven't. No big deal. Okay, so I don't want 1,000 data stores out there, so I'm going to turn around and put 3 of these on one data store. No problem, pretty normal, right? Well, disk sched num rec outstanding has a queue depth when multiple worlds share the same data store at 32. So if you've got high queue depth, low queue depth, there's an immediate bottleneck when these things are under pressure, a lot of storage activity, and this is well before it even gets out of the physical machine. So this is why you look at VMware, storage latency is low. You look in guest, say Windows Perfmon, storage latency is high. This is one really strong contributor to this. The good thing is you can go override this. You can override it all the way up to 256. Consult your storage vendor, because what you may find is that they actually may recommend in their best practices guide that you go change this stuff. In fact, there are a number of vendors here I know for a fact that they do. I don't want to name any names. Now, when you do this, you better have a really good baseline of what this stuff is doing, because as soon as you change that, everything around it is going to reflect the change. So the VMware kernel latencies, the ingest latencies, and even the actual load on the SAN, those may go up. The other latencies may go down, because now you're able to have a bigger pipe to get to the storage and you can do more with it. So baseline before, make the change, test, see how the system responds afterwards. Because if there's a queue further down the stack that may be a bottleneck now, you might actually see it with latencies that rise here as a symptom inside VMware. Keep it in mind, it does add up. This is why it matters. These are real numbers. And I'm not exaggerating when I say I had a customer that was fighting this kind of latency difference. They're fighting it for about 9 months. What we found was that, it was fascinating. The database layer was seeing over 50,000 long I/O alerts every night. And inside SQL Server, a long I/O alert is an I/O command that takes over 15 seconds to complete. 50,000 of these a night. The storage admin, everything's fine, go away. And the numbers that they were looking at were honestly really good. And I get brought in by the database team to basically be a punching bag, intermediary for this stuff. And what we found was that both were right. But in the very first meeting, they had been arguing this for so long, the storage person was so mad that they brought in somebody else to spot check his work, picked up a chair and threw it at the DBA. And if you've ever picked up one of those Herman Miller Aerons, they're actually pretty heavy. This guy was pretty good. What we found, DSNRO, HBA queue depth, switch queue depth. We went and cleaned them up, and the ingest latency dropped to match exactly what the storage latency showed. Here's the problem. They were both right. It all depended on the point of view. Storage consumption can bury you. And if you have ingest bottlenecks, it can trickle downhill and it can cause you a really bad day. I mean, not only that, but I mean, I'm not going to say the DBAs are, golden with this stuff. I mean, database administrators, developers, they can miss a lot of this stuff. I mean, for example, right here, this was essentially bad code. In this case, yeah, it was. So we're just going to blame the developer because we all kind of like doing that, right? So blame them when you have evidence. In this case, it was kind of interesting. The DBA missed the fact that the developer scheduled a job to run every second instead of every hour. In this case, the storage array was good enough to where it actually insulated it and nobody noticed. But if you see how it drops off at the end there, I wanted to say, it was actually in a training class. We were looking at all the measurements, and I go, what the heck is this? You got a spike a month and a half ago, and you're eating 600 to 800 megabytes a second for the entire last month and a half. And they go, ooh. So we get in and looked at it, and sure enough, we found it. Simple misconfiguration, simple oversight, and you can see at the very bottom, yep, we fixed it. It's what happens when this stuff matters. It's just interesting. So if you change the queue depths, if you watch and profile this stuff, all these things can change. Bad code, it's all the way from the top. Big problems. If you clean this stuff up, you clean up the underlying storage, you're able to use your storage much more effectively, and at the end of the day, you're getting what you paid for at the storage. The end user performance is better, the database layer performance is better, everybody's happy. So monitor your workload, go through these layers with a fine-tooth comb. You don't have to do it every day, but go through and look at this stuff because it really does matter, and these default options are just not good enough for demanding database workloads. If you have any questions at all about this in the future or down the road, feel free to contact me here. I'm an absolute geek. I love working on this stuff. Every environment's different. It's always a challenge, and I find it a lot of fun. Maybe I'm weird. If you have any questions, let me know. Any questions in the audience? Yes, sir.
QDEP setting, on one of the slides you had a QDEP setting, where was that change at? Where did you set that?
DSNRO? Yeah, the question is where do you actually go change a DSNRO setting? It's actually inside VMware configured per LUN. Yeah. Yes, sir. If you have dedicated LUNs and dedicated data stores, it'll actually retain the queue depth of whatever's coming into it. So in that case, you're okay. Do I recommend that? It's probably overkill and it's a lot to manage. Do you need it? If you've got that kind of database workload, yeah. If it's a really high workload, would I recommend it? Most likely. Just because of this kind of stuff, you don't really have to worry about it. For normal workloads, change the DSNRO, watch it, validate it, probably perfectly fine. Cool. We'll give it a wrap. If you have any more questions, I'll be right out here. Thanks for coming, everybody. This is a lot of fun.
Hello everyone, good afternoon. Thank you for everyone for attending this session. My name is David Santos. I'm a systems engineer in Brazil. I take care of network and security in Brazil. And if you guys are attending this session, it's because you guys want to know, like me in the beginning, how can we deploy microsegmentation in the easiest way, or at least find a way to start. So, the idea of this session is how can we begin from this side and arrive in the other side? Like, how can we change our architecture from a centralized file for a distributed file? This guy is another engineer down in South America, and he had this doubt too when he started. So he was like trying to find a way out here. So The first way the best way to start is to check or to find what's running in your infrastructure. So visibility is the key. You need to discover what applications do you have, what infrastructures do you have, what virtual machines do you have in your environment. A crucial tool to begin this journey is called VRNI. For this one that don't know what's VRNI, it stands for Virtualized Networking Site, and this tool is critical for us to make this change or to deploy microsegmentation. In this session, we'll explore VRNI and also how can you use it as a best practice to deploy our firewall rules. Okay, sorry. This tool is like a visibility tool and troubleshoot tool, and it also helps us to planning our microsegmentation. We can deploy this tool as a non-intrusive tool, and it will collect flows and information of our environment. It will do analysis of the traffic, and here we can find like what's the east-west traffic, the north-south traffic, also the traffic that's switched, which traffic is routed. It will also help us to map the applications. It will discover the virtual machines, the interconnection between them, and also the ports that are used to make this communication. After this analysis, it will help us suggesting the firewall rules that you need to deploy a zero trust architecture in our environment. It will suggest the firewall rules that you need, and it will also make analysis to check which rules are masked, or you will check the rules that you have that have overlapped with the other rules. The building block of these rules is what we call security group. A security group is something that helps you to create the firewall, your security policy. A security group can you can include almost anything in a security group. A security group can contain VMs based on their names, on the operational system, and the port groups that they are connected, or something that's really cool called security tag. A security tag is a metadata, and you can attach that security tag to any virtual machine. The idea is to abstract the IP address. Instead of using something like 10.1.1.11 and 20.2.2.12, you'll have like security group web and security group app. The idea of a security group is to have like a dynamically include VMs into that. So here you have like a security group web that will have any virtual machine that has the web security tag. And you also exclude anything dynamically. Like here you have a security group dev that has every VM that has the tag dev. And if that VM loses his tag, that security group will be updated to remove the information from that VM. It will also remove any information of that VM if it is excluded. So the rules that belongs to that security group will not be applied to that VM anymore. So taking a look with a security group, where should I start? In VRNI, we have something pretty cool called VRNI application. Here you can build your application, and your application will have tiers, and for the purpose of this demo, for this session, each tier will be a security group. So you have here the web tier. It will be like you become our 3-tier security group, as our security group tier web, and you have our application tier that will become the 3-tier app security group, and you have the 3-tier database that it will become the security group, the database security group. We will also make the interconnection between those security groups and applications. We will have the connection from the external network using HTTPS for the 3-tier web. We will also have the communication between web and app using TCP port 9000 and MySQL communication between app and database. We will also have catch-all rule. We have here a security group that will contain the other security group nested. And here we will configure out the full rule for that application. Allow or deny anything that doesn't match the other rules. For best practice, I always start that rule with allow and log. So anything that doesn't match the follow rules, I can look at the logs and then make the necessary changes for my application. Now I'm gonna make a quick demo here, looking how can we do that. As it is a video, it will work. For those, yes, for those that doesn't know VRNI, that's what the dashboard looks like. This is the plant security dashboard. Here on the left, we have something called entities, and here we can look what we have and also look at the applications. At this time, we don't have any application created, and we are going to create the first one. We call our application 3-tier, and we will also configure the tiers that will be inside that application. We start with web, and here we configure the membership criteria of that tier. We can select here a VM based in their name, or an IP address, or a VXLAN, or security group, and a lot of things here. For this demo, I will do something like custom VM search, and I will create like a regular expression to match a membership criteria that I want for this application. I will start with the port that application uses, that's HTTP port 80. And here I can check which VMs match that regular expression. In this demo, it will match 4 VMs. Even our center is matching that, but we don't know that. We don't want that. We want only the VMs that belongs to that application. So we are going to refine that rule a little bit more using the VMs that has port 80 active and also are connected to LS Web, our logical switch that is serving network to that VMs, to that application. Here I created a Boolean rule, and I will check what is matching. Now I can see that I have a web tier that has communication from external network and also communicates with something else inside my data center. That's my app tier. It will communicate with the app01 VM at port 9000. Now I will add another tier to my application using that information that I just discovered. I'll create now another regular expression using incoming port 9000 and VXLAN LS app. We'll check now that we have the app01 VM here. Now I will add another tier, that's the database tier. And I'll create the same rule for database using now the MySQL server, MySQL incoming port 3306 and LSDB as my VXLAN. After that, I can analyze the flows and check here my application. So you have the full communication of that application. If I click inside any of those arrows, I can check the incoming flows and the interdependence between them. And here I have the recommended firewall rules for each one of those tiers. That's the communication between web and app. That's the communication of app. Here I have the recommended firewall rules for app, the app tier. And lastly, we have the firewall rules recommended for the DB tier. Is the service of our DB tier, the external service access for that tier, and the recommended firewall rules. After create that application, we will now begin to deploy the firewall rules. So the first thing that we will do now is the rules exporting. So going back to this screen, we're gonna click here in this menu and export rules. We are gonna export all the rules that you just see for that application. We are gonna create a DFW session in NSX for that application and set the last rule as allow N and log. Here in NSX, we're gonna create our firewall section. Create a rule for that session. And configure the allow log. This log you can check later in log insight to see what will happen. We're going to apply that default rule only to the logical suites that you have our VMs of that application. Now we are going to import that rule. Here we are using a tool called NSX Importer. So this tool is a PSO tool that you have, but you guys, if you want, you guys can have this tool too. It will import that exported the firewall rules into NSX automatically. It will import the firewall rules, the security group, the security tags, and as is an XML file, we can also make changes to that if you want. Here you have our firewall rules. Our security tags. This tool is a JavaScript-based tool. So here we are gonna run this tool, selecting the NSX manager IP address, the section, username and password, and it will deploy all that rules into NSX. The only thing that the tool doesn't do is the mapping between the security group and the VM. All the rest is imported into NSX. We also can remove security groups and firewall rules from that folder that you just saw to select what will be imported into NSX. Now we're going to make the VM to security group mapping. We see here that we have a security group others, and we also have a security group web. For the purpose of this demo, I already made some mapping, like the security group web, the VMs already have the security tag mapping, and the security group app and security group DB2. We can see here the security tag already applied to that VM. And that VM already belongs to the security group. The same thing for DB and app. Now we are gonna add something new to existing security group. We are gonna make changes in the security group others web and DC virtual. In the external internet, we are gonna add our local network as membership of the security group, because it's the where I'm doing tests in this application. Here I'm gonna add an IP set. An IP set is like an IP address or subnet that you can add as an object into a security group. We will also add a VM to DC virtual. In this case, is a DNS. My DNS VM, I will add to that security group. And automatically, the firewall rules, the existing firewall rules using those security groups will apply the necessary policy change, security policy. You can see here the VMs in each security group. And in the last part now, we are gonna monitor what is happening and make the last adjustments. We're gonna generate some traffic here to the VMs, like SSH traffic and ping, and check what's happening in the firewall rules, look at the login site, and make the necessary changes. Here I'm doing an SSH to the web tier. I generate two connections here. And after generate this traffic, I go to login site. I will log into login site. By the way, everyone that has NSX can use login site for NSX and for vSphere. Here you can see the firewall dashboard in login site, and we can select which ports are matching our firewall rules. Here you can see that the traffic that we just generated is this log here. The communication between my station and that VM. Now we are gonna change our firewall rules. We will add SSH to the first rule, and after that we are gonna change the last rule to block. So now we have the full application running microsegmentation. Here I put the service in the wrong rule. Now I'm gonna add the right server to the right rule, allowing SSH. And change the last rule to block or reject. We have two defaults here. We have default for the session, and we have default for the whole NSX. This, for the session, it was open, and then we closed it after refining the rules. Now we're gonna make some tests using ping, and you can check that the ping is not allowed. And that's it. We just made this whole application and change the last rule here to block the unwanted traffic. For the ones that want to try VRNI, there's a hands-on lab. The last year hands-on lab was the 182901 net. This year probably will be 1929 something. And it's also possible to download that at VMWorld.com. So you can go to this website, VMWorld.com/go/VNA-field, and you can download VRNI to deploy in your environment. The only thing that is needed to that to work is VDS, only the distributed switch. You don't need NSX to run VRNI. You can deploy VRNI before NSX, during the NSX installation, and use VRNI to refine your rules after an NSX installation too. Questions? Oh, so? Yeah. No, they were in 3 different subnets. But it could be in the same layer. No problem. You can microsegmentation. You can do microsegmentation in layer 2. It will also be possible. More questions? No? Okay. Thank you, guys. Hello, everyone. Thanks everyone for watching this session. It will be a little hard to compete with those guys in the side, but I will do my best to speak loud. Okay? This session we'll talk about SD-WAN. We make like an overview of this technology and what this technology can provide us. Why SD-WAN is getting so much traction? Why people are adopting this technology? Basically, what you need to do is analyze what's happening with the applications and with the world. So if you take a look in like an enterprise company, like a retail company, they need to increase their revenue. The way that they need to increase their revenue is open new stores, open new shops. It's hard to listen, right? Ariel, can you?
We're finishing off this day. We're grabbing beers. Oh, I see. Oh.
Yes.
Oh, you're getting yes. Yes. That's what we give them a round of applause, everyone.
Try. Is it better? Is it better now? A little bit louder. Okay. Can you guys hear me now? Oh, amazing. So. Let's take a look in the market today, in the enterprise market, and check why SD-WAN is so important. So any company that has remote offices or remote locations have challenged to open like new stores or new offices and this kind of thing. If you take a look in retail, they need to increase their revenue, open new shops, and open like new stores. Every time that they open new shops, they need connectivity, firewall, MPLS links, infrastructure to open that shop. And the time to market to open that sometimes doesn't go along with their needs. So they need to find something that's quicker, that's faster to open that shop. Another challenge that the companies are facing is the application migrating to the cloud. In the beginning, we had like on-prem applications, and you had like a private link to connect the remote location to the application hosted in the local data center. So with like Office 365 and cloud and everything going out the data center, we need to change the way this application is consumed. And now we cannot have like an MPLS link there. And we need to provide quality and assure the application will be available no matter what link is being used. In this case, a broadband. So you need to provide security and quality in a public link instead of provide like a quality link that was small, like an MPLS link, but it had like quality. This is one of another challenge that the companies are facing. And the third challenge the company can face is like the maintenance and day two operations. So it's very costly to have someone qualified to like solve a problem or solve an issue in a remote location. So every time that they have a problem, they need to send someone there, like to fix their router, to fix their firewall, to fix a WAN optimization, and this kind of stuff. Take a look at all these challenges. We are gonna see how NSX SD-WAN that came from a company called VeloCloud that was acquired by VMware last year can help us, okay? So the main benefit of this technology is to use any transport as a WAN connection. You can use an MPLS that was used before, you can use an internet, a 4G, a 3G, and you can use all of them together. You also can guarantee real-time performance on the critical applications. It's optimized to cloud service and SaaS applications, so you can provide quality and security to the access to an application hosted in the cloud and not more in the local data center. And it also reduces the TCO. It will reduce the TCO by reducing the CapEx, the OpEx, and deploying the necessary infrastructure quicker. Here we're gonna see a quick video showing how to deploy a remote location. I did this last night. I built a lab in my laptop and I create a remote location very easily. Basically, we deploy what we call a VeloCloud Edge. That's like a virtual or physical appliance. We select like the type of the appliance. We send an activation link, and anyone in the other side just open his email or her email, click in this link here that's showing, and that's up. That location is already deployed. It will download all the configuration from the orchestrator, that's the management control. And now we already have like a WAN connectivity between the data center and the remote location. Here we can see that this edge is located here in Las Vegas, and after a few minutes is already ready to go. It will recognize all the WAN links automatically, and it will also make like a network test to check what's the bandwidth available in those links. What else it has? It has an algorithm called DMPO, Dynamic Multipath Optimization, and it will help us monitor the flows. It does it per packet, not per flow, but per packet. It has an SLA that you monitor latency, jitter, and packet drop, and it can like transport or steer the packets on real time, packet by packet. It will use all the links available to do that load balance. Something that's really cool is like you can make like a voice call, and if your MPLS link or your primary link fails, it will switch automatically, and you wouldn't even notice that had a fail in those links. Here we can see that even in a single link location, that's this case here that I did in my laptop, we can see that the protocol is correcting the problems that it's facing. It has a lot of jitter, it has some packet loss, but in the end, the quality of experience, the quality of the traffic that the user is receiving, it's enough. It's very good actually. And you have these controls for voice, video, and transactional. You can see for the video, like for real-time video, it does a lot of corrections and it's pretty good actually. And for transactional, it's TCP, it will correct, but you cannot like see all the benefits like if it was a real-time video and voice. It will also look for the applications. It gives you the application that are using the bandwidth, the source, the destinations, and everything that's passing through that edge. Here you can see like a QoS that it uses, and we can see how much traffic is being used for each priority row. This algorithm, DMPO, I will show a short video here showing how the user will see this technology working. So we have here in the right, no, in your right, location with VeloCloud, and in your left, a location without VeloCloud. Both locations have two links, one MPLS link and one internet link, and we will inject, we'll do a test where we will drop 2% of those packets in both locations. While in the VeloCloud or NSX SD-WAN location, we can see like the video is not impacted. We can see like in the non-VeloCloud sites or in non-NSX SD-WAN location, we can see like the video quality is really poor, and it will like impact VoIP and like conference and other applications like SharePoint and applications that you need collaboration. What else? Something that's really cool about this technology is that we can make policies from a single location that's called orchestrator, that's the single management of the single point management, and you can create like what you call profiles. You create a profile and you can apply that profile to many locations, to as many locations as you want. And here you can configure something that's a business policy. You can set the source, the destination, and choose the application. Here you can choose like Office 365, or you can choose SharePoint, or you can choose Zoom, Facebook, Skype, whatever. And we can select how that application will work on top of my connections. If you use like a multipath, or you use like a single link, if you use like MPLS link preferably or mandatory, or if you use a public link, or if you use like 3G or 4G, if you try to correct the application before do the steering, you can change the DSCP if you want. And something that's really cool too is that the solution also comes with a firewall. It's a stateful firewall that reads to the application. We can set the source, the destination, and also the application. Here you can select like Facebook, but it's not only Facebook. If you can select like Facebook embedded video or Facebook message, and you only discard or drop that application, that sub-application.
All you people sitting out there on those tables, get in here
And
it's time.
here we have the SD-WAN architecture, the NSX SD-WAN architecture. We have on the remote locations what we call VeloCloud Edge, that can be a virtual or a physical appliance. We have in the data center other VeloCloud Edge, but we can have a cluster here to provide HA. We can also have a VeloCloud Edge in a VPC, an Amazon VPC, or we can use something that's called VeloCloud Gateway. That's appliance. That's a VeloCloud appliance that you can use like with your. You can use to make the one connections between the locations automatically. That VeloCloud Gateway can be used to also connect to a non-VeloCloud site. So if you have a location that only has a firewall and you want to make an IPsec VPN between that location and a location that has a VeloCloud, this VeloCloud Gateway will do this translation. And to manage everything, we have a VeloCloud orchestrator that can be hosted in the cloud, or we have some customers that has a VeloCloud orchestrator on their infrastructure too. To end this presentation, it's possible to make a try using hands-on labs. It's a brand new hands-on labs that we have. It's the 1940. If anyone is interested to try it on, and if someone wants to learn more about the technology and to discuss more, we have I know the engineers that are based here in West too, and you can talk, and I can give you their contacts too. Okay? Any questions? I have 1 minute. Sorry? Mm-hmm. By business policy. The question was how we can do like a content filter and select what goes to internet and what goes like to data center. By business policy. You can select that by business policy. Okay. Any questions? Okay. Thank you, guys. I appreciate it.
So thanks for everyone to coming out to the vBrownBag presentation. My name is Demetrius Malbrough, and I am a technical marketing engineer at Rubrik. And I will be speaking to you today about building relationships the podcast way. So hopefully you will have an opportunity to learn something new in this session. And I will go ahead and jump right in. So one of the things and one of the issues that we have being in technology is that there's so many ways and so many things that we can actually think about and so many things that we can actually do. There's a competition for our mind, and most of us have a hard time really trying to carve time out for certain things or some of the things that are most important to us. One of the things right now is in the news, there's so many issues and problems. You have cybersecurity, cyber war, you hear about ransomware, not to mention some of the political news. It's just draining, all of our times. You can literally spend an entire day following what's happening just in politics alone. And if we have any sports fanatics in the house, I don't even have to explain this category, When football season has just kicked off and you have a lot of football fans and basketball fans that are out there, and that really consumes a lot of our time. So you don't have to worry about me spending my time in that category because I kind of gave up on sports a long time ago. Technology skills. So as a technologist, most of us spend all of our time here. So we have problems trying to manage our work life, managing home and managing work, and we just spend too much time in this category. And sometimes we really spend way too much time in maintaining our skills and really trying to branch out from just the technology portion. And family, this is a really, really important function and category that we all have to learn how to schedule our time in, right? Family is very important, and this is definitely a category where most people, either you're spending quality time with your family or you're not. So where is your focus today? And trying to divvy up your time between your mental health and your spiritual health can be a challenge. Also, your physical health, taking time out to exercise, eat right, drink enough water. It's a lot of things that you have to remember that you need to do on a day-to-day basis. And they also say that you need at least 6 to 8 hours of rest. Me, myself, probably average 4, 5, or 6 hours, but that is a really important category that you need to make sure you pay attention to. And career, once again, some of us spend way too much time in this bucket. There shouldn't be too many 10, 11, 12-hour work days, but sometimes it happens. But every day for 1 month, that could be a little unhealthy. And these three, trying to focus on learning new skills, because there's things like IoT and big data and artificial intelligence. There's just so many things that are out there, right? But one thing that I really would like to talk to you today about is networking and branding yourself. It's a part of building a relationship. And I'm going to share a story with you as well. But at the moment, the shift happened for me once I started really building relationships and thinking about utilizing podcasting as that platform for me to reach out and expand my brand. So I got out of college in 1999 and I was a backup support engineer for IBM. I spent quite a bit of time here. I thought I did really well landing a job working for IBM, but after a year, I really started to understand taking phone calls and dealing with technical issues was not something that I wanted to do, for the rest of my life. So Monster.com had just popped on the scene. I don't know, we don't have any young people. So you were on Monster too, I see. Okay, cool. So I went out on Monster.com, I created a profile, and I started getting all of these recruiters pinging me, hey, you want to come work for $50 an hour? I'm like, sure, yeah, let's do that, right? So I became a consultant. I left IBM and I started traveling around doing backup implementation at multiple customers. And I did that for quite some time. So about 10, 11, up to 14, 15 years, I felt like I was getting static, right? I felt like I had hit the glass ceiling. I wasn't really moving anywhere. I was still in backup and recovery. I wanted to maybe go into management, but things were really changing really, really fast. And so I decided that I would start a podcast. And I didn't know anything about podcasting, and so I used Google to just go out, how do you start a podcast? And it was pretty simple. So one of the most important things is that when you're launching a podcast, you really have to strategize, what you name your podcast, what's going to be your topic, things like that. So I'll go through all of the steps that I used in order to get you from step A all the way to the last step, it's just Z. So before that, the podcast that I started, which is called Data Protection Gumbo, I started building some very fantastic relationships, right? I was meeting CIOs and VPs of sales and just of marketing. So I really started branching out and inviting individuals onto my show to talk about themselves. So the format that I like to use is an interview format where I bring individuals on the show and I ask them specific questions that are related to data protection. And they seem to really love, coming on the show, and they spend all of their time talking about themselves or their products. And the podcast that I created actually landed me the job that I'm in right now. I'm a technical marketing engineer, but I started as a support engineer at Rubrik for 1 year, and then I moved over to marketing. But this is how I landed my job. I built some great relationships in multiple different companies, and I saw Rubrik, and it was a fantastic place to work, and that's exactly where I landed up, and that's where I am today, truly enjoying myself. So how are you building your relationships, right? And I'm sure some of you have had ideas of how to do this. And today we use social media to go out to, you may use Twitter, you may use LinkedIn. And LinkedIn was one of my platforms of how I actually made the connections to reaching out to certain individuals, because a VP or a CIO necessarily will not respond to you unless he knows that there's some type of value prop in it. So when you mention, hey, you want to be on this podcast, sometimes they say yes. Another way to build relationships is attending events, kind of like a VMworld or any other type of conference. That's one way to build relationships, and also the old-fashioned way is like mentoring or one-on-one relationships. You see that less and less today because we're living in a digital world, and most people just really go on social media and utilize those platforms. But they're great platforms to use, but you still have to have that human touch involved. Some of you may be blogging, right? Or creating your own website. That's also a great tool that you can do in order to build relationships. And some of you may like to record YouTube videos. That's also another fantastic way to do it. But to go ahead and give you the steps of how to build relationships the podcast way, this is how I started. So I took a lot of time to sit back and think about a crazy name, a catchy name, one that would actually draw the attention of anyone that would ask me, okay, what is your podcast about? So I decided to name it Data Protection Gumbo. And the reason for Gumbo is that I not necessarily want to just talk about data protection. I would like to talk about everything that data protection touches. So no topic is really off limit as long as we loop data protection back in, because like I said, everything is digital now, so it's kind of hard not to talk about all the data that's coming in and being able to protect that data. So some of this may be obvious, but you need a topic, whether you're going to do audio or video or both, and what type of format. Like I mentioned earlier, my format is the interview format. So I bring individuals on and I ask them a set of questions, and I let them talk about their product or themselves. The second thing that you need, of course, is equipment, right? That's the microphone that I started out with. You can get a microphone. That microphone was about $50, which was really cheap. It still does exactly what I need it to do. So I have yet to upgrade my microphone, but there are, you can go up to the thousands of dollars if you would like. So a microphone is very important, just making sure you have a quality microphone. That one gets the job done. It's called a Blue Snowball. You can find it on Amazon probably for 60 or 70 bucks now. I think it's gone up over the years. And you also need a recording software. And the recording software that I use is called Cubase. And it's very complicated to use because I have a brother that is a music producer, very small-time music producer. And he uses Cubase, so he convinced me to use Cubase as well. So there's definitely like Audacity out there. Audacity is very simple. I think it's a free software that you can use as well. So that's another one. And step 3, recording and editing your podcast. These are the 3 tools that I use, software that's called Pamela. And Pamela records the audio for you, and it also plugs into Skype. So primarily, because I talk to individuals all over the country, from Australia, I even had one in Africa, several in Europe, and the easiest way, free of charge, is of course Skype. So I use Skype, and I started also using YouTube as well. So you can actually, after you export it out as an MP3 format, you can upload it to YouTube. And having a catchy title and a topic for each episode is also very important, and making sure that you are able to, drive individuals to your website or your podcast, because once you submit to iTunes, which is like one of the top leading podcast platforms, is you have the capability of being ranked. And I'll share another story as well. So my very first review and comment on my website was a negative comment. Some guy created a profile and he said, yeah, you only get a one-sided review or response from this guy. Don't listen to this podcast. So I spent just a little bit of time really trying to figure out why, someone would come on and, make a remark like that. But I quickly bounced back and I created, 15, 20, 25 more podcast episodes. So I mentioned that just to tell you that you're definitely going to have your haters, right? They're always out there. And if you have one, that means that you're doing something right, okay? All right. Step 4, social media is definitely useful. And I use LinkedIn like a champ, okay? So I created a group called Backup and Recovery Professionals on LinkedIn, and I think I created it back in 2008, and it's over 20,000 professionals that's in that group right now. So that's another platform that I leverage to market my podcast. And you as well can create a group on LinkedIn or something similar of whatever your skills and abilities are in order to kind of create an area that your peers can go to actually communicate with you as well. So that's another platform that I used on LinkedIn. And I think I have over, several thousand connections on LinkedIn as well. And I am guilty for connecting with people that I've never met before. So sorry about that, but I really like to connect with individuals, and building relationships, especially on LinkedIn, is a way that you can actually meet people in multiple different countries around the world. So I would connect with someone and use the personal invitation, and I would actually, say, hey, I'm starting a podcast. I would like to have you on the show. It would be great to connect with you. And I would send it. Maybe 90% of the time, no one responded, but that 10%, it was a quality connection that I could actually use to have someone on the podcast. Then we would exchange, mobile numbers, and then we would have exchange emails as well, and then start building a relationship from that perspective. Also, each episode ranges anywhere from 15 to 30 minutes. If you go over 30 minutes, then you kind of lose people's attention. So I try to keep it less than 30 minutes if possible, because it's kind of the sweet spot that I found. And the last and fifth thing that I like to do is to show you how to launch the podcast. And after you've created all of these things and you've gone through these steps, you've identified your audience, and you've got your equipment, you got your editing software, you're using Skype or whatever, you've submitted it to iTunes, and you're on social media. So now the final step is to just launch your podcast. I like to have at least 2 or 3. Some people like to have 5 or 10 different episodes already in the queue to release. But I guess I'm not doing as well on my my work-life balance, because I hadn't released an episode in over a month. So, forgive me for not doing that. I definitely will have one out next month as well. So just to kind of wrap things up, if you definitely feel that you need to get out and network with individuals, podcasting and building relationships by creating a podcast is definitely a way that you can have friends all around the world. And I have CEOs and CIOs, in my contact list, and I texted a CEO a couple of weeks ago, and he responded back, hey, Demetrius, how are you? I hope you're doing well. And we kind of exchanged dialogue about, VMworld. He thought he was coming, but he was unable to come. But, just really connecting with individuals that can actually act as a mentor or as even a friend. So it's definitely a way to get your message out there worldwide. And that's building relationships the podcast way. I'm on Twitter at @dmalbro, and the website for the podcast is Data Protection Gumbo. Thank you very much. Any questions? So, why are we intrigued by superheroes or individuals that appear to have superhuman abilities. I mean, we spend millions of dollars flocking to movie theaters and actually flocking to movie theaters and purchasing memorabilia, coffee mugs, t-shirts, and even action figures for our kids. But one thing that I'm here to do for you is to change your perception. And the perception of yourself and the perception of how you view others. So let's do a quick perception test. Everyone ready? All right. Look, it's a bird, it's a plane, it's Superman, right? But on May the 27th, 1995, Christopher Reeve suffered a traumatic accident. He was thrown from his horse during an equestrian competition, and he was forever left as quadriplegic. However, there was a fantastic quote that he had, and that he was an ordinary individual who had to find the strength in order to persevere and endure in the midst of his overwhelming obstacles. So from that day on, we all viewed Christopher Reeve as being an ordinary individual, and our perception of who he was forever changed. Now, what's your perception of backups? It's not that good, right? Or maybe it wasn't that good. But I'm here to give you a formula that your perception of backups, coupled with the right technology, will catapult you to being the hero of your environment. Now, a quick story about myself. My name is Demetrius Malbrough, and of course, I work for Rubrik, and I'm a technical marketing engineer. But before that, in the early 2000s, I was a backup consultant. So I traveled all around the United States, implementing backup software and hardware. And one day, Larry the sales guy called me, and he said, Demetrius, I want to give you your next assignment. But instead, he goes on to tell me, this next customer, they knew you by name. So I was a little surprised that they actually knew me. And then, this last statement before he hung up the phone, he said, it's like you're becoming the Michael Jordan of backups. So I really appreciated that comment, and it got me to perceive myself as a backup administrator and a backup consultant a little differently. So on the plane ride home, I began to analyze my skills and my abilities. And what I did was I took all of the skills of a backup administrator and I categorized them into 3 buckets. The first bucket is the build bucket. Now this is, as a consultant, this is where you actually go in and you rack and you stack, assign IP addresses, you do all the planning and the configuration. You set up the backup schedules. You spend a lot of time here. But my days as a backup administrator, I spent a lot of time in the monitor category. So just monitoring all the backup jobs, the failures, everything that goes with managing a backup environment. There was a lot of pain here, right? And here's the secret. I did promise a secret. The secret is that every backup administrator at one point in their career will tell their spouse or significant other, you know what? I'm quitting tomorrow. Or I can't do this anymore. Or maybe I want to get out of the industry altogether. I know I did that, but I'm still here, right? So the last category is maintenance. This is where you spend all of your time. It's very time consuming. There's a lot of complexity here. So maintaining all of your storage, all of your backup servers, maybe even your tape libraries. It's very painful, very stressful. And I remember spending a lot of time in this category. So complexity is very real. And as a backup administrator, you see this every day. But what if I told you that all of the components that you see here, especially the ones that have a red X on them, I can get rid of those components for you in a simple scale-out cloud data management fabric. But is your current backup technology making you look like the villain in your backup environment or your IT organization? Could very well be true. So what if you have a database crash and you can't recover for some strange reason? You may very well be viewed as Eric Killmonger, right? The enemy of Black Panther. What if you want to pull something from the cloud, but you got to pull the entire image back? You just need one file, but you have to pull back the entire thing. You could very well be viewed as Mandarin. You guys know who he is? From Iron Man, right? But most importantly, ransomware is running wild today, right? What if there's a ransomware attacking your environment, laying redundant for months, and all of a sudden, 10,000 or 100,000 files are encrypted? You're called upon as the backup administrator, and guess what? You can't recover. So you will definitely be the joke or the joker of your environment. So with the right technology that will allow you the scalability and automation that you need, you can be viewed too as Black Panther, right? Scale out architecture, giving you a global namespace and a distributed file system. One that is self-healing, in case there's a resilient node failure or multiple disk failures. It keeps on running. And something that's API driven with automation. Every click in the UI is an API call. Something or the right technology to give you hybrid cloud mobility with the ability to move data from on-premises to off-site or store that data in the cloud and able to move that data from location to location. One that gives you a cloud out functionality, allowing you the ability to archive data off to a cloud storage repository. One that gives you a cloud on capability that allows you the ability to launch apps for DR in the cloud or move apps from cloud to cloud. Most importantly, the right technology will provide you with security and immutability, giving you end-to-end encryption of your data at rest and also in flight. One that allows you to not only detect ransomware through a machine learning functionality, but to analyze that data and allow you to recover quickly. One that gives you a role-based access control or multi-tenancy to separate, let's say, your SQL database administrators from their virtual machines. They only have access to that. That capability will be able to give you that logical separation that you need. So that right technology is Rubrik. And being able to free your applications and to free your data from the underlying infrastructure. So think being able to send your data that's on premises out to the cloud, any public cloud, AWS, Azure, or Google Cloud. One that allows you the capability to not only back up, but to archive out for disaster recovery purposes, and to also give you a Google-like search functionality with an HTML5 interface. That technology, ladies and gentlemen, that will change your perception forever of backup and recovery is Rubrik. Thank you for your time.
Hello, everyone. Thank you for coming. It's great to talk to you. My name is Doug Chamberlain. Work here at NetApp in product marketing. And today I want to talk a little bit more about really bringing yourself to success with end user computing, right? Getting past the virtual desktop. Talk a little bit more about how NetApp HCI has a little different platform that may help you with that project. When we look at end user computing, we know that we have some business challenges, right? We know that management is going to give us these very tight deadlines. They're going to ask us a little bit more about why we're dealing with all these independent platforms. Why do we have all these different support contracts? All the complexity that's involved with actually delivering to what management is trying to do, right? They're trying to look at how they can add more, what they can do to actually bring more to the business and actually have all the applications that the end user needs right next to all the virtual desktops. But certainly there's some challenges there from a technology standpoint as well. So not only do we have these management challenges that we're trying to resolve, we also have these technology changes. We know that as we're trying to add a new application to our existing desktop environment, that can be very tricky. A lot of re-architecture may be involved. I know that I've tuned my pods to work for a certain type of desktop. Now you're asking me to add another type of desktop. or a database or an application. There's a lot of re-architecture that we may need to have to deal with that is time consuming and difficult. And we also know that as we're adding these new workloads, if we add them to existing platforms, sometimes there's a great deal of resource contention. And so now we have to worry about these new workloads consuming existing resources. What happens when I have this going on? I know the management is really excited about us being much more fluid, much more agile, really delivering better environment for our end users, but it gets very difficult from our side as technologists to keep up with that. At NetApp, one of the things that we've seen over the years working with virtual environments is that storage is often one of the big complexities that keeps us from being able to move forward. So what we want to talk about a little bit more today is what's going on and how what we've done at NetApp with NetApp HCI really does give you that operational simplicity that you need to be able to stay ahead of those projects, to be able to scale and keep up with the new things that are going on, to be able to respond to your end users, and more importantly, to make sure that those performance issues that you may have as you're growing your environment, as you're adding new desktops, as you're adding databases, those homegrown applications, to be able to make sure that the performance is predictable across all those new applications as well. So stepping back a little bit, let's talk about what we're doing, right? I mean, we're trying to get to a much more of a private cloud-like experience, not only for our users, but for us as well as managers, to be able to actually have a system that will scale with us very easily. As management asks us to do new projects, we want to be able to grow that platform, easily scale out. With NetApp HCI, what we do uniquely is actually scale, compute, and storage independently. Because I think we know as we're adding desktops, we don't need a lot more storage because we're doing link clones, or we're doing something that really doesn't require much more than a lot more computing power. But then there's new applications or new databases that we add that are going to give us more data, and we need to be able to just expand our storage. With NetApp HCI, we've designed it to be able to scale non-disruptively in either one of those dimensions. It gives you more flexibility to better respond to exactly how you're going to grow this end-user computing environment, supporting more and more workloads. And one of the challenges we know with doing this is, how are we going to grow at the storage layer as well as the compute layer? Right? We've been doing this in VMware for years as far as being able to add new compute to our existing environment, but the storage sometimes gets to be complex. And with NetApp HCI, we remove that complexity, scale out very similarly. When we're adding new nodes in the storage side, we're growing that pool of availability that we take from. Just like we would at the compute layer, we're going to do the same at the storage layer, which really gives us some great opportunities to be able to grow and to grow easily, right? We're trying to eliminate that complexity. When management asks us to do something, we're trying to be able to respond quickly. By growing a single pool of storage, it does help us on the storage side to be able to do that. Now, the other thing that we know that's a huge challenge with end-user computing, and especially around doing virtual desktops next to things like databases, is at some point in time we're going to have a boot storm, and that may overtake a lot of the available resources, right? There's never a DBA that likes to know that a desktop is going to run next to their database, right? My database has to be up, it cannot go down, I'm not expecting it to go down. You've put desktops next to it, and all of a sudden, everybody turns up for work and my database starts going downhill. My other applications start going downhill, and that means trouble tickets for you, right? The DBA starts calling you, the end user starts calling you, right? Applications aren't being responsive. What's going on? That's not something that is going to help you be successful building out an end user compute environment with mixed workloads. When we looked at how we could do things a little bit differently at NetApp, with our NetApp HCI, we're actually allocating the backend storage resources independently for each one of those applications. Every time I'm adding a new workload, I'm not only giving it the compute layer specifications it needs, but the storage layer as well. How much storage space do I need? How much IOP performance do I need out of that storage? And each workload is going to be isolated and protected from each other. So instead of having that big spike, that big downturn, that big resource contention issue from that noisy neighbor, I no longer have to think about what do I have to do to resolve that. I've actually preemptively set myself up for success. I've looked at my resource availability, I've allocated the resources properly, so every time I'm adding a new database, every time I'm adding a new desktop, every time a new homegrown application comes out, each one of those new workloads is going to have its own protected level of performance. And I know that I won't be dealing with any of this interference because each one of them has been protected from each other. By giving them their own resources, we help you get to that optimal experience. to be able to fire up those new desktops, to move from engineers from their physical to virtual, to help make sure that I'm expanding my call center, to make sure that all my new databases or my new applications all have the performance that they need to give the results that I'm expecting. So when management calls and says, I'm ready to do something next, I'm ready for those new projects, I want to push end user computing forward, what we hear is, I can do this. I know that at the end of the day, every new project I'm going to be incrementally able to scale. I need more compute, I'm going to add more compute. I need more storage, I'm only going to add more storage. I know that I can shape exactly what I'm delivering from a platform to the exact needs of the business. When I look at that as well, not only am I eliminating the storage migrations, taking a lot off my table, right? Eliminating the effort that I have to put into building this system out, I also know that the end users are going to get the results that they need. I'm able to deliver each application very predictable performance. When I think about the challenges of moving to VDI, what I've done to create these different pods for each desktop and the databases and the applications all sitting on different platforms, those are kind of going away. Now I have the ability to, in a single platform, deliver predictable performance for all these various applications. Each workload will work as expected, as predicted, exactly what we need, and anytime I want to make those changes, I can, because I'm doing it on a single platform. All of these features are going to be accessible through all of my VMware tools. I just go right into where I'm comfortable, whether I'm going all the way through vRealize operations, I'm using Log Insight, I can use those tools to be predictable, to be ahead of myself, or I just go into vSphere and provision what I need. So all this means that we can do something different for this move from VDI to end user computing. When we're trying to add more desktops, we're trying to add applications and databases, I now have a platform that has been designed to grow with me, eliminating some of the headaches that we've had in the past, trying to actually address the needs of this end user computing initiative. So we're happy to really talk to you about this because at NetApp we're very proud of what we've done to give you that next generation end user computing platform. Thanks so much. Appreciate your time. Any questions? Yes.
Hello, my name is Edward Haledke, and I'm here to talk about what's next, Security 201. So this starts when you've already applied the security configuration guide from VMware. What do you do next? Anybody? So the security configuration guide has multiple profiles in it, and you've got the DISA-STIG, which has multiple profiles in it. You apply those, and now we got to figure out what we're going to do next. So what we know is that we have bounded all our management and hypervisors. That's what the configuration guide in Security 101 does. We have our ESXi surrounded by our management. We have our security controls between everything, and then we have our workloads. This is just pretty standard 101 stuff. This is what we know. We have all our security controls. We have our firewalls, our hypervisor settings, our VM settings, our network settings, our logging. Again, that's all from the configuration guide. We want to log to some place so we can look at the logs. So what do we do with our logs? Well, that's a big question. So where do we go? We're going to have to take all these things and somehow come up with some sort of assessment or score to say, how well did we do them, right? That's the first step. Because I can apply the configuration guide completely wrong. I could apply a patch, some of it could go away. Now I need to figure out what changed, assess the environment. So that's the next step. There are tools to do that out there. I've written some, other people have written others. Then we want to know, did our score go up or down? Does the system change in any unexpected way? And how do we know it's unexpected? Every change to an environment should be known in some fashion. If I'm changing the hypervisor, I should know what I'm changing and why I changed it. Basically, if you're in a big shop, there probably is a ticket associated with that required change. I applied the configuration guide. I patched. Oh, I went in and changed a setting because I had to tune vSAN. All these matter. Basically, we need to know what drifted. What's the configuration drift? Hypervisors hypervisors in our virtual environments, they don't stay static. They're constantly changing. We are either doing it ourselves, some tool may be doing it for us, or I may be patching, or just naturally over time. By the way, a long uptime is not a badge of honor. If you have a long uptime past 3 months for a hypervisor, that's actually a badge of shame. It means you're not doing security patching, which come out every 3 months, if not earlier. Some of them come out every month. Patch as often as you need to. Part of that is also controlling configuration drift. I assess daily. Some people can actually assess audit every hour. It depends on how vibrant your environment is, how much it's moving. You want to do is basically, if you are making a change, you may want to, like I just did an update, I may script an assessment immediately as part of that update. Why? Because I want to know, did that update change something I did not know about? I do this specifically in my lab environments where I'm testing upgrades. Then when I go to production after my test is done, I know what should be changing back to where it should be going. That assessment helps. Even then, I may make a bunch of changes because I have to, and I may automate that. I still want to assess to make sure I did it right. So what do we monitor? These are just some basic things. You want to monitor the things you cannot prevent. So in a virtual environment, if I use something like a high trust tool or other type of security broker, I can prevent some things from happening. Inside of vCenter, I can use role-based access controls to prevent things from happening. Only certain users can change network settings, for example, or certain users can manage the cluster. That is important. That prevents bad things from happening, prevents changes from happening that shouldn't be there before. I can also monitor for those things I can't prevent. For example, it's almost impossible to prevent a hot add of one disk to another virtual machine. If you give me the right to create a disk, I generally have the right to add a disk. So you want to monitor for that activity. You want to monitor for placement of VMs. Even though I can tell you can create a VM and you can only put it here, well, actually, you can put it anywhere you have access to on that hypervisor. So you want to monitor for placement. It may go in the wrong spot. Oh, that area is a virtual switch, for example, is for the DMZ. Well, I just put a production VM that belongs out in an unprotected area of my network into the DMZ. That's probably a bad idea. You want to remove it, and that's why you want to monitor for placement. I want to unapprove, and basically there's also a lot of unapproved networking out there. I may have a promiscuous mode port group because some security tool requires that, or some other tool requires that, maybe an SDN or any number. It's actually a number of SDNs require that. Putting a normal workload on there is a really bad idea, because then it inherits all that promiscuous mode capability and can attack your environment. So again, I want to monitor where I'm placing things, whether it's in my network, whether it's inside of my storage. I may have a different LUN or different storage or data store for certain workloads. And I want to know if I'm going across trust boundaries. So you monitor for things you can't prevent. You also monitor those preventions so you can find out who did what, when, where, and how, and who was blocked from doing something. I also want to monitor performance. The funny thing is that years and years ago at our SAY conference in VMworld, this was around 2010, yes, many years ago, I asked an important question of a bunch of security guys. I said, what is the early warning system for virtualization, virtual environments to tell if something's gone wrong from a security perspective? Almost to a person, they said performance. It'll give you that metric that says something just spiked and chewing through CPU. Well, if that's not normal behavior, it could have been an attack. You want to monitor for that. Matter of fact, App Defense takes advantage of that same thing, and that's how it does it. It actually monitors CPU and memory utilization to give you a possible, hey, I'm being attacked. Now go deeper. So it does that. Log analysis. I want to analyze all those logs. The vSphere 6.7, 6.5 logs have been greatly improved. So I can now bring those into VRLI using security dashboards, or even creating your own, you can monitor those all for security events. Somebody doing something they should not do. That log analysis is really, really important. Splunk actually has enterprise security with virtualization logging in it already for the main things that people should be looking at. That's a good start. You can add to it, add your own rules, add the things that are unique to your environment that you don't want to see. Why? You don't want to monitor, but you don't want to just alert. You may want to quarantine then alert. And actually, there's a lot of text on here, and that's going to be on screen. The reason being is some issues require an immediate response. I place a VM on a promiscuous mode port group that shouldn't be there. I may not want to wait for the alert to cycle through the system, which could take, what, an hour or 2 hours? In the meantime, I've already attacked your environment, stole all your data, and left. So you want to basically quarantine or shut down or get rid of that immediately, and then augment the logs to say, I did this action, and then that people can go back and say, okay, that travels all the way through, but I've already done the action. This is important. You also, to do proper quarantining requires more. I may need more network, I may need more storage, I may need more compute. And the reason being is I may be taking bigger VMs, quarantining them by moving them into another location. I may be moving them across data stores, I may be moving them across to different networks, and I may want to keep them running while they're doing their bad stuff and monitor them even further while they can't go anywhere. So I may need more resources available in my cluster to do this, and it's actually very important. And then the alerting part, again, you want to quarantine, then alert. The alert needs to feed stuff into the log files that says, augment the logs that says, I quarantined this, this is why, and I did it automatically. And this is the tool that did it. So again, get who did what, when, where, and how. That way, when it comes down to the security response team, they'll know where to go, they'll know what they're looking at, and they'll know why you did it. And it's an automatic function. That's the next step. Then we get into things like forensics. So I've quarantined, now I need to do forensics. You need to ensure your virtual environment is forensics ready. And by forensics ready, I mean that you may probably want a forensics cluster. You don't want just one host, you want a cluster of hosts. You want enough storage that I can move things to it so that that storage is now separate from my regular environment. I want enough networking that I can actually duplicate the networking environment in this quarantine area. And I'm too far forward, sorry. When I do that, I now have a forensics ready system that has already VMs in it that actually have all my forensics tools. I may then be able to do snapshots and memories and get memory. And when I look at all forensics, you don't want to do forensics haphazard. Forensics is actually for the court of law. Anytime you use the word forensics and you're doing it, it is for the court of law. End of story. You want to take really, really good notes about what you're doing. You need good notes, and everything you do has to be repeatable. When we do malware analysis, we're not doing forensics, we're doing analysis. If I'm doing malware forensics, that means I have to step up my game. That's where you need these forensics tools already available, ready to fire. And I said, forensics for malware is no different. It's still for court of law. But I have an advantage in a virtual environment that no one else has. I can get memory and disk and everything right underneath the VM. The malware, the attacker doesn't know I did that. And I could do it multiple times to get difference in changes in state. That way I can track all the way through my environment exactly what it did to memory, what it did to disk, how it went from A to Z. So don't look at just point in time. You want multiple points in time. So do you have enough storage to get multiple points in time? How do you handle VMs that were encrypted? VM encryption disables the getting of memory through a snapshot. It doesn't allow you to drop memory anymore, so that memory file is gone. It's not encrypted, it just can't happen. So you have to now find another tool to get memory if you have encrypted VMs. Forensics Ready is like an end game. This is really where I would love all our environments to go, is to have a Forensics Ready cluster. This is really pushing the envelope on most people. But it really means you need more capability. You need to really think outside the box on what you want to do. Okay? So that's actually all I really wanted. Today, it's really, when we start talking about Forensics 201, it's really just the beginning. We've done the basics. Now we've got the beginning of our where we want to go next. And where we want to go next, we want to assess, get a score, we want to do logging, and we want logging in and monitoring. That monitoring is really important. You want to monitor for the things you cannot prevent first. Then you want to monitor to ensure the prevention worked right. Because that could change, right? Then we want to worry about what are we going to do when we find something bad. We want immediate actions as fast as possible. You want within 5 minutes. That should be your goal. It shouldn't take an hour or two or even a day. 5 minutes, automation is king here. Okay? And then you want to have everything ready to do forensics on it right away. And that is it. That's where we're going. That's Security 201. I know I gave a few ideas here, I hope, but I'm open to questions. Any? I don't know how much time I have left, so. Well, it's supposed to be 15 minutes, that's why. Yes? Question? Okay. So the question was, what compliance tools do I recommend? Well, that actually is going to depend on the regulatory compliance you need to meet. FISMA. That one's a tough one, actually. There's not much out there. HITRUST does some things in that arena. I know that vRealize Operations has some capabilities that are not complete. I know there's some other third parties that are small that have done some things in that area. Most of that's process related though, and that's the problem. Process is hard to track. That's why you want tooling and monitoring to make sure you take the logs and make sure it's following your process. That's going to be the important part. Yeah. How do you get to the process that you need to follow? There is, actually at RSA conference a couple of years ago, there was one that actually walked you through secure processes for various regulatory compliance. Let me get with you after this and we'll talk about it. I can't remember the name of the company off the top of my head. It was like a just started startup type thing. And I can't remember the name. No, not Puppet. Puppet can do some of that, but not all of it. Yes? Oh, you're just fixing your glasses? Anybody else have another question? So here's the other question is, how do you prepare your systems for forensics? I like having a forensics cluster, but you also have to look at the forensics tools. Not all forensics tools are made ready for virtualization. Be really careful which tool you choose. Now, the one that I like the best is FTK. They actually do access data. They do a lot better than almost any of the others for a virtual environment. They actually even understand virtualization, which is a good thing. So it's something to think about. Monitoring, there's going to be a lot of roll you around. Everybody's rules and regs for what's valid is different. What you quarantine on will be different from company to company to company. I do know if you're going to be putting a VM on a promiscuous mode port group because that you're required to have one, which by the way, you should never have one. And any time you have one is a massive exception. But if you need one because you need to get packet data or something like that, which actually is valid, it's short-lived, you need to make sure you know exactly how to turn that off, anything that is not it, off, or move it. Get it out of there. It doesn't belong. That's what you need automation for. We are not fast enough. It will take me 30 seconds to attack an environment if I have that level of access. I'll be able to drain the swamp easily if that's what your virtual environment looks like. It gives me too much access, so you need to make sure I can turn it off as quickly as possible. That's where you're going to have monitoring tied to automation. That's something you would probably end up even having to turn off or quarantining to find out how you even got there in the first place. Could have been a mistake. It could have been a legitimate malfeasance. Any other questions? None? Thank you very much. How many have been here for 10 years? Hello, my name is Edward Haletke, and I am a virtual VMware vExpert. 10 years, I've been coming to VMworld since 2008. I started out with virtualization like everybody else, P2Ving my desktop to a VM and workstation 2. Okay, did anybody else fall that way? Anyways, throughout my years, I've been studying the hypervisor. I want to know how this thing works, because if I understand how it works, I can better secure it. And I have a security mindset, so that's where all this comes from. I also like tinkering. I like knowing how things work, so I went and did that. So this is how data flows through our hypervisors, VMware vSphere specifically, or ESX, and ESXi. And we have multiple different flows we need to worry about. The first one is our network flow. Typically, everything moves from the VM through a port group to a vSwitch through something called the DV filter, and then through the driver, and eventually I get to the hardware and the physical NIC, and I go out from there. At any one of these stages, I can intercept data. We need to think about that. Management has its own network. We call it VMK0. It's a port group with a VM kernel device. It flows pretty much the same way. No real major things here. If this was a, with no VLANs, everything flows off the same and looks the same. Now, it has general security controls and where they are placed. Inside the port groups themselves, and actually the virtual switch, I can reject a bunch of things. Inside of the virtual switch are other controls like traffic shaping, network IO control, load-based teaming, and things that control the driver further down. If I'm going VM to VM without changing a VLAN, or if they're on the same VLAN or the same port group, the traffic actually, as you notice, never leaves the hypervisor if the VM is on the same hypervisor. If it's on a different hypervisor, believe me, it leaves. If I have no VLAN or the same VLAN but a different port group, this is important. It still treats it as doing the same thing. I didn't give it a different VLAN. I'm using the same control. It actually never leaves the virtual switch either. Again, unless I'm going to a different hypervisor. If I'm going to a different VLAN or a different network with a different physical adapter, I'm actually going to be leaving the hypervisor. Everything's done at the physical switch. It goes right through the virtual switch layer and directly to the physical switch and gets routed up there. If I have a no VLAN, save VLAN, different switch, different adapter, make and model, same thing happens. I have to go out. And make and model does mean different things. So if I have an Intel NIC and I have a Cisco NIC, I'm definitely going to have to plumb those very differently. Why? Because they plumb to different virtual switches. different virtual switches means I have to go somewhere else to route between them, or put something between them to route between them, like another VM. Again, I'm going in and out, and management does its own same thing. Now, here's the thing. Routing between things that are in the different hosts is only capable if the top of rack or further up is allowing you to do that route. So if I actually deny it in the virtual switch to route between two VLANs, I mean the physical switch to route between two VLANs, all the way up, you're never going to be able to do it. That's just the way it is. But if I have them routing to each other, then I can actually traverse these networks and I actually enter the physical world. Again, VM to VM, different VLAN, different vSwitch, same type of thing. I'm going in and out. I'm actually leaving the hypervisor at this point. This is considered east-west traffic. This is if I'm having different VLANs, but different network connectivity. Like for example, one of these networks on the left, let's say, is my VDI network, and I don't want my normal server network on the right to talk to it. Well, they can talk only if the connectivity exists in the physical network. If that one of these was a DMZ, for example, a DMZ network, that physical connectivity probably won't exist. But I hope it wouldn't. So they would have a break there and they would not be able to talk to each other. So that's that. That's networking. It's pretty straightforward. There's lots written on this. You can always find that. And there's been a great talk, set of blog posts called The Great vSwitch Debate. You can find it all in there. So let's talk about NSX. In here, everything kind of looks the same, no guest introspection, everything's just standard traffic, and I'm blocking it. So NSX, I can actually tell the VDS to block all traffic. Actually, every VDS I can do this. I can say block all traffic on that VDS. It'll go to the VDS and just die. Won't go any further. I can do that. That's built into a virtual distributed switch today. It's not built into a virtual, the VSS, the standard virtual switch. But if I want guest introspection, which is built into NSX, and actually it's part of VMware tools. It's installed as, anytime you install VMware tools, the guest introspection API and libraries and agents are installed automatically. So what happens is the VM does something different. It goes and says, okay, I'm going to go to VMCI, which is going to the hypervisor kernel, and then I'm going to go to the guest introspection driver, and that driver is going to say, oh, I got to go to this local vSwitch that NSX created for me to go to this local port group to get to the per host service VM that does the introspection. Notice it's actually from the VM, not traversing a network. It's traversing VMCI, which is an internal construct. This is how a lot of the antivirus tools get plugged into NSX. This is actually EPSec version 2. There was EPSec version 1. Endpoint Security version 1 did it slightly differently. But this is what we're working on now. Now we get to NetX. Does anybody know what NetX is? NetX is basically the next generation of security from VMware built into NSX. It's for NSX-V only at the moment, but allows you to actually tie together, kind of like network function virtualization, a bunch of controls that are drivers and or service VMs that you can steer traffic through. So in this case, I got two virtual security appliances. I'm actually going into the DV filter. DV filter has the NetX slots. It fills in the slot, sends data to an appliance, says, oh, you do that. Oh, next slot, go to the next appliance. Any one of these appliances could say, don't deliver that traffic, or modify the traffic, or do anything I want to it. And then it'll pass to the next one and the next one. And there's only a limited number of slots, so there's only a limited number of things I can do with here. Again, if it's allowed, then the traffic would be allowed out and follow the same path of the network switch that we were talking about. So that's effectively the basics of the NSX security features. When it comes to the logical routers and everything like that, it's really just your DVS with a few other things thrown in and VMs to link things together. It's the best way to look at it. virtual disk caching. This is actually really interesting. How many caches do you expect to be in your disk cache all the way down to your hardware? How many caches exist naturally? 2, 3, 10, 1, none? So generally the normal usage is the VM goes to a local disk cache. One way, there's always a cache on there. Another path would be going to the cache at the remote disk. Every disk has a cache in it. So we got to think about that. All data at the cached within an array or within inside of the hypervisor hardware is actually always cached. I can cache in the array at the disk, but I also cache at the array itself. All arrays have caching, believe me. So I got multiple paths here. Anything above that is uncached. Now, I can actually cache in the HBA. All host bus adapters, all SCSI devices have caches built into them for the exact same reason. So now I'm caching in multiple layers. Again, anything above that is uncached. So this is, sorry, yes. So this is actually a different one. Let's talk about IP storage. We talked about fiber channel, now let's talk about IP. Same thing. I have caching in every array. If I have an iSCSI server, believe me, there's a cache there. Again, I have to worry about where things are happening. So some other controls, multipath protocols, storage I/O controls, all happen roughly at the driver layer. Anything above that is uncached. So what's happening is internally, when I start going to iSCSI, I have to transport from iSCSI to the iSCSI driver stack. There's a storage driver stack where the VIO is, but then I have to go to the VM kernel switch, which actually gets me down into networking again. Excuse me. Anybody use VFRC? VFRC basically moves the cache into the hypervisor. So effectively, I'm using a local SSD as the caching layer for everything. So when I do a read, it goes first there and says, do you exist? If I am, I'm cached automatically and I read back. If not, it goes through the same path to figure out and get all the data you need. So whatever's cached is cached. But the VFRC is a way to do a read cache within inside of the hypervisor using local SSD. How many of you guys use vSAN? Anybody? vSAN? Oh, vSAN has a built-in cache as well. That's what the local SSD for vSAN is for, is to cache reads and writes. So again, I have to go there. And then anything above it is cached. Anything below is not, or could be, depending on the hardware you're using. So you can actually tie VFRC and vSAN together if you have enough local SSD, if you want to, and get more caching. Here's the thing about caching. It all stacks. The more caching you have, the faster things are, and you can stack all your caches. I can't stack encryption, but I can stack caching. Multiple layers, multiple everything. It's only uncached if it's actually not in the vSAN cache using this approach. I don't know anybody who does this, but I just figure I document this for posterity, in case. So virtual disk encryption, we went through caching, many layers, all there. Virtual disk encryption is very different. This again is your normal usage unencrypted for remote disk and local disk. I can encrypt at the disk layer, right? SSEs, but anything above that is unencrypted. So anything going through the hardware, through a switch, through anything is unencrypted. Generally, this is great for what purpose? I got to throw away a key and I don't care about the disk. I can encrypt in the switch. Yes, there are encrypting switch type capabilities. You can actually plug into your storage array or your iSCSI network an encrypting unit that will literally, you pass through encryption. It acts as a switch and does encryption at the array. Everything below that's encrypted. Everything above that's unencrypted. I can encrypt at the HBA. Yes, every fiber channel HBA has an encryption chip on it. No one uses it, but it exists. Every iSCSI offload card has an encryption chip on it. No one uses it, but it exists. And they don't use it because they fear the performance of doing the encryption, which actually these days doesn't exist. It's not a problem. So I can encrypt in the hypervisor. This is in-VM encryption. What I'm doing is I'm doing the encryption actually in the VM, but the key is in memory. Anything below the VM is encrypted. Everything in the VM is not. Now, there are tricks to say, hey, I can put a small key there and for a small time and decrypt and encrypt automatically anytime I want, but the keys are always in memory. That's a weakness. Or I can use Intel SGX, which, by the way, this is not implemented in server-class CPUs today. And this is actually using a trusted execution environment where all the encryption happens inside of the CPU. So data would be passed in, the key would be in CPU, and the CPU itself would be doing the encryption. Again, anything above is decrypted, everything below is encrypted. I can use a virtual TPM to see, hey, hold my encryption keys for a VM. This is how it would look for in Hyper-V. And this is how it looks like in vSphere. The virtual TPM is actually backed by VM encryption. So what's happening is when I use my virtual TPM, it's a chunk of the metadata files that are written for every VM. It's encrypted in there using VM encryption. It doesn't encrypt all the file, just the chunks it needs. So the NVRAM and certain sections of the VMX file and anything, I think those are the only ones, but there may be one or two others. When you do this, I need a KMIP using KMS, speaking KMIP, to hold those keys for me so that the underlying layers can be decrypted. The key cache is where I stick those keys. This is very complicated. So let me back this out. So unencrypted in key and memory in the VM. I can read the key out of the virtual TPM. So if I even have a virtual TPM, I put the key in it, right? Well, I have to read it out to do the decryption. But the key's safe because it's outside of somebody's control. It gets read in the memory. Someone changes it, you just read it again. No one can write to it again unless you have the right permissions, right? Can those permissions be gained? Yes. But it's backed by all the layers of VM encryption, which happens inside the, let me see if I can do this, there we go. Nope. The I/O filter that's in place for the storage does the actual encryption of the bits that need to be encrypted when they get written to the disk. It's NVRAM swap file, parts of the VMX file, and a few other things as I was documenting. The key that gets written is one that the VM just can't see for the virtual TPM. But I can store in a virtual TPM other keys. So the VM itself can't decrypt what the virtual TPM has. That's actually a nice feature. This is VM encryption itself. It goes through the VIO, the I/O filter, and the driver. Everything at the I/O filter, below the I/O filter, is encrypted. So not a little less complex, but what we're doing is, again, the KMS sticks the stuff in the key cache on a per host per basis. That's why you need a KMS. You can't do this without one. It needs to be KMIP 1.1 or higher. There are plenty out there that are actually free and enterprise class. I suggest if you're going this route to look at that. But everything gets stuck into that key cache. That lasts through a reboot, but also it gets re-updated every time you reboot to make sure that you got the right keys out of the KMS. So the ultimate holder of the key is not the key cache, it's the KMS. You need multiples of them. So what happens is when I go through VIO, I then hit the I/O filter. The I/O filter gets the key cache, does the decryption or the encryption of the bits so you can read and write. That's how it works. vSAN encryption is basically a little different. VM encryption is doing it at the I/O filter. In other words, as data passes through the SCSI, the virtual SCSI adapter, it's going to encrypt somewhere in the filtering stage. vSAN itself is a driver. So what they're doing is they're using that same key cache and pulling it into the vSAN driver and doing the encryption and decryption so you get data at rest encryption. Again, everything above the vSAN driver is unencrypted, everything below is encrypted. The advantage to both VM encryption and vSAN encryption is that the key for the encryption is never in the VM. VM can't see it. I, as an administrator, can't get to it. I, as an administrator of the VM, cannot dump memory and get to it. This is an important thing. That's always been a weakness with encryption inside of VMs. So that was that. Encryption, caching, a lot of them are very, very similar in concepts. Where and what we do on them is the important bit. So let's talk about services. We're going to look at CPU memory flows, vMotion, live migration, and yes, there is some, I presented this for all hypervisors, but it's really just vSphere. So vMotion, everybody knows how vMotion is great, right? Everybody's used it, I'm hoping. And do you know how it works? So the very first thing does is that vMotion spec is actually encrypted these days with an AES-256-bit key with a 64-bit nonce. And basically it says, okay, stun the original VM and instantiate a new one. Copy over data, right? So what it's going to do is the vMotion itself, in this case, is saying, hey, stun the VM, which means halt all processing, instantiate a new similar VM with the same spec on a new host. The next thing it does is starts transferring data. So this one's going to copy memory. It copies the used memory first and then the unused memory. Generally, unused doesn't mean it hasn't been touched. It's used pages. So copying the pages, not the actual, all of the memory. Just the in-use pages, or it could be parts of pages that are unused, but it's just pages. You're not copying byte, it's copying pages. Once I've done that, I've stuffed that all into the virtual memory of the VM. Then I go off and say, okay, I now need to copy the registers. Because once I copy the registers, I can tell the VM where to pick back up, because that's all in the registers. It's the current instruction pointer is what you really want. That, and you need every other register there too to make it work. Once I've done that, and by the way, if you are turning on VM encryption, vMotion is encrypted by default. You have to have VM encryption to get encryption vMotion these days. That's 6.7 and 6.5, I think. And then I have to deregister the original VM because I don't want two of them. That would be bad. And then unstun the new VM and say, hey, I'm up here. And I'm now ready to run. How fast does this take? Less than a second? Sub-second? Yeah, it's fast. Because most of it's already on the other host. The disk is on there, so all I have to do is copy memory, in-use memory pages. Not all the pages, just the in-use memory pages. So that's the basics of vMotion. Ballooning, TPS, and compression. So there's a memory services inside of vSphere that will do a per VM memory page type setup. Those VM services can do compression of memory. So what it's doing is taking more than one page and compressing it so it fits into less pages. Less pages it takes up, the less memory it actually uses. That means I can share this memory across more and more VMs. But remember, a page of memory, once it's assigned to a VM, stays with that VM. So when they compress, they're actually stuffing pages. But it has to be uncompressed at some point in time. So there's an uncompression, there's a page that you can uncompress into as well. So memory ballooning works very differently. The MEM services detects the need for more memory pages. Only free pages, so if I have a free page in one VM and not in another, it's basically going to say, hey, can I borrow that page? That's a page from your book, I need to borrow it. So what it does is says, okay, I'm going to mark that page as unusable in the VM, and then zero it completely, bitwise zero it, and then allow the new VM to have access to it. Now that process gets reversed when the VM is done with it. So if you have an overcommitted memory, could be one of the things that's happening. How many people use memory ballooning? Few? Okay. I don't anymore. but I have more memory than I can use for the VMs I have at the moment. That's changed over many, many, many years. I started with using ballooning, compression, the works. Transparent page sharing is very, very different. So there's actually a transparent page sharing buffer that is basically set up per group. If I have a single VM and I say this can't share with anything, there's no buffer for it. If I have a group of salts that I use for a group of VMs, then all those VMs can do transparent page sharing. I have a group of buffers for them. And then I have ones like, oh, all the hypervisor, I can do it that way. So mem services are basically only if I share the same key can the page table be shared. This is cool. Each page is then compared. It does a checksum, and then it does a bit by, if that checksum passes, it does a bit by bit comparison. So the checksum's used to just say, oh, you don't match, I don't care. But because all checksums have been broken, they do a bit by bit comparison to say, is this actually identical? If the page is identical, I can compress them and repoint everything to the one that exists. It's the only time it happens. In a large environment with VDI, this could be very, very useful. You also tend to want to turn it off when you have users that are in different security zones. Just saying. Fault tolerance. Anybody use fault tolerance? Good. A few of you. So fault tolerance is very much like a VM, like a vMotion, kind of like a half vMotion is the way I always look at it. When I set it up, I stun the VM, the target VM, and I instantiate a shadow VM. Once I instantiate the shadow VM, I can then send events. Now, if I'm using one vCPU, it sends non-deterministic events, memory access, that's it. If I'm 2 to 4 vCPUs, it sends all instructions. That's why you need a 10 gig link. If you don't have a 10 gig link, multi-vCPU fault tolerance is going to be painful. And then I instantiate the shadow VM. And then the fault tolerance engine is going to start transferring CPU instructions based on the type you have. The shadow VM is just sitting there running in the background, doing everything you normally did. During a failure, it actually, when the failover happens, the source VM is dead, so it promotes the shadow VM to being the main VM. So it finishes the vMotion, so to speak. It does the instantiation, the proper instantiation. Change block tracking and snapshots. Everybody uses this in some fashion or not. So what happens is, when change block tracking happens, I have the disk sectors, all change blocks of the disk sectors are copied, are written. So if I'm changing a sector of a disk or a block on a disk, it's going to say, okay, I'm going to copy and make sure you know that I changed that block. So change block tracking is a journal of all that. So that when I know what to copy into my backup or to repair, I have a list, which is kind of cool. Again, what's happening is when you do the snapshot, which is generally what this is used for, it instantiates a new virtual disk that is the current instance of it, and the main virtual disk is just not doing anything. But there's a CBT file that actually is being written to for the change block tracking as well as the virtual machine. Snapshot services work the same way, except that you're not actually using CBT unless you ask for it. It's going to stun the VM. And if it's encrypted, by the way, this won't work. It's going to create another disk, and it's going to repoint it to the new disk. That's all it does. So I have an instance, but the CBT file is also being used at this time, usually. You can tell it not to, but most people do. You can have multiple snapshots. And when I restore a snapshot, what I'm doing is I'm going to copy the revert is I'm going to copy the commit, I should say. I'm going to copy the first one to the next one to the next one, and eventually it's going to be one disk. So if I do a complete restore, I can do that. I can also get the memory. Memory is not going to be gotten, you can't snapshot memory if your VM is encrypted. It just won't work, just don't even bother. But memory is really useful when you do snapshots if you want to do further analysis of a VM. You have a backup to do malware detection, other type of analysis you want, forensics, the works. So I actually then write the memory file, and some of the CPU bits get written as well, specifically registers at the end. When I do the commit, I stun the VM and repoint everything. I copy the data and then repoint to the old one. So now all those virtual disks I created that had all the snapshots in it disappear. Now I can keep them if I wanted to. You just do the next previous one. This, I like doing this. I like keeping my snapshots really clean. Snapshots used to add overhead. They don't really anymore, so something to think about. VMCI, so VIX. This was a big thing that brought up at Black Hat last year, that VIX allows attacks. Actually, it doesn't. So what VIX does is allow the management layer to be able to talk directly to the VM through the VIX services. What you needed inside of it is the VIX spec, but it also requires a privilege inside of vCenter, requires a special setup, and has a limited results set. So you can actually get many results out of it, but you can do a lot if you have the right permissions. Something to think about. It allows you to run in the VM. There's no network required, but it requires a login and actually requires VMware tools. So if you don't have VMware tools, this is impossible. VMCI is going, oh, so this is VIX communication, uses some more on it. VM communication interface, we talked about that a little bit. Basically, it's allows a shortcut through to a driver that has nothing to do with networking or storage. They use it for endpoint security a lot, and it's just a glue layer, but VMCI used to allow VM to VM communication. It doesn't anymore. VMCI is used specifically for endpoint security only. So it's been very, very much locked down. This is the NSX guest introspection I've already went over. Serial ports, there's a number of different serial ports. You got named pipes. They actually allow VMs to talk to each other through named pipes. You have a serial service, which actually can write to disk. You have serial services that can write to a port concentrator upstream of you through the network. All these work. There's also pass-through devices with SROV. I can actually take a physical NIC, for example, and map that directly into the VM. And we are almost out of time, and then you got plumbing and pinning, and that's the end. Thank you very much. And I'm open afterwards for questions.
Hi, everybody. Welcome to my session, my trudge through IT burnout and the fight to keep it at bay. My name's Eric Lee. I've been in IT for 24 years. I'm currently a senior enterprise architect with a very large healthcare company based out of Kansas City. I'm told I'm the weird guy in IT because I don't like Star Wars, Lord of the Rings, or anything like that. I'm into a bunch of different things like dirt track racing, soccer, building things at home and stuff like that. So a little bit of background about me. We're going to learn a lot more going forward. My first 15 years through IT, I'd only heard about IT burnout twice. Both times it was when somebody in the community committed suicide. Outside of that, I never heard it. And even during those times when the suicide happened, we only heard it for 4 or 5 weeks, and then it kind of faded away. Through my career, as I've gone through IT burnout twice, to the point that I had physical issues because of it, I felt that it needed to become a part of the community, much like technical help with each other was. It needs to be out there. We need to talk about it more and stuff like that. We haven't been doing that. So I decided to put my journey out there, what I've gone through and how I'm working on it every day, and get it out to where everybody else can see that it's not just themselves and learn from what I've done. Starting out, I grew up in a blue-collar family. I had 2 brothers. I have 22 cousins, of which all but 1 are boys. We were rough and tumble, lots of activities. My parents got married at an early age, at 18, had my older brother when they were 19, my younger brother, myself, a few years after that. They were always working. We were free range, playing, always busy. You know, probably didn't go to bed as early as we should, but it was a lot of fun. As I got older, I got into other sports and activities. I helped build the race car, the yellow one, from the ground up with my best friend. We went and picked that out of the junkyard. We borrowed his dad's flatbed truck to go get it without telling him. We gutted it, built the roll cage, built the motor, put everything in it ourselves. Also, I was playing on a competitive soccer club. We were traveling all around the Midwest playing tournaments. I also played on the Olympic development team for Kansas and made it to regionals a couple times as well too. So I was always very, very busy growing up. As I moved on to college and moved away from home, my dad gave me $20 for gas and said, "Good luck, son." So when I left, I was on my own financially, physically, and as I said before, you know, we were running around doing a lot of stuff. I was on my own pretty much emotionally as well too. I played soccer for 2 years in college, paid my own way, worked full-time while playing collegiate soccer. I'd do side jobs as well to get through. I then moved on to KU to finish my college. I worked full-time still for this company that I was on the help desk for. I was on the board of my fraternity, and 1 year I even had 11 W-2s. I just had to do whatever I had to do to be able to pay for room and board and everything else. I had numerous student loans as well, just to be able to get by. To say I was busy is an understatement. But as I've said before, being busy is not always burnout, because that's just what I knew. That's what I did. Just because you're busy like that, it always depends on where you're at in your career and what's going on to know whether you're in IT burnout or not. I had no thoughts of IT burnout or anything around it, even though I was working in IT when I was doing that stuff. After college, the company I was working for got bought out. They bought out 4 other companies in the United States. I started working on an Active Directory consolidation project across the United States for 2 years, and it went so well they had me do it globally for the next 2 years. So for that 4 years, I spent 80% of my time traveling the world. I was kind of pissed I was paying rent, because all I did was laundry and kind of stay there for the weekends, and then I'd go again. I was home a little more than that as well too, but not a lot. During those weeks when we do migrations, if any of you guys have done some of that stuff, you know that it's very busy weeks. In a manufacturing company, you got to cut everything over as quickly as you can so you're not impacting manufacturing. There's weeks where we worked 90 plus hours without batting an eye. Was it stressful? Yes, it was stressful. But as soon as you were done with that cut over, and on the downside, you usually cut back on your hours. And if you had a good boss, like I kind of did at the time, he would allow us to only work 30 hours that next week to kind of get your feet back under yourself. So just working long hours to me is not IT burnout by itself. Towards the end of working at that company, I noticed things have changed. After my project was done, we were working on a bunch of other projects. Most of them were either underfunded or we thought were funded and became underfunded. We noticed that morale for our team was going down, other good people were leaving. Our customers, other departments, did not like working with us anymore because we couldn't do their projects. If we tried to do their projects, they were not successful. It got so bad that the manufacturing department hired their own IT people, put in their own switches, put in their own servers, and did it all themselves because we wouldn't help get it done. And what came of light was that my manager, his job got shifted to where he pointed to the CFO, reported to them. So his bonus structure was tied on how much money he saved from the budget, not from did projects get done successfully. Mine were still tied to whether the projects got done successfully. So there was a conflict of interest there. I'd worked at the company for over 11 years by that time. As many of you know, if you work for a company that long, you kind of buy into it. You feel like you're a part of it. You feel like the projects that you've done are actually a part of you, right? Not just something I did and I handed off and I went off to the next thing. So this was very, very hard for me to deal with. I was not happy. I was downright pissed, actually, that these other guys were putting in switches right next to ours, putting in servers right next to ours, and doing all these cool things that we should have been doing for them. But to me, not liking my job or where I'm at by itself is not IT burnout, okay? There's times where I don't like my job today. but I'm not burnt out because of it. Then one thing happened as I was there. My wife looked over at me one day when we were watching TV and she said, "Look at your hands." I was like, "What are you talking about?" And I looked down and my left hand is shaking like this. If I had the remote in that hand, it actually wouldn't have stayed in that hand. It was shaking so bad. And I had no idea what was happening. I looked at my right hand and it was shaking just a little bit, kind of like a nervous shake a lot of people might have if you got up like this to speak the first time. I was like, what the hell's going on? So she started asking me some questions. What are you thinking about? What are you doing? You know, I found out I was focusing on things at work, not just what I didn't get done, like relationships that we were having, like just all kinds of stuff. And I was so enamored by that stuff that I couldn't focus on the TV show that we were watching. Hell, I couldn't even tell you what that TV show was or what was going on. So over the next couple of days, we finally started talking. As I told you earlier, I grew up in a family of all boys. Just like tech, which is primarily male, we don't talk about our feelings. Neither did my family. If you weren't feeling well mentally or you were upset about something, we were told to go work, go do a chore, go to whatever, and eventually you won't feel those feelings anymore and you'll be better, right? My wife comes from a family where they talk about everything. And so this relationship wasn't working very well when it comes to feelings and stuff like that. So finally we had to start talking about them. It got to the point I was having physical issues because of it. And what we found out is I was being overly snarky to my wife for the dumbest things ever, right? Not just normal sarcasm, which I speak as a first language, just stupid stuff, right? But I had no idea I was doing it. And it was actually wearing on her, but not enough that she would bring it up to me because she knows I don't talk about stuff like that. The other thing that we started realizing is that I couldn't focus on anything. You know, I'm not a very good reader, so that didn't like show up because I'm just not a very good reader. But what I did realize is when I'd read text stuff that I like to, I could read a paragraph and I'd have no idea what I just read, right? I'm just like focused through the page and just reading the words, but they're never getting into my brain. I hated doing things like going to the movies anymore, mainly because I'd pay $8 or $10 to go to the movies and I'd have no idea what just happened because I'm still thinking about the crappy things at work and everything else. The worst thing is I'd find myself playing Minesweeper for like 2 hours at a time and have no idea I was doing it, right? Or I'd peruse the internet and I'd have no idea what I was looking for or what I was looking at. I really had no idea what I was going. I would segregate myself from my friends. I was no longer wanting to go play volleyball and softball and play soccer and do all this other stuff I was doing. I'd really faded off into a deep state of depression that I didn't want to be around anybody. I'd go to work and go through those cycles. So what did I do about it? Well, working at a place for 11 and a half years, you're not sure what you can do, right? You have really good relationships at work. You're not sure who you can talk to or not. You're not sure what you can really do outside of work. And in our industry, like I said, we don't talk. Well, finally I said, screw it. I'm getting out of this place. Changing a job has to be the fix for this. It's just as easy as that. And it turns out when I changed jobs, within about 2 weeks of being there, the shaking went completely away, right? So I was like, that's gotta be it, you know? And you think about it, but what did I actually change? Just the job. But in reality, that's nothing. People change jobs all the time now, right? That's not changing anything mentally that you're doing in your life. When I changed jobs, I happened to go to another company that just merged with another company. So here I am back again doing these back-end integrations again over and over again. Same type of stresses, same deadlines, same hours and stuff like that. Add into it that the company I went to is in the advertising industry. And this is in 2008. What happened in 2008? The recession, right? So most of our advertising dollars started dwindling. So our projects started getting defunded and stuff again. Back to where I was before. I started reflecting on that and thinking about what symptoms I had before to see if they were coming back again. And luckily this time it didn't come back again. So just having those stresses alone is not IT burnout. There's a difference between stress and IT burnout. A new job opportunity came out about 3 years after that. And it was a guy I'd met, and he goes, hey, we're looking at getting into this CI/CD stuff. I'm looking for somebody who knows networking, storage, VMware, Windows, all this stuff. And I'd accumulated a lot of those things. He's like, we want to automate start to finish. And I'd already been automating a lot of stuff. I'm like, this is sweet. So I took the job and I went over there. And the first year we went from doing almost no automation to automating our full stack deployments and doing testing every 12 hours, right? And this was awesome. My boss told me that 50% of my job is to go to whatever conference, research whatever products to help make us move faster. This was sweet. Best job I ever had, right? The VP, once he started seeing what we were doing, he gave us leeway to any amount of money, whatever we wanted, as long as we were progressing the business. Our developers were becoming more efficient. We were able to ship product faster because we could get through testing faster. It was awesome. Sitting in meetings and everybody going, oh, you just automated that whole process. Now I don't have to do it 5 times a day. You saved me from doing all kinds of stuff. It was literally the best job I've ever had to this day. Towards the end of working there, though, I had some friends from the previous job that were really, really good at what they do, and they left and they went to a VAR. They'd been recruiting me off and on. There was some management there that I'd met before I didn't really like, so I kept telling them no. Well, after we got to this point where we were doing fully automated stuff, we were getting it faster and faster, even less than 12 hours, things kind of slowed down. And I actually skipped a slide here. 1 year at this place, we were putting on a conference in Orlando. And when we were down there, or about to head down there, I was setting up all the labs, and I was responsible for not the content of the labs, but the lab infrastructure. So think the hands-on lab stuff here. I had to do the front-end portal and all the lab infrastructure stuff. We decided to put it in the cloud. I worked with a cloud vendor for about 3 months to try to get it working, and it wasn't working. 6 days before I had to go to Orlando, I had to rack and stack a whole bunch of gear, get it on a truck, ship it down there, just to make sure we had it as backup. My coworker looked over at me and said, hey, look at your hand. My hand was shaking again. Not as bad as previously, but bad enough that other people were noticing. I took a second and went back through those symptoms we talked about before. And luckily, I didn't have any of those other symptoms. I was still doing sarcastic things, but I wasn't being snarky and snippy. I wasn't segregating myself. I was still going and hanging out with friends, doing activities. I was going to the movies again. Doing stuff like that. Luckily, when I got to Orlando, I contacted the vendor again, and we started walking through our processes, and I got a hold of one of the guys, and we made the changes necessary, and everything started working. Within about 2 hours, the shaking was completely gone, and it never came back the rest of the week. And if you've ever seen the hands-on labs people running around, those guys are crazy busy, and they put in a lot of hard hours to make this stuff work for all of us. So as I was talking about, I had a couple guys, there was 4 of them that were recruiting me to come over to this VAR. I'd been talking to them about what I was doing. They had a whole bunch of customers that wanted to take the same CI/CD journey with me. I thought, this is going to be awesome. I can take everything I learned, I can educate customers, I'll learn from them as well too. This has got to be the great thing to do. Talked to multiple people and they said, yeah, sure. I talked to other people and they said, I don't know if I would do that. You've talked about how much you like this job. I don't know if I would take that chance. But guess what? It worked last time to take another job, and the time before that. It's got to work out for me now. I haven't taken a job that I didn't like. It's got to be good. Well, it was. The first 9 months I was there, it was phenomenal. I met a bunch of customers. I started them down the automation path, started getting them to actually talk to their developers and start doing some of those basic DevOps stuff that we've trying to talk about around here for a while. After about 9 months, though, 2 of the managers that I didn't like came back. And now all of these crazy processes started showing up. Things that I would not have my team do at all, ever. Part of the things that I've heard about in the past that I didn't like. I got called out in email internally to everybody for stuff that I had nothing to do. And then when the guy found out about it, there was no apology to me or to everybody else, like sent out to everybody else to let them know that I didn't do it. It was literally just like, oh, well, okay, and I'm like, well, that's crap. And then if you've worked in sales or pre-sales, you know that you have a quota, and your base salary is not usually that high, and everything's based off your quota. I lost half my account managers, and they didn't change my quota. So, and they wouldn't do it, and this was in February. So I had the whole rest of the year that I was not going to be able to make a single quota, which means it was going to be about a 60% pay cut to continue working there. And I just couldn't handle that on top of everything else. About this time, depression really started seeping back into me. I started noticing all those symptoms again, and even worse, this time I was thinking about that last job I just left to get here. I'd never taken a job where it didn't work out for me, like I said. Not only that, this time I left the best job I've ever had in my life to go to this crappy place now, right? I couldn't get any of my work done because I'd continually focus on that last job. I would think about what I was doing there instead of writing statements of work. I would think about, you know, this new technology that I just saw and how I could apply it over there instead of emailing my customers back or calling my customers back. I would go sit in a coffee shop and hide in the corner and just stare for hours at times, and all I could think about was that last job and how much of a failure I was and how much my friends who told me not to go were right, and I didn't want to hear "I told you so." Those things just eat at you and eat at you and eat at you and eat at you. About this time through this process, this presentation, most people are asking me, and I'm hearing it, hey, he hasn't said anything about suicide except for before in himself. And let's talk about that for a second. I thought about suicide. I thought about it a lot. I spent hours sitting in my car thinking about it. But I thought about suicide the same way a lot of people think about taking an exotic trip. Hey, wouldn't it be cool to go to this like crazy island that's like way out in the middle of nowhere, yada, yada, yada. But then I never take the time to go to Travelocity to see what it might take to actually get there. That's what I would relate it to. I thought about it. I thought about how much better it'd be for me, how much better it'd be for work, how much better it'd be for my wife to not have to deal with me. But I never thought about it in the terms of how would I do it? What, should I go get this? Should I go do that? I never got to that point. And you don't have to get to that point to be in a deep depression or to be burnout, okay? Don't let yourself get to that point. So at this point, it's time to move on. Something's got to change. And so let's talk about what was the trigger for me for that change. Luckily, I had one friend of mine who just calls it the way it is, right? We all need one of those friends. I'm sitting with him having a couple beers at the bar. TV's on, he's asking me questions. It's kind of like my kids nowadays. It went in one ear and went out the other, and I wasn't answering him. So I know how he feels now that I have kids. And he finally smacks me on the arm and is like, dude, what's going on? And I'm like, what are you talking about? He goes, well, I'm asking you all this stuff. You're not answering. What are you thinking about? And I'm like, man, I don't want to tell you. Like, you're just going to call me names and this and that, you know? So he kept prying and prying and prying. Finally, because I probably had 3 beers by this time, I started telling him about how I left the job, about how I was depressed and all this other stuff. I should have never left that job. I was pissed off and all this other stuff. He turned around and looked at me and said, bullshit. Get over yourself. The job's gone. You can't change that now. Either make your new job the best one it's going to be or find another one. That point in time is exactly what I needed. I knew I needed other changes, but that was the tip of my iceberg to get me on that journey. I needed that one friend to just, not in a crazy way, but to just tell me the way it is. So after that, I went back and I started thinking. I needed a strategy. I needed to start somewhere. At this point in time in my life, I have 6 strategies I use to deal with IT burnout and depression. I didn't start with 6. I started with number 1. And over time, I've added each and every one of these. And at times, I've had to stop doing some of these and change them to something else. So let's go through these for a second. Support system. Number 1 thing I did is I got rid of all the negative people in my life. I hung out with some people that I thought I liked and I liked to be around. But all they did was bitch and complain every day about all kinds of stuff. And I didn't need that negativity to build on top of what I already have. So I got rid of those people. I got rid of the people that I wasn't sure if they would have my back if I really needed to talk to them, okay? If I'm gonna be vulnerable to you, I need you to be vulnerable back to me, and I have to trust you that you're gonna keep what we talk about in confidentiality. The next thing I did was probably the second hardest thing I've done, and I had to talk to my boss. I had to let my boss know what my triggers were at work. You know, certain people, certain projects, if I get stuck on something, I tend to focus on it forever, and then I get kind of like, I can't do anything else, right? And he can recognize that in me, and he can stop me from doing that type of stuff. And he can also block out other things coming down the pipeline as well too. I also needed him to praise me for things that I did get done in the right way, right? I didn't want him praising me in public. I didn't want him doing that. I didn't need money. I personally just need somebody to come by and tell me that I did a good job, but not only that, but tell me why it was beneficial to the company. I buy into the company when I work at the company, and I needed to know that stuff to know why I was doing a good job, not just that I was doing a good job. And this was very, very hard because I didn't know how he was going to respond. Luckily, my bosses responded so well. He realized that if I was happier, I was going to be more productive. And if I'm more productive, I get more stuff done for him, which then makes his bonuses better, and his bosses like him even more. And he's actually started implementing some of these talks that I have with him to the other people on our team, and it's made our team more productive as well, and our team talks better to each other as well. The next thing I did was I got organized. If any of you have seen Scott Lowe's blog post on Inbox Zero, he did it at Kansas City VMUG many years ago, and I've been using it since then. I kind of faded away from it, and I've gone back to it. Instead of seeing everything in your email inbox every single time and you focus on those things that you haven't got done, I sort them out via this Inbox Zero process, and then I only see the stuff I need to work on at that point in time. If you haven't read Scott Blow's blog post on this, go check it out. I've got it at the end of this. The other thing I had to do was track my to-do list both at home and at work. I started using Todoist for that, and I can show you I've got all my honey-do lists on there for my wife, plus everything I need to get done at work. Lastly, I had to talk my wife into using a shared calendar. There's so many times with kids and with her schedule as a teacher and stuff, I didn't know where we were going. She didn't know where I was going. I'd been trying to get her to do it for years, and now we do it. So I can open up my calendar and see when the kids have Girl Scouts, when they have Taekwondo, when they have whatever, when my wife has stuff, when I have stuff, and we share those for everything. Like I said, I like going dirt track racing. I put all the dirt track races I want to go to on the calendar for like 6 months out as I would like to go to this if we have nothing else going on, and then she knows in advance. The next thing I had to do was make time for myself. As you get busy with work and with your home life, it becomes A, very, very hard to do this, and B, you kind of feel bad that you're getting away from your wife and kids. You feel guilty, right, for taking that time. But if you don't take that time for yourself, you'll have both physical and mental challenges with not only yourself, but your kids. As I was going through this the second time, I had kids at that point in time. And taking a step back, I could see in my kids that they were starting to mirror things I was doing. The next thing I had to do was positive reflection. I keep track of things that I like, positive things in my life, and I go back and I think about those. As I talked about, I came from a blue-collar family. My parents have no post-high school education. I've made it through college. Look where I've made it to in my IT career. I've presented numerous times here at VMworld. Don't forget those things that you've accomplished. Don't forget the things that have happened to you, like praise that you've gotten as well too. Go back and look at those as well. The next thing I did is I started volunteering. Last year, I went down to Houston for a week with Team Rubicon that I volunteer with and did disaster relief work. When you go down there and you see people in a tent city, it really puts into perspective what you have going on in your life, right? It makes you want to figure things out instead of just sitting back and focusing on things that you don't have. The last thing I do is I reach out to others, a la here presenting to you guys. I posted my blog post on the topic, and it's kind of gone out a lot of places. I reached out to people in my community. I have lunch once a week with some people, once every other week with other people, and we talk about how we're doing in life, how we're doing at work, how we're doing at home. We try to keep work stuff out of it. And it works. Reach out to people who are doing simple things that you see that are doing them well. These are some feedback that I've gotten over the last year that I tuck away in that folder that I can go back when I'm starting to be down and remind myself that I'm not as bad as I think I am, right? Simple things is I sent an email to or a text message to a friend of mine and wished him Merry Christmas and sent my card to him personally and said I was thinking about you. And then I get a tweet back, you know, publicly saying how much of a classy guy I am. I was having a shitty day that day. Shitty day. And then all of a sudden my notifications pop up and you see that, take a deep breath, it's not that bad, and move on. First time I gave this presentation, I got home that night, I got this email. Reach out to others because you don't know how much just your experiences can help them. I started crying that night I got this. If I can help somebody else, it's worth it. In conclusion, take back your life, look for the symptoms in yourself and others, figure out your strategies and don't give up on them or change to a new one. And finally, pay it forward. Pay it forward like we do with the technical content, do it with this content as well too. You'll be amazed at how much it'll help you and everyone else. If I could spend an hour, I could show you all the amount of people that have messaged me and said, I've been feeling this way for years. I didn't know what to do until I read your blog post. Thank you so much. Finally, here's some resources that if you want to research to go out on your own before talking with others, has very good content at the top, even texting if you're into that stuff. At the bottom, there's Sonia Cuff has a mental health link of other podcasts, blog posts and everything that revolve around depression and IT as well. The Xenarchic Effect by Eric Shanks, you might have seen this on some podcasts and stuff. He wrote this just after I had posted mine about focusing on tasks. And then the last, Inbox Zero by Scott Lowe. And I'm done.
Hey everybody, welcome to VMworld 2018. Thank you for joining me in my tech talk today called Talking Priorities and How You're Lying to Yourself. Little bit of an disclaimer before I get started. Everybody's priority is going to be a little bit different, obviously, right? Everybody has different life situations. This is just kind of a presentation about how I've dealt with mine and how I learned from it and changed to it. So before we get started, what are some of the common priorities that we have in life? Obviously, we have our family. We have our health, physical and mental health. We have our money, which everybody loves. We have our friends. And then finally, the most important one is we have our work. So when it comes down to it, what are your top priorities? Everybody likes to say that they need money. They always need money. That's why they do work. And, but they always say that the top priority is their family. But when you really look into it, top priority, when you say it's family, it usually gets taken over by something called the hostile takeover. And my hostile takeover that I had was about 6 months ago when one of the members of our team actually left. I needed to fill in the gaps of what that team member left behind, sorry. So it required me to work every day from 9 a.m. to 9 p.m. at night, 5 days a week and most weekends. It was something that I willingly did. Nobody asked me to do it, but I felt like I could step up and kind of take ownership of this particular position that was left open. And it's a hostile takeover. And we have all different ones. Some of ours are family hostile takeovers where we have urgency in family. Some of them are money. A big financial strain gets put on you without you noticing, an emergency that comes to work. Hostile takeovers are really things that dictate our priorities, even though we don't really want them to, sometimes even though they're willingly. So when I was going through this time of working between 9 in the morning and 9 at night, I would tell myself particular things to make myself feel better about how I was abusing my other priorities, my family, my friends, my health. One of the things I would say is that I'm making a lot of money. So what's the problem, right? I'm an hourly employee. I made a lot of money when I work overtime. But one of the things that I would say to myself is that even though I don't see my kids, even though I don't see my wife, I'm still making a lot of money to support my family financially, making sure my kids have a roof over their head, which is another one of my top priorities, obviously, is our family. Another thing that I would say is that I'll go to the next one, right? Going to the next one. Every time you have to miss a family function, miss a barbecue, miss a birthday, you always say to yourself, I'll go to the next one, right? And we keep consistently saying that to ourselves just to make ourselves feel better. And I did that constantly over the last 6 months that I was having this this hostile takeover of my priorities. And the one that really got me before everything else is, I would say to myself, the kids won't even notice, right? I'm a father of 3. I have 3 beautiful kids, and I would say to myself, to make myself feel better, that I wouldn't see them at 2-week spans because I had to work weekends, and I would leave before they got up for school. I'd get home, they'd already be in bed. I would work every weekend, and I would say to myself, the kids won't even notice. My 6-year-old, he has the memory of a goldfish, I would say to myself, right? Even though it's not true. When we tell ourselves these things, it's us trying to justify abusing our other priorities that we hold so sacred to ourselves, right? My family is my #1 priority, or at least I thought. So one of the things that I had to do was learn how to adapt and change with the priorities that are coming at us, right? We have to adapt to the situations that we get thrown in that we don't have control over, and we have to learn how to come up with a plan to change that. We're all in IT. We love troubleshooting things, but when it comes to our own priorities in our own life, we really don't troubleshoot as we should, right? Is that a valid statement? I mean, it's one of those things that I love solving problems when it comes to technology, but I hate solving problems when it comes to my life, right? So I had to learn how to adapt. I had to learn how to literally take a step back of how my life was and figure out, how do I make an active change in this particular situation that I'm in? I'm working 12 hours a day. I work most weekends. I'm making a lot of money, that's great, but I'm not happy about it. I have to learn how to adapt in this situation that we're in so I can kind of control my emotions and what I'm feeling when I'm thrown into these different priorities that we have. And changing is coming up with a plan that I did, starting saying particular things to people when they were throwing all kinds of tasks to me. Like one of them is saying no, right? I hated to say no anytime somebody asked me to do something, regardless if it was the smallest task in the world. It could be I need a keyboard changed out and the help desk guy wasn't there. I would go and change that keyboard even though I was working on something really important in front of me. I had to learn how to change my behavior. Whoop. And then also, one of the things that we have to do is start to prioritize our priorities, right? We have to think about what realistically is going to be a top priority of our day. We all have small tasks that we have to do throughout the day, 15, 20 small tasks that take 5 minutes to do. We all have big tasks that we have to do throughout the day. So one of the things that we actually, that I actually came up with is I would do all my big tasks, regardless of how big they were. I'd spend about half my day doing all that. The little task, on the other hand, I would get done in bulk. So I would do a big task, maybe configure an ESX host that I do all the time, and then in between that, I would do 5 tasks and then go back to the big tasks. Prioritizing your priorities, not only in work but also in life, is a big, sorry, I'm blanking there for a second. Prioritizing your priorities also in life is also it's very important. You got to prioritize if you going out with your friends that weekend is good for your family. You got to prioritize if your son wants to go out to the movies, if that's feasible in that particular time when you have something else that you have to do at home. So one of the other things that came up was starting to manage the expectations with people at work and also people like my friends and my family. So managing expectations at work came along with, not everything that you give to me am I going to be able to do right now, right? Like I said before, I hate saying no to people, but I had to learn how to manage the expectations and how realistic my time is, right? If you're going to ask me to do 15 or 20 different tasks within a day, it's just not going to happen. I can't prioritize. We're all human, right? We're not robots. We're not computers, right? Even though we like to think that we are sometimes. We have to manage the expectations of the people around us. And that one of those things is learning how to say no obviously. Say no to people. It doesn't mean that you're unwilling or lazy to work when you say no to somebody. Actually, quite the opposite. It means that you have all your tasks in order, you have all your tasks straight, and you know how to do them, and you have a plan on how to do them. You're prioritizing your tasks that you have, which is also prioritizing your work priorities that you have. The other thing is don't be afraid to push back on your management. People hate that. When a manager comes up to you and says something along the lines of, I need you to do this right now, everybody just says yes, right? Even though they have 10, 15 other tasks that they need to do, they're overloaded with work, but anytime your manager comes up to you and says, I need you to do this right now, they never push back. They get overloaded, their work gets really crappy, honestly. Once you start to get 15 or 20 tasks within a day, you're trying to focus and you're trying to switch from one thing all the way to the other and back and forth the whole day, right? Don't be afraid to push back on your management, and also don't be afraid to push back on other things too, like your family and your friends. Managing expectations doesn't only come with work, right? It comes with your family and your friends as well. Your friends may say, I want to go out this weekend and party, but you have to work. You're on call this weekend, you can't go out. You got to manage the expectations of how your work-life balance is really, your company doesn't really care about your work-life balance, right? So one of the things that your family and your friends like to know is like, why can't I see you more than that? Why are you working all the time? One of the things is my company pays me to work. They don't pay me to have good work-life balance. Every quarter where my company shows their financial reports, there's not a line over there that says Frank's work-life balance, right? It doesn't work that way. So managing the expectations with your family and your friends is a big part of the all-around managing the expectations of your priorities. And what I found when managing your expectations and kind of prioritizing your priorities, you come up with a pretty good formula on where your priorities and how much interest, urgency, and importance you should have in those things. Not everything's going to be important just because you think it's important, right? Not everything's going to be urgent just because you think it's urgent. Everybody needs to make their own judgment on what they think is an important priority, an urgent priority. One of those things is saying simply, will something break if I don't do this? If I need to do it within the next 3 minutes, is my whole data center going to go down if I don't do it? Is something going to burn down? Then I will have urgency in that situation. If it's important to you, but you've been planning this for 3 weeks and you just came up to me and you need it by the end of today, that's important to you. It should not be important to me just because you need it. And your piss poor planning did nothing for me, right? You had 3 weeks to plan this, but yet you came up to me the day that you needed it and then expected me to do it for you. So urgency, important, and then also interest as well. Everybody's interested in their work, hopefully, right? Everybody's interested in their hobbies that they have. One of the things that I found out is that there's a pretty good formula for everything that we do when it comes to our priorities, right? And this was actually a really good exercise when I did this. I was trying to come up with a perfect mix of what I think that all my priorities should have equal parts of: interest, urgency, and importance, right? So the first one's on our health. It's about 80% importance, I'd say, about 15% urgency and 5% interest. If you're any more than 5% interested in your health other than working out, you're a sick human being, right? If you like getting your tooth pulled, you like getting surgeries and stuff, you need help, right? Not only physical, but mental help as well, right? And then what about your priorities, right? Your priorities are something else. Everybody keeps thinking family, friends, work, money. But what about the priorities that you hold for yourself? I like riding motorcycles, right? It's not an urgent priority. Nothing's gonna happen if I don't ride my motorcycle, but it interests me. It's important to me, my mental health, that I get time, to handle my own priorities as well, even though they may not be my top priorities. But the next one would be your work, right? Urgency, I'd like to say, is about 60% of my work priorities. Anything that's going to break, obviously, I take that over as soon as possible. Importance, and then interest. And I've gotten a lot of flack about this one because interest is actually very low. It's not that I'm not interested in my work, right? Everybody's interested in their work. It's just, it's still work. You'd rather be doing something else pretty much any time you want to, unless you work at the most perfect company in the world where you don't have to do anything, you can just do your hobbies all day long, and then they pay you truckloads of money, right? The urgency that comes from the work, the importance that comes from the work, just kind of overinflates the interest, because there's always going to be something that you're not interested in, or they have very little interest in, that you're going to be doing at work that takes over your priorities. The last one is your family. And I like this as equal parts. This is what I came up with. It's interesting, right? I like taking my kids fun places, interesting places that I find, camping. It's important to me that I spend time with my family, my wife, my kids, my friends, and also the urgency that comes in with having, you know, your family emergencies. Hopefully they don't happen to you, your kids. It's urgent that I get to, you know, really see them and kind of, you know, spend a lot of time with them, even though in the past, you know, couple of years when I was trying to figure this whole process out of kind of prioritizing my priorities, it really shined on me that it's urgent that I see my kids, not just important, right? So I got a question for you. I need 3 people in the crowd who are not government employees and also are not shy. Anybody? You, sir. Out of the 3 priorities, you got family, you got your work, and you got your money. Which one's your top priority? Family, okay. I'm gonna give you this, right? There you go. That's signed personally by me. I drew that last night, by the way. Maybe worth a couple $1 million one of these days. Anybody else? Come on, I need 2 more people at least. What about you? What's your top priority? Family, money, or work? Family? There you go. That's for you. Thank you very much. Once again, hand sign. I try to make these as kind of gender neutral as possible as well. I mean, one of them, this one has a mullet. So if anybody wants the mullet one, I need 1 more person. Anybody else? You, sir. Family as well. Can you pass this down to him for me? Thank you very much. Now, everybody here says that their family is their biggest priority. That's an obvious answer, right? Nobody's gonna say my work is my biggest priority. You'll sound like an asshole, right? Nobody's gonna say money's my biggest priority. You'll also sound like an ass, right? Everybody's gonna say family is their biggest priority, right? So you 3 gentlemen, if I can have you just stand right here for me, right? What's that? Oh, you won't be in a minute. You definitely won't be in a minute. So there you go. So I'm your manager, right? Oh, okay, yeah, you guys can go over. They're telling you guys to go over there, so that's fine. We'll work with it, right? So I'm gonna be your manager, right? You, sir, I need you to work this weekend, right? It's your kid's birthday party, but I need you to work this weekend. Here you go, take that laptop for me. I like it, thank you. Are you an hourly employee or salary? Hourly, I like that. You want some overtime? Ooh, not that one. I'll give you the big bucks, man. There you go, $100, give me that. It's a Surface Pro. It's worth a lot more than $100, right? And what about you, sir? Salary, okay. Well, you know what the thing about that is that I can work you goddamn as hard as I want. I still have to pay you the same amount, right? So I need you to work on all those POCs for me. I need you to, I know everybody seems busy right now, right? Everybody in your colleagues are seeming busy and things like that, but you're the star. You're my main man, right? You're the one that I want to work with those POCs, and I want you to be awesome, and just, you're going to be fantastic once all your colleagues get done doing whatever the hell they're doing. I don't even know what they're doing, right? So here's the thing. Just because you are the star of the show, just because you're running the show, does not mean that you don't have a choice. Every one of you had a choice to say no to me, right? If I am your manager, you could have said, I don't want to work this weekend, I have my kid's birthday party. You, on the other hand, said, I like money, but I like my family more. And you're the star, you're on salary, my friend. You're overloaded by work anyway, right? So you're gonna have to work weekends now, right? So, desires dictate our priorities, priorities shape our choices, and our choices determine our actions. Everybody up here had a choice. So what I'm gonna do, I'm gonna take my Surface back because I need that for work. Thank you very much. You can keep that. I'm definitely gonna take that back. Thank you very much. You can keep that. And you can keep those because I don't want those. Okay. Thank you. So you guys can go back to your seat. Thank you very much. Let's have a round of applause for all of our wonderful volunteers. Fantastic. Yeah, you can keep that. Yeah, go ahead, go ahead. It's a Walmart frame. It's expensive. It's plastic. The real thing's glass, so I don't know if you'll be able to make it through TSA with it, right? But it's okay. So before I figured out this process, right, I was doing multiple things. Number one, I was abusing my priorities. I was abusing myself. I love that hat, by the way. I can never find another one. That one broke, but I love that. I look like I'm Amish and I make cheese for a living. It's fantastic, all right? I was abusing my friends, and more importantly to me, I was abusing my family. But until I prioritized my priorities, I started managing expectations, and I knew that I had a choice in what I can do on a day-to-day basis, right? I started prioritizing, I started managing my life, I started managing expectations for my family, my friends, my work, my managers, my colleagues, and I feel better about myself. And realistically, I found the perfect mixture of my priorities that I have. And it's really helped. So on closing, everybody here has a choice, and I hope you guys make it to the best of your ability. I hope you push back on your expectations from your managers. I hope you push back on the expectations of your family and your friends. And I hope that none of you have to ever have it be in a choice where you have to pick between your family or your friends, or your work, or your money. Thank you very much.
Hey, how's it going? Good it's almost noon. It's afternoon now, right? How's it going? My name's Gabriel Chapman. I am here on behalf of NetApp. I'm going to talk to you a little bit about hyper-converged or hybrid cloud or both. We know that hyper-converged infrastructure is a very popular technology today. I've worked in this space for a while. A little bit about me. I've been in technology for over 20 plus years, unfortunately. Been working on the vendor side for the last 7 or so. I lead go-to-market strategy at NetApp for our cloud infrastructure technologies, which kind of encompasses a whole suite of technology, whether it's hyper-converged, converged infrastructure, analytics, object storage, and all flash scale-out technologies. This is my 8th year at VMworld. I started in 2010. I've been a vExpert for the last 7 years. I've been heavily focused in the VMware community. And today I'm here on behalf of NetApp, really kind of want to talk to you about some things that we have going on. If we look at, always how familiar people are with hyper-converged infrastructure, but the reality is if we look at that marketplace, what we see is that a collapse of a traditional infrastructure stack of technologies, whether it's servers, switches, storage arrays, etc., taking those technologies, packaging them up into a building block-based approach, right? I mean, I spent, the better part of 2005 to 2009 virtualizing everything in my data center at the server layer. What hyperconverged was take that a step further, because at the end of the day, what are those systems? They're a bunch of commodity x86 servers running some form of Linux. I should be able to virtualize those those constructs and put them into a scalable building block approach that will allow you to facilitate the bulk of the workloads that you have on a daily basis. One part about that that's really beneficial, the value that a lot of people see, is the simplification effort. Is being able to take all of those things, provide an interconnected awareness, and simply deploy them. So you have a magic deployment mechanism and a magic management mechanism, and you can bake those into existing products like vCenter, or you can build your own kind of master control plane and manage it outside of vCenter and manage multiple hypervisors and multiple clusters of resources or whatnot. But the idea behind it primarily is a simplification effort to rapidly deploying resources and then making it simple enough where any of your VM admins or people within a cross-functional team have the ability to manage and provision infrastructure. It's a fairly crowded space. I mean, this is not everybody that's in there. There's probably about 30 to 35 companies that actually provide some kind of hyper-converged infrastructure solution. And what we're starting to see is obviously the consolidation. We saw, Hewlett-Packard acquire somebody, Cisco's acquired a company to bring technology in. You have others that are focused around, pure PaaS, containers as a service, as well as OpenStack type offerings, but the vast majority are focused on a single type of architecture, which essentially takes commodity x86 and does a shared core methodology where you're basically running a controller virtual machine that can attach and provision all the resources, and that takes a little bit of resources and overhead, but then your trade-off there is the simplification effort, right? I would expect over the course of the next 3 years. Many of the companies who've kind of come into this space may or may not be here. We saw the same thing happen in the storage world, where the best of the breed type got all acquired, and then everybody else kind of struggles or simply goes away, or that's common with a lot of disruptive technologies. If we look at what some of the analysts will say, HCI is the area that we're trying to focus on. We've beaten the whole process of the consolidation effort, like bringing everything down into simple appliances that scale to meet most of your needs. But now the shift is to how do we integrate with the public cloud? How do we provide or provision a hybrid cloud integration points, right? It's one thing to build infrastructure locally that I play with, but almost every company or customer I talk to has some kind of cloud strategy they're looking to. And the biggest issue for them is how do I bridge the gap between what I've built locally and how I operate in the public cloud space. So if I'm building and provisioning infrastructure applications in Amazon, how do I pull that back down locally so that I'm not doing this massive translation effort, I'm not having to do 2 different development paths, and we see containerization being one of the main points that allows for that to happen, a simplification allowing that to happen, because we look at how the prevalence of Docker, the expansion of the Docker ecosystem, now Kubernetes taking on such a big lead role there, and you're seeing more of the public clouds try to offer some kind of containerization as a service offering because they want to be able to build those new next generation applications and then bring them down into the data center, and by nature, containers offer portability. If we look at what matters for customers that are building cloud infrastructure locally in their own data centers, I have all the work that I've done in the traditional data center. I mean, up until about 2010 or 11, this was my life and focus. I built, single purpose platforms, single tenant, isolated workloads. I would build silos of resources for virtual desktops, and I would do a silo for databases, and I'd do another silo here and there. And then I had this, I was not getting the efficiencies of scale that we see with the cloud provider. If I go to Amazon, or if I go to Google, or I go to Azure, they've taken care of all the plumbing for you. You're just consuming resources. And I think a lot of people in IT would like to be able to say, yes, I can basically provide you with compute, storage, and memory, and a layer to provision those in some kind of self-service portal, and you just consume it the same way you would go as if you swiped your card up in the public cloud. And the areas of focal points of cloud infrastructure have a different set of rules and requirements. They usually focus on multi-tenancy or mixed workloads. It's usually a shared infrastructure solution. It's traditionally more scale out than scale up in many respects. It has to be flexible. It has to be able to provide significant levels of automation, i.e. it has to be 100% API addressable. And so that's where we're going in terms of infrastructure that bridges the gap. And I think we're starting to see that in the beginning, hyperconverged was kind of focused on that traditional silo, and now it needs to transition into the cloud silo or cloud space. Most of our customers kind of have 3 things we seem to commonly. It's like everybody wants to say, hey, I want to deliver something faster, cheaper, and better. I want to make sure that my people can come in and leverage our own technical resources instead of continuing to expand into shadow IT or expand into the public cloud, when I should be able to control those. And there may be reasons for that. It could be governance, it could be security, it could just be a mistrust. Many of the customers I talk to, all of them kind of say, hey, I want to operate like Amazon does. Well, I'm like, you know what? That's an aspirational goal. Because most people would like to be able to do that. But they do want to take those characteristics, rapid provisioning, scalability, guaranteed performance, and they want to bake those into the infrastructure solutions that they're building. And hyperconverged is kind of a good start to go there, but I think we need to go a bit further and bring more of that cloud goodness into the platform. The last part is predictable performance. It's one thing if getting away from the silo-based model and being able to cohabitate your production, your dev test, your QA on the same common infrastructure, and at the same time put a walled garden around each one of those so that they're not competing for resources, is a significant step in moving towards really delivering cloud infrastructure in your data center. Because you don't want to have to maintain 3 separate silos of infrastructure. Even if you're able to cohabitate mixed workloads, you can take it a step further and get great economies of scale, especially at the data layer if you're able to do say global inline dedupe compression, thin provisioning, etc., and make that 100% API addressable to automate as much of that stuff. So we kind of see these 3 areas: delivering things faster, operating like a cloud, and providing predictable performance. as being hallmark points to that transition to being more of a hybrid cloud infrastructure solution instead of just focused on your day-to-day VMware admin. And that's where we see a lot of HCI 1.0. Pimping a product, right? So I'm going to talk about what we've done in terms of how we looked at the market. Obviously, NetApp is not the first entrant into hyper-converged infrastructure, but we did look at the space as a whole over time in the last couple of years and looked at our own internal portfolio of intellectual property and said, well, we think that as we start to move forward and as we see more and more cloud, it becomes the predominant mode of delivery, we need to make sure that we can bake a solution or provide a solution that provides predictability, i.e. predictability for workloads or applications and performance. We've always been able to do a little bit of performance predictability through scheduling resource pools, et cetera, inside the virtualization space, but moving into the storage layer was always a bit of a challenge. Flexibility to scale on your terms. I can scale my compute and storage independent of each other without kind of making you take a lockstep approach. That's, if we're doing cloud type solutions, I don't want to have to strand a bunch of resources someplace because of an arbitrarily method to scale everything in lockstep. And simplification simply means, hey, there's no book called The Joy of Menial Tasks, so therefore if I have to do something more than once, I should be able to automate it. For us, what we've done is with 25 years history in servicing data and data workloads and working with cloud providers, et cetera, we wanted to take all the experience that we had in the enterprise space and put that into a hyper-converged solution and really kind of work towards shifting this from just traditional infrastructure sits on your dock or in your data center and how it extends into several different areas. Obviously, we want the kind of scale out agility that most customers are looking for in terms of building a robust private cloud infrastructure. So you can start small, scale non-disruptively. We're going to get rid of the whole concept of forklift upgrades. A lot of this is table stakes for hyper-converged and even more so into hybrid cloud. And for us, the differentiation pieces around it are, we want to be able to go after and tackle those infrastructure as a service type offerings where performance and workload consolidation are primary and big. We want to have simple automated infrastructure workflows and integration points with common third-party tools and platforms. So whether it's Puppet, Chef, or Ansible, PowerShell, vRealize, et cetera, those are the types of integration points we want to bring in. We also want to make sure that as a company that has a portfolio of technologies, that there is still interconnected awareness. We have a concept called the data fabric that allows for workload mobility and data mobility and information, inspection and security across multiple different platforms. So I can take a volume or a set of workloads running on a hyper-converged and snap mirror them onto a traditional storage array, or maybe even put them up into the cloud. It's that kind of broader expanse of not trapping the data on any one consumption model and freeing it up to go where you need to use it. So in how the hybrid converged infrastructure piece of this or hybrid cloud infrastructure piece of this comes is, we start off as, hey, I'm going to come into an organization, we want to talk to them or say, hey, simplification of your common infrastructure applications. So it's virtual desktops, it's your test dev, it's your enterprise tier 1 apps and down below. Great. You have a hyper-converged infrastructure solution here that can facilitate those. This is kind of HCI 101. Going further though, how do we leverage your existing infrastructure assets? If you've purchased NetApp ONTAP technologies, if you've wanted to leverage the own compute that you have sitting on the floor, how do we integrate those into a hyper-converged solution that sits on the floor? Because we want to take that Borg approach where it's like, we're not going to lift and shift everything all at once, but we can over time move workloads over and continue to get investment protection with your existing solutions. So we have an open storage model, i.e. you can bring your bare metal instances, an alternative hypervisor, you can go straight with Kubernetes and connect those into the HCI space and leverage the storage technologies in there and get the benefits of that predictability through guaranteed quality of service, et cetera. But also it's the ability to move data and workloads between the HCI platform and other common NetApp technologies and products. Furthermore, we've always been really keen about the open source environment and making sure that these next generational workloads, if you haven't had DevOps pounded in your head for the last 4 or 5 years, I don't know if you've been on the planet Earth, but that move towards looking at infrastructure as a service, continuous integration, continuous development pipelines, the entire DevOps movement, and that shift to containerization, which I think is starting to make more inroads into what we consider hyper-converged infrastructure. It could be, container-based infrastructure. So we want to really go after that. And then there's some existing workloads that are starting to come to prevalence. So whether it's AI, ML, IoT, we're looking to make sure that the platform is kind of future-proof to facilitate and work into those areas as well. The last part here is the public cloud. And we've been working with Amazon and Google and Azure for a while now to provide services in the public cloud, whether it's NFS as a service through our Cloud Volumes implementation. We want to make sure that we have the means to bring that back down into your local data center as well. So if you've done workflows and if you've leveraged something like Cloud Volumes on Amazon, there's going to come a point in time when you want to leverage that additionally on premises. So being able to extend your data footprint or management aspects down into your local data center is one way that you can approach that and build more of a hybrid cloud infrastructure solution. So it looks like my time is up. Good thing, because this was my last slide. And I want to thank everybody for attending. Obviously, if you have more questions, you can always come to NetApp and take a look at our website. We'll have lots of information about this, and look for us at VMworld Europe coming up soon. So thank you.
Principal engineer at VMware. I joined VMware in 2000, left in 2012. I started Datrium, co-founder of a company called Datrium in 2013. I've been involved with storage, hypervisor, or Java virtual machines in some way, in one way or other, for about 20 years now. So disasters do happen. It's rare, but it does happen. This is an actual photo sent by one of our customers from Sonoma County. As you know, last year there were wildfires, and you can see the red arrow pointing to where his data center was. So this is an actual customer photo. Another one, after Hurricane Harvey, data center is completely flooded. That data center isn't coming up anytime soon, right? So this stuff does happen. So when we talk to customers, we ask them, what's your DR plan? And true story from one IT admin we talked to, he said, plan A, my plan A is to never have a disaster. And then we ask him, okay, what if there is a disaster? That's plan B. Plan B is for me to die in the disaster so that I don't have to recover from it. It's an actual story. So the reason why he said that is you can see on the right side. According to Gartner, 94% of disaster recovery plans cannot meet their recovery point objective or recovery time objective. The whole thing is pretty fragile and complicated. And that's because disaster recovery plans, orchestration software, and the primary storage and the backup and all the infra behind it, it was not designed for this. It evolved into this shape over a period of 15, 20 years. It really was not designed, it evolved. So for example, if you use backup for disaster recovery, there's many copies of data. You have your primary storage, and then there's a backup. And if there's a backup admin in the audience, I am sure this has happened to you. When you try to recover from backup, when you try to restore, the restore fails. And now what happens to your RPO for DR, right? So copies of data is one problem. The second problem is it's super expensive because you're going to have to maintain a DR site running just in the event of a disaster, like just for recovery. You might be able to run some load on it, but the thing is going to cost you a lot more because you just have the site running there. The third piece is it's a complex distributed system. If you're virtualized, you have site recovery manager, then you have your primary storage, perhaps backup, and all of these things need to work together, and they were not really designed to work together well because it's from different vendors. There are different infra silos. Everything working seamlessly is not really common. And to illustrate my point, this is the set of steps you need to do if you're using backup and recover from backup in the event of a disaster. I cannot walk you through all this. There are 21 steps here, and these steps are not really simple steps. So for example, one of the steps here is, okay, I need to promote my primary LUN, promote my LUN replica into primary. I wrote this as one step, but it doesn't work as a simple step and everything works, right? Who knows what's going to happen when you recover from backup and then promote this and all that. So it's what could go wrong? A lot of things. So then along came cloud, and DR to cloud was promising. So there are many potential benefits to this approach. So For example, maybe this simplifies DR management so that you don't have to manage the DR plan and keep all of these things running. Maybe you could fail over to cloud resources, which are elastic, so that you don't have the data center running up there all the time. And so maybe you pay only when there's a disaster. So the promise is there, but the reality is still complicated. So first off, the on-prem complexity still persists. You still have a prem data center that's complicated that needs to work with your cloud data center. The second point is, until recently, if you had vSphere on-prem and you wanted to fail over in the event of a disaster to, say, AWS, you invariably ended up having to convert VMs from one format to other, and this is when you should run for cover. It is very fragile to do that. VMC thankfully solved that. The third one is relates to the previous one. You have your prem infra, you use vSphere to manage it, and you're used to the vSphere tooling. And then in the event of a disaster, unless you have the same exact tool set and management experience, it's going to be very painful. And the final point with the current state of cloud DR is the choice between recovery point objective and cost. So let me go into that in a bit more detail. On the y-axis, you see recovery point objective. The higher the RPO, the worse off you are. On the x-axis, you see cost. The higher the cost, worse off you are, right? So on the top left, you see backup-based solutions. If you think about backup, you cannot realistically have a 1-minute RPO backup. It just doesn't work. It's going to kill your primary storage if you do that. So backup RPO, usually you're thinking hours, 1-2 hours. Even that can be tight depending on your infrastructure. So you have a very high RPO with backup-based approaches. But once the backup is taken, most good backup software like Veeam, they can take the backup, store it in S3, Amazon S3, which is cost optimized, and then maybe they can provide you with DR to VMware Cloud on AWS. Maybe it's possible. On the right bottom is primary storage based approaches. Here you have a very low RPO, mostly synchronous replication based, like vSphere replication based. Here the issue is that you need SDDC up there running all the time to receive the replication. So you're not really saving on the DR side. In fact, your cloud cost can be very significant if you have to keep a cloud data center running all the time just to receive replication in the event of a disaster. So that's the bottom right. So you have this trade-off to make between RPO and cost in most approaches today. So let's take a step back and ask what it should be. Like, what would customers like the experience to be? So first off, it should be easy and consistent to operate. You don't need to learn two interfaces. It just should be the same thing. Second, you should not have to make a trade-off between low RTO and low RPO. It should be low RTO, low RPO. And you should not have to create a DR data center till the event of a disaster. You don't want to pay for it. You want to create it on demand. And the last part goes back to my original slide with the 21 steps, right? It should be bulletproof. Very, very few vendors, if any, can say, yeah, our DR plans are bulletproof. It's super hard. So you need bulletproof failover and bulletproof failback across backup and DR. So if you break it down into components, what do you need for DR to cloud? So as I said earlier, first you need low RPO backups in the cloud. Second, you need the DR orchestration service to be running in the cloud. You don't want to be installing and managing things. You want to consume DR orchestration as a service. You should not have to install, manage, configure, test. None of these things should be done by you. It's not necessary. It's a waste of time. Third, you need an SDDC on demand, which VMware and AWS already have produced. And the final piece is, you of course need an on-prem data center. I am assuming that you are interested in a hybrid cloud solution, and you have prem workloads and you have cloud workloads. So you need a great prem data center. So if you think of these as the requirements, this is what Datrium and VMware Cloud on AWS do for you together. So first off, you have a prem data center. I'll go into how we work in your prem data center in the next slide. Basically, Datrium is a software-defined storage platform that combines primary, backup, archival, and DR in one platform. I'll talk more about it later. So that's your prem data center. And then we take low RPO backups, 1 to 5 minute RPO backups, depending on your link bandwidth, and we can store these low RPO backups on S3. I'll touch on more details on all of this later. And then we have DR orchestration service that runs in the cloud called CloudShift. CloudShift knows about backups in the cloud and your prem data center and your DR plans. It's all in the cloud. And when there's a disaster, CloudShift orchestration service can take the backups from S3, provision an on-demand SDDC for you, instantiate all the VMs there, run your entire runbook, and produce a compliance report for you. All of this is offered as a service. There is nothing to install or manage. So breaking this down further, I am sure you have seen this slide. VMC has been really awesome, actually. VMware has been a great partner to work with, and the services they provide are pretty amazing. So first off, you have the first requirement solved. You don't pay for anything until there's a disaster. Your SDDC is on demand. Second, no VM conversion and consistent management prem to cloud. And third is now they're expanding 3 to 4 data centers per quarter around that rate. So you have data centers anywhere you want that you can use for in the event of a disaster. So more about Datrium. What is Datrium? We are basically a software-defined storage platform that is significantly more scalable than traditional HCI with built-in backup on premises and in the cloud, and we offer you radically different DR that's much more efficient. I'll go into brief detail about how the platform is architected. That is what lets us do all of these things. So think of Datrium as EC2 plus S3 or EC2 plus EBS. It's a two-layer HCI. Unlike traditional HCI, which collocates compute, flash, and storage all in the servers, we have a split architecture where at the top you have servers, what we call compute nodes. The compute nodes have caches in them, local caches, flash caches. Once the cache is local, you get great performance. But that's a topic for a different day. But the key part here is the servers are stateless, and you can scale the number of servers up to 128 servers in a single cluster. If a server fails, nothing happens. You don't have to rebuild, you don't have to do anything. I mean, it's a stateless server. At the bottom, you see what we call data nodes. These are cost-optimized capacity drives. You can chain all of these together and keep expanding capacity separately from compute, and you can put in a single cluster up to 2 petabyte of data nodes. And this is where you store the durable true copy of data and also backups. Datrium backups come in the form of snapshots that are super low RPO, that are forever incremental, compressed, deduplicated, and encrypted all in one go. So, and there is a backup catalog that goes with the built-in snapshots. Because as all of you know, just snapshots do not make backup. You need a catalog. You need policy binding that applies to VMs, not LUNs. So all of this is VM granularity. You can select a backup policy, apply to a set of VMs, and you can configure policies that dynamically adapt, for example, based on pattern matching. All of that is built into the platform, and the backups are stored locally on data nodes. And the third piece is these backups can be replicated to another prem site or up to the cloud. And the deep backups go on S3, and they still can be super low RPO. And again, the backups are forever incremental, deduped, compressed, and WAN optimized as well. So your networking is not prohibitively expensive. So once you have the backup there, the second piece is the CloudShift orchestration software. This is what is delivered as a SaaS service. The orchestration software itself runs on regular AWS, not the VMC side. It just runs in vanilla AWS. And it knows about all of your prem site. By the way, there can be more than one prem site. It knows about all of your prem sites. It knows about the backups that you stored in the cloud DVX on S3. And it knows about all of the VM configurations too. But the most important part, other than not having to manage it, is that because we have visibility into the entire data stack, we can do continuous verification. So for example, traditional backup, if you're a backup admin, I am sure that at least one backup restore in your life has gone wrong. What we do, because we have built-in backup, is we run continuous verification, where 4 times a day we can validate your backup and verify that it is in fact restorable, so that you don't have an unpleasant surprise when you try to restore it. The same thing goes for DR. And I believe this is completely unique, as far as I know at least, where we can run DR plan compliance checks. What I mean by that is this. Let's say you configure DR SRM runbook with a particular VM in it, and let's say something deletes that VM or something goes wrong, basically. You are not going to find out about it till you execute the failover. When you try to failover, you find that, oh, there's a VM missing, I can't complete my DR failover or failback. This is what we are trying to prevent. Because we have full stack visibility, what we can do is when anything changes, we automatically try to match the DR runbook with the state on the primary storage and on the backups. And if we figure out that this runbook cannot be applied to this DR plan and this storage state, we actually alert you at the time of change and say, look, you're going to have a problem if you try to execute this DR plan. That is what makes it bulletproof. There is really nothing for you to do. You just go fix the problem before the disaster happens. And now, back to the RPO versus cost trade-off. So if you look at what I just described, CloudShift delivers you low RPO because we can store low RPO backups in S3. You do not need an on-demand, you do not need a software-defined data center yet. So you have the low RPO backups up there, and cloud costs are low. You spin up, CloudShift will spin up a VMware SDDC for you when you need it. So you have solved both problems in one shot. And to put everything together, what we offer you is primary, backup, and a radically different efficient DR. It is easy and consistent to operate. You get low RTO and RPO. The DR infrastructure is not something you pay for all the time. You can pay for it when there's a disaster. And we do continuous compliance checks across the board to verify that your DR plan will work. It's bulletproof DR. So when there's a disaster, you don't need to die in it. You can deal with it. I think we have time for questions if you have. I'm happy to go into any level of detail. Come check us out at booth 3150. We have a demo of this product in the booth right now. Yes, yeah. So Datrium, the on-prem DVX, the two-layer HCI, plus built-in backup, plus the snapshots in S3 and the CloudShift are all Datrium products. S3 is obviously AWS. VMware is, the VMC is, we're an elite partner with VMware. So that's how we built all of this. Thank you.
Hi, my name is Gaurav, and I work out of Mumbai as an SE, which is a pre-sales engineer in India. Today we will be talking about the What's New session with vSphere 6.7, which was released in April. And there has been massive developments around 6.7, and it has been a major release. So I have formulated this a very condensed form, which is like I'm keeping it the agenda modern workload, the demands, how the workloads are changing right now, then what's new with vSphere 6.7, and then I have a bonus slider for 6.7 U1, which was discussed yesterday, but it has not been out, but I have managed to add a few points around the U1 as well. So let's jump directly into the modern workload demands. So now, what we have been seeing with other customers as well, and I myself work on field almost 95% of the time, the demand of workload has been really changing a lot. Now, VMware has been helping customers on the mission critical applications, business critical applications always. Right now, over a span of about 6 to 8 months, I have almost 95% of the customer talking about AI, ML, your HPC. The workload is really changing now, and I assume you might be having similar requirements in the same scale. Now, apart from that, the second part is the rapid growth to hybrid cloud. So now with the hybrid cloud, basically it was seen more seasonal, but this is one of the feature which has been really been adopted for about an year now. And then every customer has an expansion need. They might have an office in various locations, and depending on that, this is one of the major requirement right now. And last is always the security, and I cannot stress enough on the security. And to be honest, I'm with VMware for about 6 years, and security is one of the primary focus of VMware, and we take security really seriously. We have an internal alias which I use every now and then very often. The response time to that security questions are relatively very fast compared to the other questions that we have. So these are the technical innovations or challenges, customer challenges that we have on ground, and depending on that, we will be relating that to 6.7, why or how we are targeting each and every customer demand or customer challenges into a well-formulated 6.7 format. Right now, the first thing is the simple management at scale. So when we speak about simple management at scale, majorly the scale, if I have to speak about scale, customers, my customers in India, I have customers which run approximately 4,000, 5,000 VMs, and then I have VDI customers who are massively over 25,000. So scale has been one of our primary, goal play. Now with scale, we have to do simple management, which is again a point. With simple management, the major focus is the number of clicks. We need to reduce the number of clicks. It would be easier for you to manage. That's the primary focus. Then we have a comprehensive built-in security, and with security, we have been doing pretty good job in terms of vSphere or the hypervisor security to the VCSA or the vCenter security, and followed by the universal application platform, which is basically, again, going back to the HPC platform or the HPC, the demand of high performance computing. And then next is the seamless hybrid cloud experience. So how do we handle the hybrid part of it? How do we do a migration, or how do we assist customers to go to a model which is like a seasonal model? You go to hybrid, you can come back to your same vSphere platform on-prem. Now, I'll be double clicking on a few concepts, and then let me start with the management portion of it. First things first, 6.7. A direct upgrade from 5.5 is not supported to 6.7. You have to be at least at 6.0, and if you are at 6.5, then yes, you can go to 6.7 for sure. Now, what I've seen from my personal experience while speaking to the customer, one of the things, or the first thing that I recommend customer is, yes, we have 6.7. The first primary thing you need to check is the HCL. You need to make sure that your hardware does support 6.7. The HCL supports your hardware. The second part is the ecosystem. So when I say ecosystem, now VMware has the vCenter as one portion of it. Then you have the NSX plugging in, you have vSAN, you have an entire ecosystem there. Most of the customers would at least use more than the vSphere component of it. You will have maybe a backup solution. So you need to make sure you plan your upgrade according to that. Secondly, you might have to also check for the VMFS upgrade, and followed by your DV switches upgrade. Host profiles is one of the things that I have seen lately from a lot of customers. Now, while you upgrade your vSphere to 6.7, your host profiles might not work at the beginning. So you might have to get a new reference copy. So you would still need a detailed plan and charter out a plan, but this is the high level details. Apart from that, yes, in about 20 days, we have 5.5 going end of support. Now, coming to the major component or the heart of VMware, which is vCenter. And the reason I say vCenter, whenever I speak to the customers, they would always say that vCenter is one of the components that is really great. The SDK, the API integration, the third-party products, everything hooks into vCenter. Now, how are we making things better with the vCenter in terms of availability? With 6.5, we have something like an VCHA, which is basically the appliance model itself can be configured into in an HA mode. And similar to that, right now with vSphere 6.7, we do have a template for quick provisioning. Now, apart from quick provisioning, one of the things that I really like about vCenter is the no additional cost to database or Windows cost. Right now, I have I have a few customers who would really say that I do not want to have a SQL licensing cost or a Windows licensing cost. It's a pure Linux environment. So you would probably opt for this option. Now, I do have a lot of customers, and that too at large scale customers, about more than 10,000 VMs. We have tried from 6.0. We have been doing the vCenter, the Windows-based vCenter. We used to do the quorum disk, and we want to make it highly available. So now, in order to overcome that situation right now, we have an out-of-the-box vCenter appliance, which can be configured into a VCHA format, which is the best thing, or personally the greatest feature that I like right now. Apart from that, we have a Windows vCenter server. 6.7 would be the last release to support the Windows vCenter server. So in order to mitigate that, we do have a migration utility, which we will be talking about later, to move away from the Windows vCenter to an appliance model. Another great example, or another great feature with 6.7 is, so if you have been doing enhanced link mode. So when I say enhanced link mode, basically you have multiple sites, and I would say most of you would have multiple sites, either maybe for a DR or maybe for any other purpose, but you have multiple sites. So one of the requirements that has been always there, that how can I view multiple sites out of the single pane? So you use something like the enhanced link mode. So to set up enhanced link mode prior to 6.5, or till 6.5, we used to have 2 PSC, or the platform services controller. Then you used to have the vCenter server, and that's the only way you could get the enhanced link mode. Right now with 6.7, you can have embedded PSC and vCenter in an enhanced link mode, and it lies with the same, I believe the limit is still 15. And this is one of the greatest way where you can reduce the management hardware as well, because you don't need PSE, additional PSE, then you don't need a load balancer as well. So I did a brief a brief comparison between two of them. And if you look at the third row, which is like PSEHA, in the deployment of the enhanced link mode, which is included with PSE or an embedded model, you really don't need a load balancer. Now, you don't need no load balancer, then you absolutely would not require even the PSEHA to be configured. So everything would be single box, and you can absolutely do ELM. Now, coming to the next part of it. Now, we know what is supported. We just talked about enhanced link mode, and this is all fancy. So how do we start with the installation and migration path of it? Now, installation path of it is basically, the first thing is we have something like a Clarity UI, which is the HTML5 version, and I believe that that's one of the feature that has been awaited for a long time now. Now we have everything in Clarity UI built from scratch to make sure that every feature is made simple. We have to reduce the number of clicks, as well as we have to make it as simplified as we can. Now, migration, as we talked about. Let's say you have a Windows vCenter and you want to migrate to an appliance model. We have a migration utility coming out of the same ISO model. And apart from that, when you do the migration, you can pause, you can resume, and absolutely you have your old data that can be migrated back. Now, this is a brief demo of one of the features that's the backup. How do you take a backup of the vCenter appliance? So I'm logging into the 5480, which is the WAMI page of vCenter appliance, and this is the new UI that looks like. Now, in the summary, you can basically see all the health status. Another thing is in the monitor tab, this is something new. We have included the disks. If you look at the disks as well, it gives you details whether you are going full. The monitoring of the vCenter appliance itself has been really simplified, and you can pull the data. So this environment was built from scratch, so 1 day, 1 week was not available. But yeah, if you look at the disk section of it, it gives you each and every details pretty readily available as soon as you log in. And then we have the network tracks where you can actually see the packet drops or anything. Apart from that, this has been another feature is the services portion of it. Right now, initially till 6.5, we have to do a services-control all, or we have to restart the services. This has been really simplified. You have to log in, you can restart any of the services, you can stop any of the services, and this is again only with the 6.7 VCSA. Now, coming back to the update portion of it, which is again simplified, you can do an offline update or an online upgrade. Since 6.7 U1 is not available, this is in the latest version, but you can absolutely do an update from there. Now, administration, yes, you can change the password. Another advantage would be on the syslogs type of it. In syslog, we used to have only one target, and we used to send just one place. The logs would be forwarded just to one place. Right now, we can create 3 targets. If you have an SEIM tool or another target you want to configure, and then there are different protocols as well, and obviously TLS security again. Now, this is one of the most important part, backup. So if you look at it, you can. This is basically a file level backup. You have a third-party solution backup, image-based backup, which is still supported, which is still fine. But if you look at from a simplicity perspective of it, the backup has been very simplified. And also, one of the amazing part is the backup schedule. You can schedule backups. You can keep how many copies would you like to have, and seamlessly you can configure, a restore point of it. You want to retrieve maybe 4 to 5 backups at certain stage, and then you want to initiate a restore, you can do that. Now we talked about backup. I'm going to give you a quick rundown on the restore part of it, or how do we do a basic restore of the appliance. Now, if you look at it, this has come from the same ISO. I'm going to just give the backup folder path, and I have to enter the username and password. Once I enter that information, review, yes, this is giving me the path that you have configured while taking your backup. You took a backup, you went to that folder, you see that there is just one backup available. And you can go ahead, highlight that, you can select, and it will automatically pick up your detail, and then you can deploy, or you can specify the deployment. Because your vCenter was tagged to specific IP address or host name, we are trying to even retrieve that or keep the same name. So you enter the same name, and you go ahead. So basically now you're going to your cluster level and deploying the appliance. So this is your restore option. You can again go ahead and set the usernames and passwords. After the now, apart from the restore option, if you would like to change the size of the appliance, because those usually come in small, medium, XL, you can even change the size of the appliance in any case. Now, I'm choosing simple and data store, the same IP address, obviously, and then I'll go to the complete to the next step. And this will actually restore the complete appliance in a couple of minutes. Now, apart from this, one of the basic or the best feature about it, we have an integrated VROps now as well. So when I say we have an integrated VROps, now prior to the 6.7 version of it, there was VROps in it. But from the Clarity UI, you cannot configure the VROps. Now I'm going to give you a brief rundown from a CAN demo, how easy it is even to integrate or step into your VROps appliance. So basically, you have 2 models available even in the appliance. If you have an existing VROps 6.7, or if you want to deploy a new one. So I just logged into my vCenter appliance. I will go to the VROps tab, and it will give me an option. Even there is an option to view all use cases. If on the right hand side, you can view the use cases and click on install, or you can use the existing one. So both the options are available. Install, we have basically an install of local as well as online. Similar to that, existing environment you want to integrate. Obviously, you need 6.7 VROps to be integrated back to vSphere or the VCSA 6.7. Now, I will switch from here. I'm going to switch to a HOL lab after this. And I'll show you basic functionality, or what are the additional advantages or additional functionality that has been released with the VROps as well. So the simple configuration was done, and I came back to the VROps apply or the VCSA page. Now I go back to the VROps within the UI. So initially, prior to 6.7, I believe you would have to go back to a UI and configure or check all your workload. Right now, it is again integrated. Apart from that, if you go ahead, you can see all the appliance or your cluster details out of it, and we have made or we have streamlined VROps into basically 4 different components of it. So when we say streamlined or made VROps more better for use cases, we are optimizing the performance. Right now, what you need is basically you have a cluster and you don't know which workload is really consuming more memory or resources. So we give you those details on the optimized performance itself. Then you have an optimized capacity, and followed by troubleshooting, which is self-explanatory, and then you can manage the configuration going back to the vSphere client itself. Now, so with the vSphere feature client parity, so right now we have both the vSphere client as well as the HTML5. So when we go to the HTML5, there are certain features which are still not available. It has a 95% feature parity. So right now in the 6.5 U1, which was announced yesterday, we have a full feature parity, but that won't be available for quite some time. Now, this is a simple rundown even for the update manager, and with the update manager, you would look at how simplified the update manager has been with 6.7, and it would be at least like 50% of the number of clicks that it used to take in the previous version of it. So that's about the update manager or the VCSA. One of the features that you would absolutely like is the quick reboot, or we used to say optimized reboot. So what did we do with the quick reboot or single reboot upgrade? So we have large environments, and when we start to patch the environment, usually it takes about 15-20 minutes to at least patch a host, because it has to do all the changes. It has to pick up the configuration, go back to boot bank, alt boot bank. It has to make all those changes. So right now, what you can do is it's a single reboot upgrade from 6.5 to 6.7, which makes it pretty faster. Apart from that, if you are going into a quick reboot mode, which is basically you are already at 6.7, you want to do a quick reboot, which would only restart the ESXi host. So there won't be any restart of the complete hardware itself. The hardware won't be initialized from the top, but only the ESXi portion would be restarted. Now, I will give you a quick demo on the difference. If you will see, the difference on the left-hand side is a quick reboot, and on the right-hand side, it is a complete reboot. Now, with 6.7, quick reboot has been enabled by default. So what I did on the right-hand side, the host, I have just disabled quick reboot, and on the left-hand side, if you will see, the quick reboot enabled host. It is much faster. It would come back pretty fast. Whereas if you are looking at the right-hand side, it is still loading because it has to reinitialize the entire host. And whereas on the quick reboot, it does not have to go via the complete process, which is again a great process. If you have if you are looking at somewhere around 20 plus hosts, you still save a lot of time in an upgrade process itself. Now, with every version, we do have VMX upgrades. So prior to 6.5, we had VMX 13. Then right now we have VMX 14. So with VMX 14, there are majorly 3 to 4 enhancements. One of them is on the security portion of it again. Second is on the HPC high performance computing again. And you would have something like a per VM EVC. I'll double click on the per VM EVC. So everyone would have heard of EVC, the enhanced vMotion compatibility, which used to be on a cluster level. Right now we have brought this down to a VM level. And why did we bring this down to a VM level? I'll come to that on a later part of it. And the last portion of it is we have increased the number of disks from 60 to 256. Now, so that's about the management changes or at the hypervisor level as well. So we made a lot of changes, at least at the hypervisor. Quick reboot was one of the features that customer has really liked. VCSA, enhanced link mode, was another feature which we have got a positive feedback. Now I'm going to double click on the security portion of it, and what additional, or I would say the best value out of the security portion of it. So the first thing is the TPM. So every laptop, desktop, or maybe server. Let's talk about server. Every server would come up with a TPM. So those are serial devices, and those are usually used or to save the credentials, hash, or keys. So we had support for TPM 1.2 always, but it was always used by the hardware vendor. We don't expose or we don't use that extensively. With TPM 2.0, now we utilize that in a much better way. So with 6.5, I believe you might have known something like a secure boot. When you enable secure boot, basically you know that the hypervisor is in an appropriate condition. You don't have any uninitialized code running. So with that, right now, the advantage with 6.7 we have is around the upgrade, with 6.7 is basically you can do a 2.0 version of it and provide a health attestation also. Apart from that, we have VBS, which was Microsoft launched in 2015, VBS, and which is nothing more than a nested virtualization. With VBS, they used to give a Hyper-V. You have Windows 10 2016, and prior to restarting it, you have a nested layer of Hyper-V in between. So we have been doing that as well, and we have enabled support for that. We have vTPM 2.0. Now, we talked about TPM 2.0 for the security of the hypervisor. We have vTPM even for the guest OS. And why vTPM again? Basically, to make sure that even your guest OS are compliant or fully compliant of it. Then we have made some enhancements to the VM encryption, some enhancements to the new alarms as well. So this is a screenshot of the VM encryption. If you look at it, we are going into VMDK level till VMDK level to provide you a more granularity into it. Apart from that, FIPS 140-2, we have been doing this for a while, our VM kernel and as well as our OpenSSL. VM kernel is basically for all your OpenSSL is for communication, and VM kernel, I forgot about the VM kernel part of it. So now you are coming back to the universal application platform. I think we are running out of time. Yeah. So universal platform application, the major things that I want to show you about is the NVIDIA vGPU support. Now we do support NVIDIA vGPU with vSphere. This was previously supported only with Horizon, and now we do support with vSphere, as well as we can do the suspend and resume of it. Apart from that, we have the persistent memory, which is, if you are looking at the top layer, which is the CPU, cache, and DRAM, which is costly. And again, you don't have that much latency in it. If you come back on the down, flash as well as magnetic, which have a slightly more latency than compared to the PMEM. So right now we consume PMEM in two different options. One, we can do a PMEM data store level, or we can do via the NVM as well. RDMA is one of the enhanced feature of it, which is again the direct memory access. Now with RDMA, some of the applications have been, or the customers have been requested to make that compatible. So one machine is reading directly the memory of the second machine. So once you do that, the latency has to be really, really low. So there has been a support for RDMA protocols. Rocky was one of it. Then we support Rocky V2, which was routable Rocky. And then there is IWAP. We don't support IWAP for now, but apart from that, yes, instant clone of it. Now, instant clone was again a feature available only to Horizon portion of it. You can spin up machines instantly. So once you have a powered on machine, that can be cloned pretty fast. It would be way faster compared to the regular clones. Then coming back to your hybrid cloud of it, or the hybrid link mode, one of the features that I would want to talk about is the cross vCenter mixed version provisioning. You can do a vMotion across so this is your on-prem on the left-hand side. On the right-hand side, you have your AWS cloud, VMware Cloud on AWS. Then you can do an across provisioning and across cloud for sure. And that too, everything is encrypted. So apart from that, U1 was launched recently, or U1 was announced recently. 5 of the key features is it has a fully featured HTML5 based vSphere client. It has vMotion for NVIDIA grade machines. It has a vCenter server converge tool, which is basically if you have multiple PSE and multiple sites, you can still do a convergence of all of them. And then there are enhancements for vSAN and HCI, which is again a detailed topic altogether. Then we have an enhancement to the content library as well. I think, thank you. Thank you for joining. Good afternoon. My name is Gaurav, and I'm a pre-sales engineer at VMware. I work out of the Mumbai office in India. Today we will talk about the vSAN 6.7 version, what's new, and I have segregated it into various sections, so hopefully you should like it. Now, prior to starting, anyone here already using vSAN? Can you give me a heads up? Oh, that's quite a few. Okay, great, good to know. Anyone already using 6.7? Okay, so this should help you with that. So let me start up with the again the challenge or the problem. Always a legacy architecture. So this goes back when I joined VMware 6 years back, and I was part of GSS and troubleshooting issues. There always a back and forth, at least with the storage team, and ESX Top used to be my friend saying, you know, there are high VDGA values, or the storage is performing very poorly, and it used to literally take me days to fix that. Now, this is the primary reason of going into a modern software-defined architecture, which is basically everything is converged into a single box. Now, this is where vSAN, a high-level picture of vSAN. Primarily, it is on an x86 architecture. Everything is integrated into the hypervisor. There are 2 models. One is an all-flash, other is a hybrid model, and it is easily scalable. So when I say easily scalable, you can do a scale-up by adding disks. You can do a scale-out by adding various nodes to it. And the last thing, which is pretty important, is about the managed through VM storage policies, which is actually the SPVM. So in a traditional architecture, you might not be able to control it individually at a VM level or at a specific disk level. Now, this is a brief map of our innovations of vSAN. Where did we start in March 2015, and where do we stand at the latest release of April 2018? So we started with all flash, and to me, the major advance was in the deduplication compression, which was launched with vSAN 6.2. Now, vSAN 6.0 was actually against vSphere 6.0. Then we had the 6.0 U1, which was vSAN 6.1. Right now, vSAN 6.7 is compatible to vSphere 6.7. And we will talk about various features to it. Now, the first feature, which I believe you might be looking at all the product UIs, this has been into the Clarity UI or the HTML5 user interface. Now we had a lot of objections already for the Flash, and this is the major reason of moving towards an HTML5 interface. Now the advantage of an HTML5 interface, it is almost compatible with every browser. Now this has been backported. Almost everything has been written from scratch. Right now we are, I would say, a feature parity of 95%. If I have to talk about from day 0, day 1, and day 2, if you want to do something like a config assist is not something that is available with 6.7 HTML UI, and that's the only reason you wanted to use the older version of the client, which and starting with day 2, you will have all the enhanced new features in it. Now, one of the important or the enhancements, even with vSphere 6.7, is an integrated VROps. So when I say integrated VROps, basically you don't have to move back and forth between your VROps and vCenter to look at two different UI. This dashboard can provide you from within vSphere 6.7, you can look at the basic health check. Now, if you want to create certainly new dashboards out of it, then is when you look at the complete or the entire VROps. And apart from this, a basic version or like a basic view of around 6 dashboards is available with vSAN with no additional cost for VROps. Now, this is the another great news of the WSFC or the Windows Server failover clustering. We already supported the SQL Server availability groups. We support the Exchange or the DAGs. Now, with this release, we have also started support for WSFC. And if you're looking at it, it is via iSCSI. And with iSCSI, there are on the left-hand side, if you are looking at it, it's the physical as well as on the right-hand side in the virtual as well. So this is one of the enhancements that we have for specifically for WSFC. Now, adaptive resync, or I would call it as resync fairness. So with resync fairness, which means basically you need to move the component from one host to the other host. We had a slight enhancement in 6.661 as well, where the resync traffic would be, reaching to a specific latency number, and then after reaching that specific latency number, it would be changing its value to a output or a throughput level. Now, with this architecture or the modern workload, what we have is a guaranteed reservation of about 20% of bandwidth for resync. When there is no bandwidth congestion, when we have 100% available, you can absolutely use it for the VMIO as well. Now, apart from this, now the next part is the destaging process. So when I say the destaging process, the first task when we hit vSAN, and if you are going to a write buffer of it, you need to write it in the cache buffer. So when you write it to the cache, it has to be destaged back to the capacity tier to make sure everything is written back. So that process of writing it back has been enhanced a lot. I have a home lab of around 3 nested ESXi on a Lenovo box. The performance has been really better compared to the earlier version of 6.6. And I don't have, or we don't publish an official number like this is the value, but I'm pretty certain it would be a greater performance post 6.7. Now, this is another consolidation of replica components. So if you are looking on the left-hand side, if it is doing a consolidation at the component level itself. Now, we have an object, and that is split into various components. And while we are trying to place the host into maintenance mode of the host 1 is getting on the left-hand side, getting placed into a maintenance mode, we are not moving that complete entire C1 component back to the host. We are actually consolidating. We are just consolidating the replica out of it. That means less transfer or less data transfer, and then means you can do a faster maintenance window as well. Now, this is with the space efficiency, and I actually had a lot of customers speak about it. Now, if you're looking at the blue window or the odd one out, it is the VM swap, which is actually equivalent to your memory. So prior to 6.6, prior to 6.7, so this VM swap was always a thick or a thick component of it. So when I say a thick component of it, you would obviously have to maintain, if it is 8 GB, then that would be a thick component, and it is not a thin component. With the 6.7 version of it, we are trying to make it more space efficient. And if you are looking at a scale version of it, maybe around 512 GB of memory host, and you're running around 600 or 60% of virtual machines, you can still save around, I would say, roughly around 2 terabyte only with this change. Right now, this is on the fast failovers. So with the fast failovers, I don't have typically any customer, or I don't have a customer at all who is running this particular architecture, but every now and then when I speak to a storage admin of a customer, he would typically want to go with a Fabric A and the Fabric B architecture, where your switches are not connected. Your switches are not connected. So what we can do in this architecture as well, or the enhancement with this architecture is, you can there would be a fast convergence once your one of the VMK NICs is down. Now, if you are looking on the vSAN traffic separation for, and this is specifically for stretch clusters, we have quite a few enhancements on the stretch clusters as well. So if you are looking at the DCI link or the ISL link, which is the vSAN data traffic, so this is the dedicated link. So when you plan for your stretch cluster, obviously you would be planning in a phase that your data traffic has to be segregated on a fast link, and the witness or the metadata would transfer over the witness link. So this is another enhancement that we have added to it. Now, again, coming back to the stretch cluster portion of it, if you're looking at the stretch cluster, left hand side is my preferred site, and on the right hand side we have the secondary site. Preferred and secondary are connected via a fast link, and the witness, which would be typically a metadata only. Now, in case we have we have a connectivity issue of the ISL, the preferred site has gone or non-responsive. It does not have any connection to the witness node as well as to the secondary node. In this case, the VM has failed over back to the secondary node, and for some reason, if your witness has started communicating back to the preferred site, we still need to make sure the fitness of it, right? You cannot move all the machines or make that as a preferred site again. So in a stretch cluster, until and unless the ISL link is back up and running, the VMs would not move to the preferred site. Now, apart from this, again, this is with the stretch cluster itself, the resync or intersite resync as well. Prior to 6.7, we would move all the replica components from site A to site B. So when we move that, obviously you have more traffic compared to what with the 6.7. Now with 6.7, the movement is of a single component at a time, and secondly, we do have visibility now at the component level as well. We try to do the first component. Let's say we have done the first component, we got a proxy owner, and then it is beyond the proxy owner, which is going to replicate it among the local site itself. So this is again an enhanced version in the stretch cluster itself. Now coming to the next gen apps, which is basically there are various applications which have inbuilt high availability. Now when they have an inbuilt high availability means they don't have to move around. So doing an FTT or any sort of data is really not required. So when we have that architecture, we can do an FTT 0. If you are looking at the third column, we can do an FTT 0. That means we are not maintaining more than one copy. It's a single copy, and then you can absolutely have multiple nodes. Since you have application level high availability, this can be useful. Now, this is part of the vSAN Ready Care, where we have invested in people, services, and technology to make the product better. So since we have 15,000 plus customers on vSAN now, we have increased even the GSS support to a certain extent, and similarly we are investing on the vSAN Insight portion as well. Now, there are health check advanced or enhancements. I would like to speak about at least the HCL updates. That would be only fetching your update differences only. It won't be a complete or entire update. Apart from this, there are other configuration and compatibility improvements as well. This is again going back to day one. And Now, last portion, if you look at it, firmware check are now independent from driver check, because we have that HCL. If you go to the HCL, it gives you a driver version, then it gives you a different firmware version. So we kind of fixed that in the 6.7. And there are other connectivity related improvements as well, vMotion and vSAN network connectivity improvements. Now, this is with the enhancement, again back to the support angle of it, or the support of vSAN itself. Now you can, or we can download, or sorry, we can upload the data, we can upload the anonymized data back to a vSAN support insight bundle. We don't collect any host names, we do not collect any IP addresses. We would collect certain information from your environment, basically for real-time identification only, and then when you create a case, or when you log a case with VMware, there would be no back and forth going, oh, you have to upload the log bundle. That means you really would have a faster response, because GSS might have access to a lot of details when you log the case, and there is additional proactive support capabilities that is with GSS now. Now, this is one of the component I think that has been there for a while with starting with the 6.0 till 6.6. We have to run this as a scratch partition, or the boot device. So when typically with vSphere, it is about 2.5 GB, and if you are looking on the right hand side, the extended version of it, you would have to basically, there is a KB article, you need to go back on an ESXi host, run a command, and make that diagnostic partition expand. So with 6.7, that is possible even with the at the time of upgrade, or at the time of a greenfield deployment. You have a scratch partition of 4 GB, so all your logs data or any other logging still persist back to your vSphere logging. Now, support for 4K devices in vSphere and vSAN. Since we are seeing a lot of 4K devices with the larger block sectors, so basically this was something that was pending on the vSphere 6.7. Immediately after 6.7, vSphere started supporting it with the software emulation. Now we have support for the same in the vSAN 6.7 as well. Now, this is again coming to a security angle of it. We have all FIPS 140-2 validation. Now, it's a validation, not a certification. So the primary difference is, if you are talking about a certification, that has to be via a hardware and a software vendor. So that means you might not be able to change certain things if you are buying a FIPS certified solution, X hardware, then a specific version of vSAN, specific version of switches. So with the vSAN FIPS 140-2 validation, what we are doing is we have two modules which are validated. So one of the module is the VM kernel, which is basically possible for or responsible for your vSAN encryption or for your VM encryption. Then we have the OpenSSL, which is basically for the TLS communication, and we are also, or when we get into the encryption model of it, we actually rely on a third-party vendor like HighTrust or any of the third-party vendor who can provide us the encryption capabilities. Now, some of the takeaways right now, it is put into 3 columns as we discussed. So one of them was absolutely via the HTML5 UI. So even I started working on vSphere for from 4.0 and ESXi 4.1. I was so used to the C# client, and I still like that C# client, and then we suddenly moved to the Flash-based client, and I personally did not have great experience with that. Now, after moving to the HTML5 and using the product from a long time and sticking to the C# client, after using HTML5, this is finally something I can really say we have made a significant enhancement to it. Now, when I say enhancement, when you log in, the things, if you have to go to the CPU of it, or you have to go to VM, the things are really possible in terms of fewer clicks as well. Now, We talked about the vRealize operations that is embedded within vCenter, and we talked about WSFC. Just a note on the WSFC again, just to be sure. This is via iSCSI. Now, vSAN, and now this is possible via iSCSI. This is one of the corner cases you might want to use it. This is not something, you know, I have designed a recent environment for one of my customer who was running around 500 odd VDI, and I designed that solution on WSFC so that the file server was made available, and because he did not had additional investment to make on the NAS component or NFS, he's totally relying on the HCI portion of it. So that was one of the use case that I used it. Apart from that, I would also highlight again the improved space efficiency after making it thin provision, and the support experience, which is really at par now. So with that, if we have to find out more about vSAN, 3 ways to find out. You can take a vSAN assessment, which is the HCI bench, which is really good from a POC angle of it. If you want to see your performance or how many IOPS, you want to fulfill all those requirements, you have your expectation set right, you can use this tool. Our HOL has been quite famous. These are again nested labs. So if you want to give HOL a shot, I usually create a lot of demos out of HOL. Now, the last is the storage hub resources. I highly recommend using the storage hub resources. Every guide, or like if it's a 2-node, it's a stretch cluster, it is any specific information related to vSAN, SRM, or anything related to storage is consolidated back into this particular resource or the storage hub. And with that, I would end the session for now, and thank you for coming. I can take offline questions.
Hi, good afternoon everyone. My name is Girish Manmadkar. I am part of VMware Cloud Foundation BU out of Palo Alto, responsible for various customer use cases, responsible for understanding customer feedback and bringing that into the business unit to improve VMware Cloud Foundation and features. You must have heard in the morning about various announcements based on Cloud Foundation, which gives you an overall basic way to start your journey towards the cloud, whether it's a private cloud or public cloud. Today I'm going to talk a little bit more about Cloud Foundation, as well as I'm going to speak about how you get to a hybrid cloud and how do you establish really a hybrid cloud environment for you or for your customers. So with that said, I think wanted to touch upon what we have, right, from the portfolio perspective, from the VMware perspective. When you talk about a private cloud, we have various infrastructure products as outlined on this slide. Compute, storage, and networking gives me a basic benefit of building my cloud infrastructure, whether it be a private cloud or whether it's going to be on a public cloud service offered by various public cloud service providers. And on top of that, I can run any virtual machines, any container-based applications as usual. And also at the same time, if I have a need, I can definitely provide various level of cloud management control into my overall infrastructure, whether it be a vRealize set of products or it's going to be delivered by VMware Cloud vRealize automation, as well as security is provided by NSX. So all these are on top of my basic infrastructure delivered by Cloud Foundation to a public or private cloud. So how do we achieve, the best-in-class private cloud from VMware, right? So if you look at it, like what we do from Cloud Foundation perspective, we have various products that, as you heard about it, right? We have vSphere, we have NSX, we have vSAN, we have vRealize suite of products. So we bring them together. We build the bill of material of my software stack, what we call as a software-defined data center. As a software-defined data center, we bring them together. We understand what the interoperability of each and every product we perform the testing of all our products just to make sure that we validate, we understand that each and every product, their dependencies, their way to work with each other and provide some level of integrations. So once we are sure about that particular bill of material, we go up in the stack and we kind of pull together various best practices from individual products to make sure that not only the reference architecture from individual products are considered, but also we are building together a standard architecture design from software-defined data center perspective, just to make sure that it gives you a guidance. And I think we have about 340 design decisions across the stack. So we want to make sure that the design which is built to deliver you a private cloud experience, software-defined data center, based on a documented guidance is VMware validated design. So they are the best practices. There's a best design document that they are delivered to you. But we also use that VVD guidance when we want to automate and bring that to you in an automation fashion, which is delivered as an integrated platform for your on-prem cloud or your public cloud, which also has a lifecycle automation attached to it. Once you deploy it in an automated fashion, it also has to have lifecycle management. Consider if you have to apply a patch. Consider if you have to upgrade a single piece of software within the stack. It takes time for you to really go through testing, understand how and what are dependencies between the stack, whether they are compatible to each other or not. It takes time. So we want to make sure that we take that onto us, we validate, we test, and then we ship you that bundle just to make sure that when you click on a button, just like updating any of your app on your smartphone, you click on a button and it just does its job. Similar experience that we want to do, ensure that you as a customer can experience when you want to apply the patch or upgrade your environment. Another option that it gives you that you can apply this particular patch or upgrade a single cluster by cluster. You don't have to really apply the patch or upgrade entire environment just because it is a part of single vCenter server, right? So what we do from the VVD perspective is a complete data center level design. It covers not only hypervisor, but also it covers storage as well as networking pieces of it at a software level. That gives me a software-defined data center architecture, which is standard, which is consistent across all my environment, which is tested, because we want to make sure that it is robust. It has a scalability attached to it. So when we perform various levels of testing, when we are delivering this guidance, we kind of do a load testing. We create number of virtual machines per hour just to make sure that how much that particular, make sure that it is robust, applicable to another way of providing a built-in intrinsic security. You can definitely use aspects of and from NSX implementation perspective and attach those properties to your virtual machine or virtual machines, which can move around with those properties, with those intrinsic security files to it. That gives me an ability. It's new in VMware Cloud Foundation 3.0. Definitely flexibility. We used to have to approach regarding the rack switches. The customer can bring physical network and just focusing on automation at the software level, which opens the door for customer that don't want to buy of building a cloud center servers. And the UI, we have rebranded the UI aligning with VMware other products, based clarity based, which allows them feel and look across all the products, right? This is about ecosystem of compatible solutions. So you have private cloud based on various architecture. So it's a verification because same. With that said, if you have any questions, feel free to shoot me an email or contact me on a YouTube. Thank you very much.
Welcome everyone. Thank you to vBrownBag for having us here for this particular Tech Talk. We're really excited about what we're going to be doing here today. My name's John Arashid. I'm VCDX #1. I work at VirtuStream, but I've worked at EMC's Office of the CTO and VMware for many years. This is my co-speaker.
And I'm Chris Gully. I work for the VMware Office CTO, group called Dell Technology Solutions, and we really are focused on innovation across the entire portfolio. Yep. So John and I took an opportunity to kind of talk about the things we're doing, and hopefully you guys have lots of good questions, and we'll go from there.
Yep. So first off, I have to give a disclaimer. We're not going to be presenting a roadmap. We're going to be talking about some things that are based on what is available today, but also what is to come in our vision. Where do we see things going for Internet of Things? It includes the devices, it includes the gateways, it includes AI and things like that. We'll get into those details. But again, Any questions on specific roadmap details or schedules, we're not going to cover that because that's not what we're here for. We want to cover some specific things that we're working on and where we think you should be looking going forward. This is our agenda. We're going to talk about some use cases and one particular example tied to one of the POCs that we're doing with one of the companies that we've been partnered with, Toshiba, and they're doing AI as a service. We're doing platform for AI as a service as one of our research topic areas, and Chris and I are working together on expanding that so it's not just the AI, it's IoT. We're looking at the IoT challenges. We're looking at how AI fits into the picture, some of the design and operational patterns, and then how do we see Dell Technologies now working as a family as well as other partners working together in that ecosystem to deliver success. This is a part one. The deep dive is a part two, which will either be at VMworld Europe, but we've also been talking about doing a full vBrownBag with probably it's more than an hour on kind of the details. So we're going to give you a quick overview of this with some of the details and some of the vision for the future. Chris?
So, you know, IoT landscape is pretty diverse and we know it's evolving, and this slide really is just to show the dynamic elements that come into play as you go. They all have different types of connectivity. There's lots of connection points for information that come out of that, and we're looking at how do we extend compute further out to the edge. The customers have more capabilities closer to the data. They can do more real-time analysis as the ecosystem starts to evolve. IoT tends to be growing. I forgot the numbers, but they're large as we expand the capabilities. And obviously security is being critical to that. The analysis of data is critical, analytics, the decoupling of points and things like that are growing and changing. GPUs are coming into play, acceleration, all that stuff is happening. We're looking at solutions that enable the customer to evolve in that ecosystem without having to learn it from scratch. And that's what we'll go into more.
Cool. So I'm not going to go into the details here, but I wanted to show you some of the things that we look at from IoT, edge computing, the devices that are out there. We're looking at different verticals. There's a focus that my group has had on a POC with Toshiba that's specifically around transportation. In the city of Tokyo, they're getting ready for the Olympics in 2020. They're working with the taxi companies. They don't have Uber and Lyft like here in the US, or it's not the same type of approach. They're focused on the taxis in support of a lot of different aspects. They have data coming from IoT devices, and they're doing AI, deep learning, and so on to make recommendations on route pathing and making sure that they meet the SLAs that are in there. Our focus specifically, though, is talking about, or more than specifically on AI, it's the bigger picture of IoT and how AI fits into that. So the use case for transportation is based on the POC that we've done. We have what we call a vehicular cloud. This is one of the industry terms that they have in the transportation industry, where you have different vehicles, different types of transportation systems. And the way that we look at things for our autonomous cars is somewhat similar to what we're trying to do here. What we're trying to do is look at the requests that are coming in for pickup and drop-off times and locations. In Japan, they will have up to 8 passengers. And so they have to make sure that if a new passenger is going to be picked up, they don't break any SLAs for any one of those maximum of 8 passengers. Now, what we see going forward is edge gateways to collect data from these devices, do some initial analytics so that when you send, I'll call it scrubbed or sanitized data to a cloud somewhere for doing further analytics, that you can still follow geographic regional boundaries so that you can follow regulatory compliance. So do the more computing at the edge, and this is something we'll talk about further with VMware Pulse IoT and several other technologies as well. Then we have a data and analytics cloud. This is where we believe there's a cloud of clouds, and you're seeing a bunch of bubbles, and this truly is a cloud of cloud. There may be one big cloud that is a system of these smaller clouds that have specialized purposes. One of these areas is for data storage. So we can have data storage related to the devices, status, and updates related to the sensors and the actuators. But we also have additional data that could be coming from the government, weather services. If you know about events, if you know that there's going to be an Olympics in your city, that's a major event. And if you look at the past history, if you don't manage transportation, it causes a lot of challenges, bottlenecks, traffic jams, and people missing, getting to go to some of those events. But we're factoring in weather, traffic, and thinking about it from a smart city perspective. Transportation is one aspect, but there's many more aspects that we can include as well. There's the analytics and AI. This is things like deep learning or inference engines that are created. So once you've done the deep learning, you can make recommendations based on new data. And finally, a user interface where if I have a device, I can request a taxi service, and based on the analytics, the inference engine, it can make a recommendation on which is the best fit for a taxi. Just because a taxi is here and somebody in the front row here might be, the customer, it doesn't mean that I can actually pick you up and still meet my SLAs, and that's part of the intelligence in there.
And real quick, also, culturally, they have aging population that's outside, and so providing these services allows them to get the service needed to those folks. And to John's point, it's bringing all the data together. It's not having them siloed, and it's being able to use all of that richness to then drive solutions that help solve problems for them moving forward. And again, meet SLAs that are very critical.
And this is just one use case. When we get into the deep dive in one of the following sessions, not at this conference, but later, we want to go into more examples around security, healthcare, and other areas to give you more examples. This is just one example what relates to the proof of concept that I'm working on, but there are many other ones that we have other team members working on as well. So we're going to split this up. I'm going to cover the first half, but we're not going to spend too much time. The deep dive will go into a lot more depth and more examples. But here are the top 8 that we believe are the ones from what we've learned and what we've seen from our customers and from our experience. Looking at integration in the cloud. How do we look at this? We look at it all the way from your core data center, maybe at your on-premise, and maybe our cloud or some other cloud, all the way to those edge devices. How do we make sure that we have that full integration, we have consistency, we have security? We need the IoT management from the edge to the cloud. We need to think about regulatory compliance, geographic boundaries, privacy protection, all these different things that come into play that force certain decisions to be made around the data and where the workloads are and where you get the access. And one important aspect of this is with regulatory compliance, we see moving the workload closer to the data is the better fit for regulatory compliance than trying to move the data elsewhere. So if you look at GDPR or you look at individual country or regulatory compliances, you may have a boundary where you can't move the data out of there. No matter what you want to do, you can't move it. And in some cases, even if it's scrubbed, there may be restrictions on doing that. So we're trying to think more about that edge IoT.
Or even the costs too can play a role. Moving the data can be very costly.
So another area is on security and secure ledger. There's many transactions that are happening between the edge devices, the cloud, and all the intermediate areas. We do believe that with some of the new technologies out there, there's a particular VMware technology around blockchain for secure ledger that does, in some of the testing that they've already presented on, 60,000 transactions for secure ledger in the space of a second, versus maybe a dozen or so per second when you use traditional blockchain. And that, the VMware technology is with debugging turned on. So the expectation is going to be significantly higher. There will be sessions here at the conference I recommend going to see, in particular if you know Mike DiPetrillo, or if you don't know him, I definitely recommend going and seeing him if you are looking at that area.
And IoT skill sets being another one. As this ecosystem evolves, it's like software soup. You get all these things done, you have buzzwords, containers, AI, all these things are happening, but the skill set of the sysadmin, the OT, the IT person are being up-leveled, right? So they're having to learn new skill sets. It's a good thing, it's a challenge, I think. It's a paradigm shift to some extent. But I've seen that we're trying to create solutions that provide software that help bridge the gap between those, right? It's not just throwing it at them and saying, go figure it out. It's, hey, we've been thoughtful about it, and we're trying to give you the tools and the things necessary to go be successful. The bandwidth and latency obviously is critical, and I just mentioned, moving the data is important. Move the right data, don't move all the data. Moving all the data becomes costly. How do you normalize the information? How do you make sense out of it? And again, so as you move further out to the edge, latency becomes a real thing to deal with, right? And so you have to figure out, how do I optimize that for what I'm doing and know the sort of the bounds of that latency and bandwidth and leverage them to my advantage. And that's a challenge, I think, as 5G comes online, we'll have some new opportunities to realize more bandwidth, and the technologies will evolve with some of that technology coming. Data modeling, storage, and flow. As we put those all in one piece, but they're very critical. The data structure, it's easy to actually generate the information, But it's once you've got the data, what do you do with it? How do you get it somewhere? How do you normalize the data so you could use it in multiple potential clouds or on-premises data centers? So you have to make those decisions early and follow those as a sort of a foundational component for your IoT mantra, if you will, as you move forward. And then requirements of cloud. So that's sort of the overarching thing John and I are talking about, is that you're going to always have multiple clouds out there, whether it be your private cloud or your public cloud. The key is how do you leverage all of them to work for you and not pin yourself into one technology that when you need to pivot, you're not unable to, right? So it's standardizing across things, leveraging the ability to use VirtuStream for mission critical applications, but then using other potential cloud providers for either their regional expansiveness or the collaboration because you have more people working in that ecosystem, or your data center itself because you've got the governance and security required to do that, but they all have to work together. They can't work independently.
And think of it this way, one master cloud for the analytics related to all of this, all these different components, and then the individual, maybe we call them subcomponents or the elements of this bigger cloud that focus on things like the storage cloud or an enterprise cloud on CPU or a GPU cloud for the accelerated requirements of AI workloads. Now, IoT, AI, we look at the data flow for Internet of Things. We start with looking at some of the training data. We get this information from devices. We might have reference information, and that's used to go to the next step where we do deep learning. We create what's called an inference engine, and that inference engine is where we actually have the ability to make a prediction. New data comes in, and we can say, based on past experience and our algorithms, here is a recommendation for the driver and a number of other elements in that system for the taxi service, if I go back to the POC. We have that model and classifier that does the actual inference. Typically, the deep learning is done at night. The inference is during the daytime. But as things advance with the accelerator technologies out there, we're going to see more and more analytics pushed to the edge and potentially even on devices. I don't know when they'll have it on the watches, but there's already been things that have been presented by NVIDIA and other companies about pushing analytics to your laptops, to your PDAs, your iPads, or your Android devices. So, and then there's the prediction when you actually have to make a decision. How does that happen? New information, a new request comes in, find the best way to respond to that and meet all the requirements around that. And if you run into a failure at any point, take that failure to additionally learn more, retrain, refine your engine, get more and more accurate. One of the questions I get is, well, should we use single precision, half precision, double precision? Double precision with accelerators doesn't necessarily mean you'll run faster. You have to look at the use case. I can't go into the details now, but that's what we're planning on doing for the follow-on to this session. And then as we get new data and we try to do these new predictions, that comes in and it continues to be a refinement process.
Yeah, and I think the second part of this, or see the build out, is we're showing that the data is coming from different places now. The devices actually are getting smarter. You may have just the actuators and things like that. They're pretty embedded. They do a function, but the gateways themselves are able to do more now. They're more intelligent. They have more compute. You can run AI there. You can run machine learning algorithms to make decisions quickly at that level, as opposed to having to ship the data off to a cloud or a data center to make decisions and then losing that real-time ability to make business decisions. It could be from turning off a piece of equipment because it's starting to vibrate too much and it could damage it and it's very expensive, all the way down to it's a pipeline of some sort and you need to actuate something to shut things off because the pressure's getting too high. The key is it can happen there. It doesn't have to happen. And you can train those models with what we're calling a distributed core. That's an edge compute platform that's purposeful. It's not just hardware and then someone just put some software on it. We've thought about how we're approaching this architecture with the distributed core. It can land closer to the edge. It allows you to then run additional analytics on top of that. It could be GPU, FPGAs, to do rescoring and stuff like that you would traditionally do in a data center or a public cloud. You want to
go to the next one?
And so,
quick check, we got about 8 minutes.
Okay, so you said distributed core, I used that word, I'll go a little bit quick, but the idea is, I said, it's a purposeful platform. We're taking platforms and we're giving them purpose to run automated provisioning. They have accelerators, self-service, multi-tenant. Security, so secure ledger, you hear that called blockchain sometimes, same concepts, right? We're managing the data, who has access to it, how they get access to it and what they're doing. Monitoring, software defined, we're using vSAN, we're using NSX. It's got Pulse IoT device manager on there, so we're connecting this downstream so your gateways are now managed through the systems management style. So the hardware that's being managed, and it gives sort of the IT, OT guys vision into that, what's happening. And then lastly, lifecycle management. The whole stack can be upgraded and maintained in a validated way, right? It's not something that's like, hey, go grab some random firmware and let it fly, see how it goes. No, we're validating these things, and they're sort of blessed, if you will, on how you would maintain and update that. And by the way, a lot of this is built off of VCF. So I don't know if you guys saw the keynote tonight or today, but it was, it's bringing together all these different solutions and making them sort of turnkey to the customer, so that they don't have to focus so much on how it operates, but more, and it's using the things that they're already comfortable with if they're VMware customers, but they can go focus on their workload and they're driving their business. And oh, by the way, they can scale this very easily because we're going to make it easy to bring to the market for the sales folks and for the partners and everybody else.
Yep. So I want to talk about one other aspect. Many cases, if you're in the IT industry or you're working with technology, in many cases, you'll have that IT-centric focus on things. And typically the IT groups are focused on the enterprise applications, but in AI and IoT, we start thinking about operations technology. This is, they call it OT. This is where you have the business people focus on the business and the IT people focus on IT. There is a relationship between the two, but the idea is let the people who focused on business intelligence to specialize on that, and let IT do what they're good at on the specialization of that, but still do a partnership. And when we look at this, we have OT looking at covering the details around what we would have at the edge data centers, where we have the Internet of Things, the sensors, the actuators, and here I'm showing a cloud that's tied to the OT group, where we show analytics and data lake. That is how some customers have been doing this. In fact, there's a lot who have done it that way, where OT and IT is the same person, which causes sometimes a conflict or a challenge in trying to focus on the business problem to solve and not have to worry about the underlying infrastructure. But as we go forward, my company, VirtualStream, and other companies are looking at how to actually help the customers focus more on the OT, and that's where we start moving this closer to the cloud provider or fully into the cloud provider area. There will still, I show this as an overlap because there's still going to be dev tests, sandbox evaluations that might be better done on premise or within the customer's cloud, but then for the mission critical workloads, we want to make sure we have those guarantees, the SLAs, we have the availability, and we have the security that can allow them to take it to production, which is similar to what we're doing with Toshiba. They focus on the IT, we focus, the OT, and we focus on the IT. Okay.
And so building off that, what John was going about, the hybrid IT model, the convergence of that is Pulse IoT. Raise the hands. Anyone know what Pulse is? Anyone heard about Pulse? Not a whole lot of hands, so that's good and bad. But what Pulse is really engineered to do is manage your IoT gateways. The cool thing about it is that we're bringing to bear the manageability, the compliance, the monitoring, zero-touch onboarding for these devices. Security obviously is a huge component of that. The focal point, though, allows us to take the software solution, which is Pulse, couple that with, if you'll click the next.
Oh, yep, sorry.
So it brings together the two different optics from IT OT to say, hey, look, we know there's sort of cultural paradigms there that they don't really necessarily interact that well. Usually it's through exception. OT's like, hey, I want to do this. IT's like, yeah, you can't do that. Well, then get an exception, you go do it. Through natural sort of progression of merging the hardware and the software, they just do it organically. They don't necessarily have to be in agreement, but they're able to get a voice, and they can drive their standards and maintain that compliance through the shared stack and the shared software. So if you click one more, so that brings in the idea of distributed core being the platform that they both share, right? IT can own it, but the OT side of the house can then pull in the gateways, if you click one more,
sorry.
The gateways that are operating off of that distributed core, and they're using Pulse to maintain and monitor, and then that brings in, again, the vision of the convergence of them working together, not necessarily having to interact as much as they would typically, but they can use the same applications, and that's an aggregation model for that. And then IoT Edge Operations Connectivity. This is just a scenario of showing sort of the awareness that IT and OT have, right? They kind of blend at a very narrow spectrum. but we're looking at the different scenarios today of how they operate and the different use cases that we need to solve for. And so the first one is obviously Pulse today uses gateways, it goes directly to a data center. That's their model today. As they grow, they're going to start to support things like a distributed core. So you can run distributed core and connect it out to the public cloud and have a hybrid model for how you move your data and manage your IoT landscape. You still have the standalone model though, where you have manufacturers who still want to run a distributed core and have gateways, but they're not going to connect outside of that, and we understand that. But still, it's the opportunity to support that and grow that. And then lastly, I think the sort of the sort of North Star is that you have this hybrid model where you're giving them something like a micro data center that could be a smart retail space outside of a building, or it could be outside of a park, and you land a distributed core inside of that, but you still have your data centers and you still have the cloud. And you're choosing to move the data how you like to between those different elements, and then you're using Pulse, if you'll click one more, and it can live in multiple places. We're introducing an idea that as they move towards a SaaS model, that you have a master of masters. And so you may have multiple Pulse instances running downstream, and they're managing very large ecosystems, but you can aggregate that back to one and monitor it all and govern it from one space. So that makes that easier as you grow to allow that you can stay in compliance and allow cyber guys to have their purview into the space.
And we see this as a true multi-cloud. My company focuses on mission critical workloads. There are other companies that do that, but there are also other companies who focus on non-mission critical workloads. You'll have to look at your ecosystem of your environment within AI and IoT to determine what makes the most sense for each of those different types of provider benefits. Yep. So I'm doing a quick build down on here, just to kind of give you the overview of the different sections. We talked about the cloud of clouds to make this big analytics cloud. This is actually showcasing where the different stages for AI and IoT would fit in. The edge cloud would have things like the devices, the edge gateways and analytics, although some of the edge gateways may overlap, like with distributed core, closer to the actual cloud or the core data center. We have the data collection and storage of training data. The initial collection may be at the edge, but at some point there is a central repository, a storage cloud. We have the deep learning in that core, we have the classifier engine, we have the prediction, the inference, and then we get the additional unknown IoT data coming in to further learn, make predictions, and also refine the accuracy of the model. And so this kind of shows you where the cloud fits. Pulse IoT I'm showing here on the edge, but with the way that things are going right now, it goes all the way back to the core. If you want to add a point to that, we got about 4 minutes. So
yeah, I mean, I think that's a good example. I think the key is that they're all interconnected at some point. They're not living on their own. They all work as an organism, and you have to use them and manage them that way.
Yep. Now, this is what I would consider, there's all kinds of terms you could use, but I think this is the one that I think you'll find the most valuable. What is the vision for the future? Based on what we know from today's technology and where we see things going, based on customers and partners and the industry in general, this is what we see. Look at the hardware layer. There's traditional compute, storage, networking. We've now seen accelerators added for doing the AI, the special math that's required for doing those predictions for the classifiers and the prediction engines. We also have this concept of intelligent gateways and embedded gateways. The intelligent gateways will have the GPU so you can do edge analytics, but the embedded gateways might be at a building or in a particular other location. This upper layer shows you the system of secure ledger, desktop as a service, accelerators as a service, traditional clouds for storage and compute, but also containers as a service are very essential for this particular process because many of the customers we're talking to now are using Kubernetes with Docker containers. There are other ones that fit into there as well. We need to have governance across all of this. And the last thing on this one key area is thinking about the system that goes together to create this one big cloud made up of these smaller elements and how they all work together. Last area we'll go through very quickly. I'll do a quick build out.
Sure, so
it's
it's showing sort of that it's, again, thoughtful. These are solutions that we're engineering, we're layering software on top of them to make it easy for the customers to adopt. We're looking at a base configuration, a storage configuration, and an analytics configuration, and pulling in third-party products to help them be successful.
Yep. So the one thing we want to leave as the last takeaway is that with Dell Technologies, we're trying to work together in a very solid ecosystem, partner with other vendors like NVIDIA and others that are out there to actually give you a total solution end-to-end, including the financial and professional services that are needed as well. So I'm going to leave this with asking you if you can fill out the survey. We'd love to get that. The vBrownBag team really appreciates it because it helps them determine what are the next sessions that they may want to choose. And if you are interested in doing a vBrownBag talk, I highly encourage you to talk to the people behind the crowd who are making us happen. So what I'm going to leave this with is our contact info. Because we have other sessions coming in, we're going to step off, let other people come on and get ready. And if you have questions, we'll talk to you back there in the vBrownBag.
Thank you very much.
Behind the vBrownBag area. Thank you, guys. Thank you.
How you doing?
Awesome, welcome. Thank you, and thanks to the vBrownBag folks for letting me present today. My name is John Diaz. I'm a technical marketing manager in the cloud management business unit at VMware. And what I wanted to come talk to you about today, or share with you today, is the vRealize Orchestrator Management Pack for vRealize Operations. How many folks right here presently are running vRealize Operations in their environment today? Okay, good. What about Orchestrator? Okay, about half that number. So let me explain real quick. Orchestrator is a tool which does what the name implies. It orchestrates or creates or allows you to create workflows to do any number of things like create new VMs, configure hosts. We even have the capability to reach out to third-party systems, works with VRA. You can do things like send ServiceNow tickets, initiate ServiceNow tickets through their REST API. So it's got a lot of great extensibility. It's a good tool to be able to automate a lot of things that you would do manually in your environment. So having the ability to do things like take alerts that you receive from vRealize Operations and commit some action based on a workflow that does a predictable thing like restart a VM or delete snapshots or those types of things obviously has a lot of value. So we released this actually with the 6.7 release of vRealize Operations earlier this year to allow you to do that. So it adds orchestrator actions or orchestrator workflows to the action menus for VMs, for hosts, clusters, and so forth. We've actually added some more capability to this. I've been working very closely with the engineering team. In fact, hopefully they're watching from Bangalore right now. Gaurav Gupta is very interested in a lot of the feedback the customers had, some feedback that I had. So I've been working with them on this. And some of the new capabilities that we added are the ability to take any workflows that you create as a customer in your own environment, because that's the whole idea behind Orchestrator, is to allow you to build workflows around routine tasks that you do every day, and things that you might script through PowerShell or something like that, but add some governance and capability around that with Orchestrator. So if you have workflows that you use to remediate problems, and think about something like whenever I see an alert for a virtual machine with high CPU, I always want to check for the processes that are using the most CPU, and I want to get that list emailed to me, something like that. You can obviously automate that task, right, with things like Orchestrator, things like PowerShell. So if I have that action already built, that workflow already built in Orchestrator, why don't I just automatically have that happen when I get an alert for a VM that's had high CPU for a long period of time. So we can actually take those workflows and map those workflows to the vRealize Operations recommendations, and you can either commit those as part of an action or part of an alert where you get the recommendation, hey, check for processes that are using CPU. It'll add a little run now button. You click that and it'll go out and run that and email your report back or whatever that action is that you want it to do. And then we can automatically do it so that when the alert gets fired, the workflow just automatically runs in Orchestrator. Now I had a demo, and then unfortunately I learned at the last minute, we weren't really set up here today to do live demos, so I'll explain the demo that I was going to do, and then I talked to Ariel, and we'll set up a separate vBrownBag session where I can do that. It's actually better, so I can go into more detail about how that works. But the use case is this. I have my servers configured with NTP, all of my ESX hosts configured with NTP. I have particular NTP servers that I want them to use. I want the NTP service to automatically be set to automatically run when the host boots up. And I want to make sure that it's always running. So VROps can detect all three of those conditions. If I violate any of those conditions, misconfigured NTP servers, the service stops for some reason, or somebody changes the policy setting so that the service is set to manual, for example. And it can trigger an alert. The alert would then fire an orchestrator workflow that goes, oh, I'll go ahead and go fix that for you. NTP is broken on this host. I'll fix it for you and resolve that alert. Another thing that you could do is, instead of automatically fixing that, you could go in and let's say you have a number of hosts that you need to change configuration settings on. Let's say you want to point at a different NTP server. I can have a workflow to configure NTP on each of those hosts. So these are not native actions that are available in vRealize operations today, but these are actions that, if they're important to you, then you can create those yourself. And the nice thing about Orchestrator is there's a large body of work out there. In fact, the NTP workflow to configure NTP on a host, I just pulled down the script for that off of the vBrownBag site and made a couple, 2, 3 little changes. But there's a lot of community content out there, as well as we do provide in the management pack a number of workflows out of the box that will automatically be added to the action menu. So we give you kind of a starter kit, and then you can go on and build your own. So this is kind of what it looks like. A little bit of an eye chart here. I had to pull these kind of at the last minute from our enablement deck for the next version of VROps. It's going to be released in a few weeks. But you can see here what we have are the traditional actions that are included with vRealize operations. Things like delete idle VM, power VM off, on, those types of things. But then these orange icons that indicate that there's an orchestrator workflow that's now been exposed as an action, and these are the starter kit, the ones that are provided out of the box for you. So, for example, we're looking at a cluster object here. So we can do things like, for hosts within that cluster, I can say, put these hosts in maintenance mode, one or more hosts in maintenance mode. I can do host power operations. I can do things like decommission a host from VROps. And then I've got a workflow here at the cluster level that I created. It's actually not one I created, it's one that comes out of the box with Orchestrator. But there's a workflow in Orchestrator to find orphaned VMs. And what it does is it looks in its own index and says, I can't match these VMs up with anything that lives in vCenter, and it will email you a report based on that, as well as a list of files that it can't correlate with any other system or purpose. So you get a good report there that tells you, hey, this is where you may have storage waste and things like that. So now I can run this directly from vRealize operations and have that report emailed to me by virtue of just adding that custom workflow to vRealize operations. So I don't know how many of you are familiar with something like RV Tools. Before, RV Tools is kind of, that's a good thing that it does. It helps find orphan VMs, but it's a separate tool that you have to run. Now with this, you can bring that capability directly into vRealize operations. And you can see here also that some of the improvements we made over the last version, if you got to play with the 1.0 version, you'd realize that you had to kind of pre-fill, or you kind of had to know the name of the virtual machines, or Like if you wanted to impact all the virtual machines, like I wanted to migrate or evacuate a host, I needed to know what host the host name was that I was going to migrate to. And now we just we've added a lot of pull down lists where we go, oh, these are all the host targets that you can move to, so you can do a pick list. So little usability features like that don't seem like a lot, but they go a long way for for making this easier to consume. So again, I'd hope to have a demonstration for this, but we will do that in a future, probably in a couple of weeks. We may do an ad hoc or something like that, so you can get an idea of how it works. Not available today. The 1.0 version is, so you feel free to download that management pack and install it just to see what it does for you today. It won't allow you to bring in the custom workflow. It'll allow you to bring in custom workflows, but it won't allow you to tie them to the alerts and things that that I talked about. But you get an idea of what the capability is, so you can check that out. But when you see VROps 7.0 release, that's the same time that we'll release the new management pack with all these great capabilities in there. So any questions? That's about all I had for my session. No? Good. Well, thank you for your time, and thanks for vBrownBag for letting me speak today.
All right. Hello. My name is John Hildebrand. I am a technical marketing engineer at Cohesity, and what I'm going to present here about is we're going to talk about using the Cohesity platform for what we dub application mobility for test dev across multiple data centers or public cloud. So a little bit about Cohesity to begin with. Founded in 2013 by our CEO, Mohit. He's a co-founder of Nutanix at the same time, so if there's a lot of similarities between some of what Nutanix does and what Cohesity does, that's one of the reasons for it. Also, he was one of the leads on the Google file system, so there's a lot of Google influence across our platform. So at the same time, we've got multiple different persons working at the company from various other big time companies like Google, VMware, EMC, NetApp as well. At the same time, recently we've announced some big top tier investments, including adding SoftBank and continuing partnerships with HPE and Cisco at the same time. So what are we here to talk about? Well, our base software platform, the Cohesity Data Protect, our data platform. So what we have here is we're known mostly for what we call secondary hyperconverged storage, but we have so much more when it comes to our cloud offerings at the same time. So if you base the fact that that's the on-premises way to ingest data, we have multiple ways to also extend cloud connectivity, cloud archiving, the ability, or what we're going to get into, which is our product called Cloud Spin in a little bit. But we do a lot of things with we have some long-term retention, VM migration, some test dev capabilities, some cloud native backups. So once we run our particular data platform in various public clouds, we also work with their APIs for more cloud native backups. Full lifecycle disaster recovery, fail over and fail back. And at the same time, multi-cloud mobility. We have some capabilities of being able to take, say you start off on AWS, but now you want to be on Azure. We have ways to be able to migrate things over from one cloud platform to another without really skipping a beat in the data platform itself. So one of the first things that we generally go over with on our cloud portfolio is what I like to dub our low-hanging fruit to some degree, is our product Cloud Archive. Idea here is we can add some sort of external connectivity to do our long-term retention. Basically in the cloud, but we can also work with things like NFS shares or S3 compatible, just in different locations. At the same time, we get our standard encryption and our dedupe and compression capabilities on top of it. And at the same time, plugged into it, we can also then drill into file level restores, not just necessarily VM constructs as well. And we also have cloud retrieve. So once we put our cloud archive data, as long as we have another data platform system available, whether it's in the cloud, at another physical site, another hyper-converged appliance, we have the ability to then take from that archive and move that data down to another location. So So one of the things that I'm mostly going to focus here on this is the concept of VM migration. So we have the capability through our policy engine on an on-premises version of the data platform to take a backup of that particular virtual machine. So think of it in normal VM speak. We're going to do a snapshot-based backup, and we're going to ingest the data into the platform. Then what we're going to do is we're going to perform our cloud spin operation. So what we're going to do is the VMDK in question that's created from the VMware environment, we're then going to go through a conversion process. So depending upon if it's Azure or AWS, there's two different methods to go for as far as the migration concerned. So what we're going to do is we have built into it, the Cloud Spin application will do the conversion for you for one of those platforms. And at the same time, if need be, we can also launch an instance of that virtual machine in the cloud. Now, the thing here with that, the launching, is we already have to have some of our cloud components pre-created. So your networking already has to be there. You have to already have storage accounts in the case of like Azure. So you already have to have some sort of a cloud, kind of almost parts of it already pre-created to be able to use it. Now what it allows us to do is we can easily migrate the data to public cloud, and at the same time, the conversion process is taken care of. So one of the things about this particular presentation we wanted to at least get out and about is the fact that we don't have to change or don't have to do anything funny with the data housed inside of that VMDK to actually migrate it to these public clouds. We're going to take care of an easy conversion process, and what you had in your environment should run in the public cloud. So, as far as the Cloud Spin platform, there's two different methods. I mentioned we had policy, which allows us on the bottom. I misdid the order here, but we have what's called a protection job in our system. And what that does is when we perform the VM level backup within the vSphere environment, then once that's finished, we will then create a copy of that particular VMDK over into our cloud accounts. We also have what's called our test dev UI, which basically just means I'm going to connect up directly to that environment. I don't need a protection job, but I'm going to tell it, go grab the VM from the live environment and do the conversion without having to worry about the protection job. So the only thing, again, is you do have to have your networking information. You're going to end up with a virtual machine instance, whether that's an EC2 or an Azure, and you do have to know what region and what virtual machine type you're going to want to run that as when you push it out there. So the workflow is, it does differ depending upon the clouds. So as far as AWS is concerned, AWS does have a migration API already built in. So when I think of what AWS has to do, when you do the initial copy of the VMDK file, it's got to go to an S3 bucket to begin with. Then from there, behind the scenes, there's going to be a creation of an elastic block storage snapshot and a creation of an AMI, so an actual image then that you can work with and deploy multiple instances of the virtual machine. At the same time, if you're going to go and actually turn on an instance, it's going to turn on the we're going to enable an EBS volume for that EC2 instance, and then actually fire the virtual machine up. So it's going to do everything after connecting to the networking, grab an IP address, things like that. Azure's conversion is much simpler due to the fact that there's a lot of similarities between what VMware does with VMDKs and what Microsoft does with the VHD or the Hyper-V format. Essentially what happens is header information gets wiped out from the VMware side, and the Microsoft version, we basically write a new header to point to the same data. So as you can probably tell based off of that, less steps means Azure doesn't take as long as AWS's process concerned. So the app mobility for failover capability. So now that we've started to work with the Cloud Spin component, what we can do is on premises, we can essentially take entire application sets. So in this case, we're getting an example of web app VMs and SQL VMs. We're ingesting those into the data platform. We're going to convert those particular VMs with Cloud Spin over to our cloud in question. And based off the fact, if we have a cloud edition running out in AWS or Azure, also listed GCP is listed here, but we don't have a conversion yet for Google Cloud Platform. But I would assume since we have Cloud Edition running, we will have Cloud Spin available at some point for it. So once we get that out there, now we've got the data and our VMs running out in the public cloud. And at the same time, now we're backing them up with the Cloud Edition side of the equation, which allows us, with the failover, we go one direction to public cloud. Now let's do this coming back. Okay, well, flew by that one. Previous. Okay, so now from the data platform from the cloud edition, we can then cloud spin the VM back to an on-premises version of it. So we can, if we build data into our cloud instances, we can essentially harness them and pull them back into on-premises at the same time, and essentially allow for the idea of failover, fail back from public cloud to private on-premises. At the same time, one of the interesting things that we can do, and we've had some people challenge us on, if you have a cloud edition running in AWS and in Azure, you can cloud spin between both of those at the same time. You can go AWS to Azure, Azure to AWS. Okay, so a little bit here as far as cloud spin demo from a UI perspective. Unfortunately, that's not going to work. Well, from our UI perspective, here we go. So I'm going to try to skip through some of the video here. So from a UI perspective, we're going to show via a policy. So we're going to essentially create a policy. We're going to call this Cloud Spin to AWS, and we've got an option down here for Cloud Spin. We've already created a connection to AWS within the platform. As you can see, I can select my region of choice. So I'm going to do US West 1 and create my policy. Now what I have to do is I have to create a protection job. We're going to go into the protection job UI. Now also, I will also mention at the same time, this is all available to do also with REST APIs as well. So normally I would love to show this via, say, PowerShell scripting or something with a JSON file somewhere, but it looks a little bit better than having to go through a couple lines of code to make it happen. So what we're doing here is we're kind of what I mentioned about the Google influence. We have Google-like searching through some of our indexing. I found the VM in question based off of just putting in CentOS, looking through my vSphere environment. So now I applied my policy. I'm going to connect to what's called our storage domain, which is the storage in the platform itself that we're going to actually bring the snapshot into. And then what we're going to do is we're going to fire the job off. And what's happening here is that the job is initiated. We're in the midst of performing things in the vSphere environment. I'm going to cut ahead a little bit, and now we're in the cloud spin portion of this. And what I'm taking a look here, we're actually doing the S3 initial VMDK copy, because there appears to be a file that has something named VMDK and the VM in question. So after we've finished, I'm going to go back and check EC2 one more time. Notice it took about 16 minutes. A lot of it depends upon speeds and feeds. But after a refresh, now I have things like an EBS snapshot based off of running AWS VM and port. So now I have an EBS snapshot to work with. And what I should also have available here is an AMI, so a full-fledged image that I can reference and then en masse deploy with that AMI code. So that is how we go through from a policy perspective. I'm going to skip ahead and now show from a test dev UI perspective. We're not going to associate this with a backup job and have that run in front of it, but what we're going to do is we're going to harness an existing backup job that may have already happened with the system. So the data is already on the storage system in question. So I found the job, and now I have to answer some questions related to the cloud account that I'm going to connect to. I can do things like add prefixes or suffixes to the name automatically, so I can label it appropriately. But now I'm going to look through my source, and I'm going to find my AWS account. And just like I mentioned prior to this, now I got to figure out what region. Now I got to do an instance type. So we got a bunch of the different instance types that are available. In this case, I'm doing a T2.small. I got to select my VPC for that account. Same thing with the subnet, and also the network security group. I also have it checked here that I'm going to actually, the VM that's created is going to power off. But it does have to do some consistency checks, and it will power it on initially, just to double check and make sure that everything's okay. All right, so now the process is running, and it, very similar to the policy part of it, we're going to go and we're going to check S3 one more time, and we're going to have a new VMDK that's been copied out there. So we have a new VMDK, and now we should, and we got to the end of it. This one took roughly about 19 minutes front to back with, so again, AWS takes a little bit more time than Azure does. as we'll find out shortly. And you see we now have an actual instance. So we see that t2.small instance, it was stopped. And because I ran this video shortly after I had already created the other AMI, it's now registered in there as well. I now have an EBS store volume that backs that EC2 instance, and I should have a snapshot as well. Okay, so now that we've actually gone through and shown that we can essentially create a virtual machine disk out there, what I wanted to do is I wanted to show off a little bit, while it's not inherently in the Cohesity system, but kind of to complete the workflow idea that now I have a disk image out there. Now what can I do with these sorts of things? So I've been experimenting with HashiCorp's Terraform product a little bit, and what I'm going to do is I'm going to fire off. So I've already done a plan. So if you've ever run Terraform before, what you have to do is you have to take the code and load a plan to kind of pre-tell it what you're going to build. And now what I'm going to do is I'm going to apply that plan. Now, during the course of this particular demonstration, this will likely not finish, but what I will show you is instead, so now you have a virtual machine disk image, but what I'm going to do is I'm going to create an entire app stack based off of this. Now, granted, I will state this, I had a heck of a time trying to find a web app in question to kind of show this off, but I did do a pretty good completion of showing that I'm going to create 20-some objects in Terraform using that one VM disk file that I had imported out there. So right now, we're in the midst of creating essentially our networking available out here, and I'll switch over while that's running. So this was the resource group in Microsoft Azure. If I hit refresh, you can see now I've already started to build a bunch of things. Now I've got some network security groups, an availability set, some public IPs available, and this is all coming from that Terraform file. So I'm essentially building the entire structure, and at some point, we should be getting to the point where now we're actually going to build VMs. There we go. So now I have 3 VMs that's going to constitute my web server farm. I have their network interface, the 3 virtual machines, and I have a load balancer that I'm fronting in front of this. So essentially, all I had to do was kind of perform gold master type of image creation on premises, dump that out to the cloud, and now I'm able to essentially create an entire cloud stack based off of that one VM that I pushed out there. Now, it takes about 10 minutes-ish. I'm not going to sit up here and try to tap dance too much as far as things are concerned. But what I wanted to also add on to this is, you can, in CloudSpin, do multiple VMs in one job, get all those disks out there, and then based off of it, add even more, if you want to say, more things to essentially create in this cloud stack. I wanted to show more of like adding a database engine and having that app inside of those VMs be able to talk to it. But at 2:30 in the morning, it just wasn't working out for me. So at a minimum, I can at least show that we are in the midst of creating these things. So if you notice, we're still creating the virtual machines based out of here. And like I said, the last time I did a timing on this, it takes roughly about 10-ish minutes. Azure's not exactly known for fleet of foot for getting a VM powered up as quickly as, say, AWS is. So while that's going, I guess I'll switch back to this. So based off of it, I will state that while we have the capability of being very integral into making sure that that data gets ported, but from a larger perspective, when you think about the entire workflow of taking that data that you imported and getting it actually usable, what I'd love to see is us to be able to do things like plug Terraform modules into it, and I really hope that we get to a point where I can show things like that in the future. But for the moment, utilizing a bunch of third-party tools, you can take basically based off a simple backup within our platform and essentially build entire cloud stacks just with a couple of steps in between. So with that, I basically have a thank you here, and looks like I'm ending a little bit early on this one. I didn't expect the Terraform thing to last as long. So if you want, we're at booth 1420. Swing by before the end of today, and I can show off CloudSpin even more in the booth as well. So, thank you.
All right, welcome to GitHub for getting started with GitHub for Power CLI users. So right off the bat, I want to thank you for attending because I know there's free beer that's just a few steps away. So I'm going to make this quick, and I apologize for making it quick. I have about 10 minutes to kind of go over the core concepts. And I'm going to preface all this with saying that there's lots of blogs and articles out there on how to get started, how to use GitHub, but I kind of feel like it's lacking that like personal touch. So I'm hoping to kind of give you guys that personal touch. I've included like at least one guy's blog so you can kind of look at it because I feel like it gives like a really good narrative on what to do. But I feel like I just need somebody to talk to me sometimes when I'm working through a problem. So as far as you guys getting started, you know, hopefully this will help you kind of nudge you a little bit. My name is Justin Sider. I'm the Chief Information Officer at Belay Technologies. I really just write a lot of PowerShell, which is kind of cool. So here we go. That was supposed to be deleted. So we're going to go over real quick, like what is GitHub, what is source control. You'll learn some of the words, some of the tools, some scenarios, public and private, internal repositories and what you do there, and then we'll see if I have time for the CI/CD pipeline. So here we go. GitHub is a version control system. All that means is it tracks changes over time, and it's going to do it in a small way. So just to be clear, Git is a software, GitHub is a service, and that's an external service, something you're going to subscribe to online. And then GitLab is something that you can actually download and run side internally. Okay, so there is a difference, and everybody uses them interchangeably. So take a look at that in the future so that you're not confused. All right, so some language terms. We have the downloading items. We have cloning, the fork, and pooling. Saving stuff, commit, and push. I'm going to go into all these in a little bit more detail, so bear with me. And then we have branches, and there's a lot of terms around branches, and we'll cover all those. So we have master, feature branch, merging stuff, pull requests. Holy crap, there's a lot of terms I've already gone over. But just wait, I have pictures. Pictures make everything better. All right, so, you know, never save your passwords in GitHub. I feel like I should preface with that. No plain text keys, make sure they're always encrypted. Don't save any proprietary information like maybe IP space or, you know, general network layout, whatever you guys would consider proprietary. And then if you're downloading somebody else's stuff, just don't run it. Like inspect the script, inspect the software, whatever you're doing. All right, so downloading, right? So this is probably what you're gonna start off doing. You're gonna see somebody's project, and you're gonna say, all right, I want that. So you have the option to install Git, and whether you're using the client or whether you're using the command line, you can say, let me clone that repository. And cloning just means I'm going to download it from the internet, put it right on my machine. That's it. And you can do that from your personal repository, or you can do that from somebody else's. This is where you start to get confused, so bear with me. All right, a fork. So notice I'm still within the cloud, right? So here I have the cloud, and then I have my desktop, and I'm pulling stuff from the cloud to my desktop, right? Big move. When you're forking, everything stays up in GitHub or GitLab, right? Whatever it is. So basically you're saying, Dan, you have a repository, and I want to copy that repository, so I'm going to take it in GitHub, and it's going to go just straight over to me. And when it does that, it's linked back to Dan's, but it's still my full copy. So if I make a change, Dan's copy doesn't get updated, right? Unless I say, hey, I want you to like throw this stuff over there. And then there's an approval process. It doesn't just happen. Okay, so fork is just, think of it more of like a horizontal, right? And then you can clone that down to your machine. All right. So here's kind of like a diagram of fork versus clone. So you can see the fork is going on the horizontal, and the clone is actually coming down to you. Okay. Let's see, fancy words. So, my positivity there, like, you can do this. It's not hard. It takes time. It'll make sense. So pooling stuff. So pooling stuff is, I have my repository up there, and let's say it's not mine. Let's say it's Dan's or somebody else's, right? And he's made a change, right? He's updated his code from version 1 to version 1.1. What I would do is I would pull that down. So now I get the 1.1. So it's not a clone, because I don't want to make another copy of it. I just want the changes. So I'm just going to pull the changes down to me. There's a bunch of different options. So I strongly suggest you read the documentation. I'm just trying to kind of cover the highlights of it. So saving stuff gets into that horizontal method again, right? So I've taken my code, I've cloned it down to my local box, I've made changes. You're going to save the file, right? I mean, you have to save the file. And unfortunately, saving the file doesn't do you anything as far as Git's concerned. It'll tell you that there was a change. It'll show like potentially a little red X on the or exclamation and say, hey, there's something new with this file. But it doesn't do anything with Git. So the next thing you need to do is commit it. So committing it basically makes it Git aware that you've made a change, and it takes a hash of whatever changes that are. And you can commit directory, a file, a set of files, multiple different things. But again, it's horizontal. You haven't done anything with GitLab or GitHub. A commit is strictly local to your machine. This is where the push comes in. So the next thing you're going to do is you're going to push it up. So you take that commit and you're going to push it up. You're going to add some comments to it. And now it's going to be in the repo, up in the cloud, where everybody can see it. And then people can now clone or pull from you those new changes. So to review this again, pretty pictures. I don't take credit for these pictures. I didn't draw them. I found them on the internet. I couldn't copyright them though, or find the copyright. Fork, horizontal. Clones coming down. Commit, horizontal. You're staying local. Push goes back up. Pretty simple, pretty good. So now we're going to get a little complicated. All right, so your base repo is called master. I don't know why they called master. Subversion would use something like trunk. Just know it's the base. Everything else off of that's going to be a branch, and you can call it a feature branch, a bug fix branch, whatever kind of branch you want. It really doesn't matter. The point is that it's a separate stream of code, right? I am horrible at creating branches, right? I'm the only one that kind of works in my own code, so I always just kind of work out of master, which is a really bad thing. Don't do it. Use branches. So, and a branch should be tied to a ticket or an issue or whatever kind of troubleshooting system you guys have. So, and that way, maybe multiple tickets, but even one ticket's probably better, right? Smaller changes are better. All right. So, a feature branch. This is the best thing I could find. You have on the top. So you have your trunk going straight through your master. On the top, I make a change and add some sunglasses to this thing. I have a teammate, they add a cowboy hat. And so long as these things don't interfere with each other, we can potentially merge them right back to the master branch, right? So it's possible that we're adding two different features at the same time to the code with no conflict. It will tell you when you go to merge that there is a conflict and you guys need to figure out how to resolve that, right? Maybe somebody has better trumping mechanism to put their code in over top of somebody else's. I just touched on merges, and merges are always branch to branch, so technically that the master is a branch, it's just the master branch, but you can't merge code into nothing. So if I own a repository and you want to make a change, you're going to be forced to make a branch, and then you can submit a PR, which I'll get to, I think, on the next slide, where you can request that change be added to my repo or merged to my repository. Here's a pull request. Pull request, think of it as like a code review, right? Somebody's going to submit changes to my code, and when it does that, if I have things hooked up correctly, it'll go out to, say, AppBear, kick off a build, make sure that their code doesn't violate any of our stop gates from the code being deployed. And then I get a chance to go over all the changes. So inside GitHub and even GitLab, you can see a line-by-line diff of every change that they've made. If they've added a new file, it'll show up as a brand new file. But it gives me an opportunity as the repository owner to not accept the change or to add comments. Maybe I want them to change a single line, and they can go back and make those changes. So pull request is just really just a code review in my mind. Yes. The question was, a pull request is like a request to merge, and yes. All right, so tools. I'm a Windows guy, I'm sorry. We have Tortoise Git, very much like Tortoise SVN. It's a Windows tool. It'll give you basically some controls you can do from the Windows file system. Also, we have Git Kraken. I've never used it. And then there's GitHub Desktop. So for a Mac user, you can use that. Command line tools, there's just Git, as I mentioned before. That is the actual tool itself. And you are actually required to install that even for the GUI tool. So the GUI just kind of sits on top of Git. Additionally, we have PoshGit and PSGit because we're all PowerShell users. I kind of looked to see like what the difference was between the two, and I really can't see why there's two. I feel like those two projects should be merged together, but I don't personally use either one. I like the GUI. Let's see. So now we're going to kind of go into why. Like, I'm telling you all about this, but why you should do, use Git or source control versus what you're about to see. Because I'm guilty of this, and I'm pretty sure everybody else probably is. So, one use case is you've written a script, and now, you don't want to change that script because it works, or it worked for this one thing, but you know that the guts of it could work again, right? So now you save it as my script debug, or my script from the internet, or something else, right? And then you have a bad one in there. Well, why the heck are you keeping a bad one around? Delete the thing, right? So stop creating multiple files. If you're just trying to complete the same task, use Git, version it. You can always go back, you can revert. I got 2 minutes, I'm going to speed up. So this is another issue where you are versioning it, right? Well, how old are they? Why are you keeping all these other files around? Do you have them tied to any kind of thing of when they worked or didn't work? Directories, you might do a version on directories, or you have a collection of files. Again, this gets into how do you know what works or what doesn't work? How are you going to tell your coworker that, right? Because God forbid you have these on a share drive. I'm sure that's a mess. Getting back, so the GUI tools will give you line-by-line diffs, and at the bottom you also see revision history. So you just right-click on the file, you click revision history, and you'll see how many times that you may have changed it. So it's great for trying to troubleshoot why something may have broken. Public and private, so in GitHub you can pay for an account, and you can have a private repository. That means you and only your collaborators can see. Public is anybody can see it. Even if in a public, you still have control over who can add code to your repository. All right, internal repositories. So you're talking about GitLab again. Same process as on the internet. You're going to build, you're going to test, and you're going to deploy. Right? That's the basis of the CI/CD pipeline. Here's our magical CI/CD pipeline. So I've set this up on the internet. I've set this up at work. I make changes locally. I submit to a repository. When that repository happens, I get a build from AppVeyor or Jenkins, and then I have the ability to deploy to PowerShell Gallery, or I have an internal repository running on Nexus. So you guys can do these things. There's tons of things out there to get you guys hooked up with this. So hopefully by now you might get the lingo a little bit better. Pun is perfectly intended. Any code that I have is going to be in this folder on GitHub. If you have any questions, reach out. I'm JP Sider at wherever you are. Thank you all for coming. Hope you enjoyed it. Hope you don't have too many more questions, but I'll be available afterwards. So thank you.
Hi, my name is Leah Shobe, and I work at Rubrik as a Master Technologist and TME. And the reason why I want to talk to you today about operationalizing technology is throughout my career, I spent a lot of time in development, making new products. But one thing that I didn't think much about was how is this actually going to be operationalized in a production environment? And so I thought, I should take a year out and figure out what to do. So my previous job, I actually signed up to work in services to really understand what it takes to do this. And my eyes were open. So I will tell you that today, if I had to do it all over again, I'd probably code completely different. I highly recommend every developer, anyone in engineering, even in the CTO's office, that you all should take the time out and do a 6-month, 12-month stint in services to really understand what really happens here. Because there's so many little nuances that we don't think about. We think, well, it's just a 5-minute install, but we don't think about what it takes to actually deploy it. And it's a little less about technology and a little bit more about operations and procedures. So I recommend that you get to know the folks over in services, over in operations. They're some of the brightest minds in the company, and a lot of people don't realize that. They think, oh, they're just customer service, or they just do special ops things and professional services, but actually they're the mavericks of the company. They're the ones that save your bacon when everything goes to hell in a handbasket and you really need to save that customer. So I really recommend getting to know them. They will tell you all the ins and outs of exactly what they go through. For example, even to provision a new virtual machine, a lot of times there'll be requirements of, okay, so you need to deploy an additional virtual machine to handle XYZ operations. We'll find out how long it takes your average customer to actually be able to do this. For example, I was supporting a healthcare company, and what I found out was that it took 4 months to get that virtual machine actually deployed. So you got to think about that for a second and think about the support matrix, exactly what you're asking for, because a lot of these infrastructures are webbed way back. I had another customer that was on vSphere 4.5. A lot of them are on 4.5, 5.5. And what you're going to find is if you require them to be on 6 or 6.5 for certain operations, it's not that they're not willing to do it. It's just how they have to go through all the procedures in their company, the sign-offs, everything that they have to do. And it may take 6 months before they get a chance to do a 5-minute install with your product. So just make sure you keep that in mind. There's a huge gap that I see between the product being developed and the product being deployed. And so with this gap, you just have to keep all of these things in mind. And if you get to know the folks in services and actually get an opportunity to try to close that gap, that would be quite helpful. And another thing that I've noticed in this is, in closing that gap, is some companies have enhancement requests. They say, hey, we just put in an enhancement request that's taken care of. Not necessarily, because I find a lot of those enhancement requests are actually ignored by the developers because they really don't understand the pain that our customers and our services folks go through to actually put this into production. So keep that in mind. And so in summary, I say, make sure you understand that. Try to close that gap. Try to get to know those folks. And if you do that, I think you're going to find yourself coding completely different. You're going to keep in mind what it takes to actually operationalize and what requirements you request in order to install that application. You're going to want to think twice before what you put in the support matrix.
Okay, everyone. Thanks for attending my vSphere upgrade process presentation. A short introduction for myself. I'm Manfred Hofer. I'm working as Senior TAM at VMware. I have a blog, I have a Twitter, I'm a certification junkie. I think, except the VCDX, I have all the certification VMware offers. I'm a vExpert, I'm a Cisco champion, yeah. And I love technology, and I have a lot of customers I'm talking to and helping them with upgrades. And this presentation is not only about the click next install thing, it's about how to prepare for an actual upgrade. So this is a short agenda for today. So there are reasons I need to upgrade, or I should upgrade. There are also getting information. So what do I need before I actually upgrade my environment? And there is upgrade day. What should I know during the day? What infos do I need during the day when I do the upgrade? So I think some of you might be familiar with such situation. So I was used to be in the past this one guy. So every time in my first job a new release was there, I was the first one downloading it and installing it. And then it went boom. So why to check your software? Why to check the backups? Oh, my backup is not working. And this is also a funny thing. So let's plan the upgrade. Oh, I did it already. What? So there are a couple of reasons why I should upgrade my infrastructure. And I had some customers that were really happy about staying at some specific release. But there are reasons to upgrade. The first reason is software cycle. So I hope everybody is aware that 5.5 is end of general support in September 19th. So also, if you use Site Recovery Manager, if you use 5.5 with Site Recovery Manager, you have also to upgrade the Site Recovery Manager, because 5.5 or 5.8 of Site Recovery Manager is not supported with 6.0, 6.5, 6.7. There are also hardware life cycles, like if you buy today an HP server generation 10, this server is only supported since 6.0 update 3. There are a couple of other servers that might be supported, but normally HPE or Dell or Lenovo, you name it, drop the support for specific hardware types, so they will make you to buy new hardware. Also, the operating system. I found only 3 operating systems which need a vSphere upgrade. This is Ubuntu 17.10, 18.04, and Windows Server 2019 Technical Preview. So this is a really rare situation. Also new features. Maybe if you're saying it's 6.0 or 4.5, you want new features like VMFS 6, or moving an external platform service controller to an embedded platform service controller, or multiple CPU fault tolerance. So this could be a reason to upgrade your environment. Who is here from the financial side? Who of you guys doing plastic cards? Okay, nobody. But because there is also one compliance requirement, because if you are doing plastic cards like MasterCard, Visa, or Amex, you have to follow a PCI DSS compliance. And this compliance, it reads you need to use TLS 1.0 at the minimum, and with the newer versions you have to use TLS 1.2, and this was not possible in 5.5. And the last and important one is security. Who had to patch Spectre Meltdown? Or Spectre Meltdown Next Generation? Or L1TF? So, and I think this is just the tip of the iceberg. So the important thing is to gather your information. So check the HCL. The only problem with the HCL, with the VMware HCL, it is filled by the vendor. So everything the vendor hasn't put in there, it will not be there. So check also the vendor site. The vendor site is the most updated source of truth. I had situation where I also can't find a specific version which is mentioned on the HCL, on the VMware HCL, but doesn't show up at the vendor site. So this is sometimes a little bit complicated, and you will lose here a lot of time. Also check the vendor compatibility metrics. Every vendor like Dell, MC, HP, Lenovo, you name it, has a server compatibility list where it says, okay, this server is supported with this and that release. Also, firmware drivers combination. Check if you're currently, before you upgrade, on the right version. And supported storage. I heard about that a half year ago. So there was at HPE, there is a site named Spock. You can check if your HPE firmware version is compatible with your, for instance, free-path firmware. I didn't know that before, so I was really, okay, you have to check this too. Software. The big question is, which version of vSphere are you running? If you're running 5.5, you don't have a direct upgrade path to 6.7, so you need an interim step. So you need to go to 6.0 or 6.5 before you can go to 6.7. Also, check your VMware software that is running in that environment, like Horizon, VROPS, Loginsight, NSX. Check if you are on a compatible version before you upgrade to 6, 6.5, 6.7. Also, check your backup. I don't know how it works creating this backup matrix. I try to update it every couple of months. It says which version of which backup software is supported with a particular release. This also is for vSphere, older vSphere, and Hyper-V. And check your third-party software, like PowerPath, MDL, which is called from HP, or monitoring software. Also, check if you're running a Nexus 1000B. Who got the Nexus 1000B in their environment? Okay, that's new. We as VMware discontinued the support for third-party integration switches into the vSphere platform. So with 6.5 up to 2, we dropped this API entirely. Web Client and vCenter Server for Windows was deprecated last year in August. So if you have a Windows vCenter, plan your migration to a VCSA, the appliance version. Also, if you upgrade to 6.7, a really bunch of CPUs were deprecated. I hope nobody is running server on these CPUs. Maybe you're running some of the Xeon 56XX series, which is still good for home lab or maybe testing environments. Also be aware that 6.7 is the only release supporting this bunch of CPUs, which also will be deprecated in the next or in one of the future releases. The reason for that is that we removed binary translation virtualization, which is the software virtualization. So in 6.7, we focus only on hardware virtualization because every modern CPU is supporting these three features. So these three features are really necessary if you do hardware virtualization. And why we don't support for instance, Nehalem processors, because the lacking of the VMX unrestricted guest. Upgrade day. You gather your information, you know how your environment looks like. What do I need on upgrade day, or also a little bit before. So we have 3 KB articles which describes the upgrade sequence. So before you can upgrade to a specific vSphere release, you maybe have to upgrade other things like NSX, Vera, Vero, Loginsight, etc. Only if this kind of software or backup software, before this kind of software isn't updated, you can't upgrade your environment to 6.5, 6.7, 6.0, you name it. Also, please read documentation. I had so many customers that don't read the documentation and that also don't read the release notes. If you have read the release notes once, read it twice, read it a third time. Because sometimes in the release notes, you do an upgrade, or I've done it in the past. I did an upgrade and I did it a couple of times, but there was one release because of TLS or SSL v3, where you had first upgrade the vCenter and after that the ESXi host. Normally, it's supported to upgrade the ESXi hosts first, but my recommendation is always upgrade vCenter first. And also follow your process, if you have a process. I have customers I was talking to and I said, have you put a change in your change management? And they got to me, what change management? I thought, okay, we need to have a talk about this. So if you have a change management, create a change, document everything. During the upgrade, please document every single steps you're doing, because if you go on vacation afterwards, and please don't do that, your colleagues need to handle this mess if some mess happens. And also, after the upgrade, when everything is up and running, vCenter is Xhost, you don't need to do this, you can upgrade VMware tools. I would recommend upgrade VMware tools to one of the latest versions, like 10.2 or 10.3 or 10.3.5, because some of the older versions, like 8.6 or 8.4, are not supported with 6.7 anymore. But we have also for this an interoperability matrix. So just select ASXi host, VMware tools, and you get a bunch of information out of there. And also, virtual hardware upgrade. This is also optional. And if you want to use new features like in 6.7 per VM EVC mode, this virtual machine needs to have virtual hardware 14. And the bigger thing, I think, I didn't know about that, but if you change the virtual hardware, this means also that additional CPU features will be exposed to your VM. Even if you have EVC enabled. For instance, if you have a hardware version, let's say 7, and you have the EVC mode Broadwell, then this version does only get, I think, CPU features up to Nehalem or Westmere. So please check. I had a customer who got an issue with an Oracle 6.6 Linux, which has a really old kernel. They upgraded them to, I think, hardware version 13, and this Linux kernel panicked because there was a specific CPU instruction exposed to the virtual machine. The kernel didn't know, and that was the reason it kernel panicked. Okay, thanks for your time. Does anyone have any question about the topic? So this is not quite actually the upgrade process from the vCenter ASX itself, so it's just a hint how you should approach this type of doing. Questions? $5,600. It will work, so you can install it. So normally, if you install 6.7 on one of the deprecated CPUs, then you got a message where it reads, "This is an unsupported CPU," but it still works with 5.6, also 5.6XX CPUs. So this is possible, but for production, this is not supported. Yeah. For home lab is totally fine. When you have when you get a 5.600 CPU, yeah. With all others, you get the message unsupported, and yeah, you can't do anything with this. So if you have it, oh.
Platform services controller. So
yeah.
You have, so in our environment, we have two platform services controller on 6.0 in the enhanced link mode to support the single sign-on, and we're in 6.0. So we're looking into the upgrade path, if you will, from 6.0 to 6.7. Do we have to go 6.5 or 6.7, or can we?
No, we can. You can. The question was, this gentleman has two platform service controller at 6. Okay. I take this question offline. So thanks everybody attending the show, and see you at the show.
Good afternoon, everybody. My name is Mark Crawford, and today I'm going to be talking about my experience building vSAN with certified components. And I just want to thank you for taking your time out of the busy day and coming and attending my session. So the agenda for my presentation is I'm going to talk a little bit about me, why I chose vSAN, the preparation that I did for building my vSAN, some lessons learned, and then we'll have wrap up and Q&A. So a little bit about me. I'm a senior systems engineer at NJBC. I worked there for about 7 years. I've got 20 plus years in the IT industry. I was in the Air Force for 10 years. I'm the St. Louis VMWorld leader. I've done that for a little over 4 years. 4 times vExpert. This is my 7th year at VMWorld. I have a whole bunch of certifications. The first certification I received was back in 1998. That was my MCP. I have 3 patents. I'm not going to talk about those today, but you can check those out on my LinkedIn page if you want. And I'm very active on Twitter if you want to get a hold of me. So why did I choose vSAN? Well, I work on government projects, and I work in an environment, we have a lot of software development going on, and about 95% of our environment was on government-funded equipment. And we lost a government contract that we had, and we had to turn that equipment back in. And so we had to come up with a solution to move all of our VMs and all of our data off all the government equipment that we had onto something that was commercial. And so we started coming up with ideas. And so when my boss told me that we had to basically turn all this stuff back in and come up with a plan, I went to his office, and he's like, oh, everything's fine. We'll get this taken care of, no problem. But in reality, it wasn't quite that simple. So we had to sit down and discuss a lot of things. And obviously, here's the main things that we had to discuss. We had to discuss what our budget was, what our actual requirements were, what constraints that we had, and what risks we wanted to accept. So there was a lot of discussion going on before we even went out and decided what we were actually going to do. So even maybe not using vSAN was also another discussion if there was another solution besides that. So there was a lot of discussion going on before we actually finally decided that we were going to use vSAN. So let me just back up just a second. So part of the reason why I chose vSAN was then because we actually had quite a bit of other equipment that was not government funded equipment. We had a whole bunch of servers, they had RAM and a whole bunch of RAM in there already. So that helped us make the decision on why we chose vSAN already, because we didn't have to run out and buy a whole bunch of hardware. We only had to go out and buy a little bit of hardware. So that made the decision a little bit easier for us. So once we figured out that we were going to do vSAN, one of the things that we first looked at was the licensing, because obviously depending on what you want to do with vSAN is going to depend on what license you need. So if we wanted to do something like stretch cluster, we're obviously going to need an enterprise license. If we wanted to do a RAID 5, RAID 6 erasure encoding, we would need at least advanced licensing. We already had quite a few vSAN licenses, but unfortunately we only had standard licenses. And it would have been really nice for us to be able to do erasure coding, but we got a quote to upgrade our licenses to advanced or enterprise, and we just really couldn't fit that into the budget. It was hard for us to justify upgrading our licenses. So we made the decision to just go ahead and stick with standard, and then maybe someday down the road we could upgrade to advanced or enterprise. And so the next thing in my preparation that we did before we actually started buying any hardware, we made sure that the servers that we had were on the HCL, and then everything that we were going to buy in the HCL. So my initial thought was, oh, if it's compatible with the ESXi host, we should all be good. Well, unfortunately with vSAN, that's not true. There are things that are compatible in ESXi in your host that are actually not compatible with vSAN. So the first thing you need to do is go to the HCL, and then once you're in the HCL, there's a drop-down link for you to actually go to for vSAN components. And then once you're in there, this initially takes you to a page that's going to help you build all these vSAN ready nodes. Well, we didn't have the budget to build a vSAN ready node. We couldn't just go out and buy something that's pre-configured and pre-built. We're actually building our own based on components that we buy separately. So if you're doing that solution, you have to go down to step 3, where it says build your own base certified components. I don't know why they make that so hidden down there, because it took me a while to actually find that, but if you're building your own solution, that's where you need to go. Another quick thing to talk about is also right below that is the sizing and TCO calculator. If you once you figure out how much data that you need to migrate, or if this is a new deployment, that is a very good link to go and figure out based on how much data you think you're going to have, or how much data you're going to have on the vSAN. That will help you calculate how many dishes you need to buy, what size dish you need to buy, and that type of information. And actually later on today, there's a good workshop going on, sizing workshop. So if you're interested in that, that'd be a good one to attend. So once you're in the vSAN compatibility guide, if you look over in that green arrow there, there's the 3 main things that you need to make sure that are compatible with vSAN. So you got your hard disk controllers, your hard drives, and SSDs. So once we started researching which controllers, SSDs, and hard drives that we were going to put in our servers, then we made sure that they were all on the compatible vSAN list. So we had Dell R720s laying around. Luckily, they already had 512 gig of RAM in them. And so I verified that they were on the vSAN list and they were compatible. So we were all good with all of our hosts. We didn't have to run out and buy any servers. So we were good with all of that. Then I talked with my local VMware rep and tried to discuss which different controller we wanted to use, because the controller that was in the R720s was not compatible with vSAN. So we had to go out and buy new controllers. And we did a lot of discussion. We talked with Dell, we talked with VMware. There were some Dell controllers that they wanted us to buy, but Dell told us that they weren't compatible in the R720s. So luckily we found this MegaRaid 9361 8i controller. And the biggest thing when you look at a controller that you're going to use in vSAN, you got to make sure the Q depth is correct, and you got to make sure that it supports JBOD. Those are the 2 biggest things. And so we found one that worked on our servers and then met those 2 requirements. So, and it wasn't too expensive either. So we were able to get enough of those for each of the servers. And then the next thing you have to make sure is, I didn't know this before we started building this, you actually got to make sure all your hard drives and SSDs are on the vSAN compatibility list. So after a lot of discussion with my VMware rep and our Dell rep, we decided to use these 2 different Samsung models. We chose an all-flash array, and these are actually only SATA drives. We wish we could have got SAS drives, but they're a little bit more expensive. We couldn't fit that in our budget. So luckily, these drives were still able to give us the IOPS that we needed. And so one of the 480 drive is our cache drive, and then the 960 drive is our data drives. So we had we chose our RAID controller and our SSDs and ordered everything, and we once we got it all in, we threw it all together, and we thought we were all ready to go, and we started building it, loading ESXi on it, and got it up and good to go. And on the cluster, I enabled vSAN part. Everything showed up in the disk management part, and so I thought, oh, I'm all good. I should be ready to go and just create my disk groups and then create the cluster. Well, that's really not the first step that you should be going to for vSAN. Even though it's solid and everything, there's some steps that you should do before you get too happy and go with all that. What you really want to look at is go to the cluster level and go to configure and configure assistant. And on the right-hand side, you want to make sure that all of those are green right there. I should have took a screenshot before I made all these greens, but before this, a lot of these steps were not green, and I had to go back and fix all those component parts. Mainly what it's checking for is to make sure all your hardware is good, all the drivers are good, all of the firmware and everything is all compatible. That's really what a lot of checks going on here. And then down in the cluster part, it's making sure DRS is all good and HA and all that. And then it's also checking your network cards, making sure you got 10 gig connectivity between all your hosts, and the vSAN part is enabled between all that network. So you really want to make sure all of this is green before you start doing anything else. And then there's one more health check that you want to check before you actually start doing anything else. So if you go up to the cluster level again, and then click on the vSAN tab at the top, and then click on health, all of those on the right-hand side need to be green. And so once we had everything fixed and everything green, at this point, we should have done a lot of performance testing, made sure everything was good, but because we didn't have a whole lot of time to migrate all of our data off of our old equipment, I wasn't able to do as much performance testing and validation testing as I really wanted to. And so we were really lucky that we were just able to start getting everything working. So here's one more performance check. If you go back to that configure tab, there's a health and performance, and then right here down where that health that says green, that's another part that you want to make sure that's green before you start doing everything. So luckily vSAN does a lot of health checks and configuration checks that let you know that everything is ready before you start moving any data or start using it. And so there in 6.5 version, it does a lot of good health checks. And so yeah, before we started doing any data, I would have liked to have done this performance diagnostic test, but unfortunately I just didn't have the time because I knew I had so much data to migrate off my old one onto the vSAN that there wasn't enough time to do it. But if there was time, I would really like to have done this part. And so once we started actually moving a lot of data from we had a UCS cluster. Once we started moving all the data from the UCS cluster onto the vSAN, when we went back and looked at the health, it would have showed us these two yellow triangles up there. And basically what it was saying was that the disks were out of balance. There was some data that was on some hosts, then that was not on others. So it was just rebalancing it. And it just took a little time for it to balance that out. But because we were migrating so much data at one time, it took a little while for it to do that. So if you come into health and you see that, that's the reason why. And if you look at down to the bottom down there, it will tell you what data is actually moving, what host, and you can even drill down in there farther to tell you how long it's going to take it. So even though it showed yellow up there, it's nothing really a whole lot to worry about, just something to keep an eye on. And so here's where I drilled down a little bit farther. It was telling me how long it's going to take, what data is actually being balanced onto what host. And so yeah, we've had it up for a little while now. I would say about 3, maybe 4 months now, and we've actually added more disks to the cluster. We have about 30 terabytes of an all-flash array, and we have all types of workloads on it. We have SQL, servers. We don't have Exchange on it because we're using Office 365, but yeah, we have a software development shop, so we have a lot of software development going on there, and we've been extremely happy with everything that we're doing. Any questions? I'm sorry, what's that? So yeah. So we only have one disk group, and we are because of the licensing, we're using the RAID 0, and that's the only thing that will allow us, and that was a risk we accepted, and so yeah, because the license that we have, that's a risk that we had to accept. But yeah, I mean, but that one of the benefits of doing that is supposedly it gives us more performance. So it's a trade-off that we had to have. So yeah. Latency. Yeah, we really haven't seen hardly any latency at all. Luckily, our IOP workload is not that high. We're not a huge shop. We probably have around 30 developers, and so we don't have a lot of like large production workloads. But yeah, usually under the 4 or 5 millisecond latency range. No, yeah, luckily, before we actually started the migration, about a year before the migration, I thought we might have been in this situation, and so I had already started doing a lot of consolidation to the UCS cluster, and even before that though, we'd never allowed RDMs, and so luckily we didn't have any requirements that people forced us to do it, so we didn't have any that type of stuff, so it was pretty much an easy migration, yeah. I'm sorry, what's that? Yeah, we have an all 10 gig network, so we didn't have to buy any Cisco switches or any, yeah, we have all Cisco Nexus switches, and yep, 10 gig, 5K switches, yep. Yep, and we had some Broadcom NICs that are in the servers already, so we didn't have to buy any NICs, yep. Yeah, so if you look back on the first slide, yeah, see those drives right there? Yeah, over here. So yeah, that's how we're doing it all. So I think right now each of them have actually 8 drives in them because we've added a little bit more as time has gone on. We've been able to spend more money and buy a little bit more. I'm sorry, I can't hear good. Yeah, we have VLAN just for vSAN. No, we have a dedicated NIC just for vSAN. Yeah, and then we have its own VLAN also. So yeah, each server has 2 10 gig cards in it. Any other questions? Yeah, so we are using a product called Quest vRanger. It used to be owned by Dell, but then they sold it, and now it's owned by Quest. It was originally a Quest product, and then they sold it, Dell bought it, and then after the merger, Dell sold it back to Quest, so we're using Quest vRanger. It does okay. It's not the best product in the world, but it works. Any other questions? All right, I want to thank everybody for attending my session.
Hello and welcome everyone. Thanks for spending your lunchtime with me. My name is Marco Abella. I am a Principal Product Manager at Dell EMC, specifically working on the XtremeIO product line. What we're here to talk to you about today is metadata-aware replication, which is a new, unique technique for efficiently delivering business continuity and disaster recovery. Very different and much more efficient from any other storage replication solution out today. Just by show of hands, how many folks here have XtremeIO today or are familiar with XtremeIO? So about half. Okay. So let's start by saying that replication by definition is the copying of data and no other storage. So in fact, it's actually a copy data problem. And no other product handles copies of data better than XtremeIO. Traditional replication solutions, they rely on brute force copying of data in order to do the replication. This forces administrators to have to make trade-offs between RPO and RTO and cost. So the higher the level of protection, obviously it comes with a higher cost. What you see with existing replication solutions is that they are not very efficient in the way that they do replication. So what you typically see with existing replication solutions is that all changes need to be replicated. Arrays at both ends need to transmit and receive all change data. There's no awareness between the two sites. WAN bandwidth needs to be sized to account for all change data, and many customers have to, in fact, deploy very expensive WAN accelerators in order to reduce the bandwidth. So in this particular example, we're looking at an existing replication solution where we have a primary site replicating to a DR site, so a source replicating to the target. The source and the target are currently in sync with these three data blocks A, B, and C. And what happens is, let's say a new data block is written. Even though this is a duplicate data block at the source and at the target, this data block A already exists at the target, but the two arrays are not, they don't communicate, and they're not able to know that this block already exists. So we actually have to use up bandwidth over the link in order to do the replication. Now, yes, some of the more modern storage arrays today have deduplication, where the data block would have been deduped at the source and then again at the target, but that deduplication would not take into consideration the WAN, the links. That block would still be sent over the WAN, and then once it arrives on the target, it then gets deduped, but again, from a WAN efficiency standpoint, it's not very efficient. The difference with Extreme.io is in using the metadata awareness of Extreme.io, where the source is fully aware of the content of the target, where if a data block already exists on the target that needs to be replicated over, we do not need to do that. We can do it in a much, much more efficient way, simply by replicating only the metadata. So same exact example as I was showing before. We have a source site replicating to a target where the source is currently in sync with data blocks A, B, C, and D. If a duplicate data block or a new data block comes in that needs to be replicated, same exact example as before, this is a duplicate data block. Data block D gets written. The source knows that this data block already exists on the target and it does not need to replicate it. It simply sends over its hash metadata, making it much, much more efficient, both from a storage perspective and from a bandwidth and link utilization standpoint. So what you saw in this example right here is that with the Extreme.io's metadata-aware replication, only unique changes are replicated, so data is deduped at the source, destination, and more importantly, over the WAN. And the unique data blocks that do need to be sent over, which I'll show you more later on, are done so in a compressed manner. The arrays at both ends transmit and receive only the unique data, freeing up the resource for other use. WAN bandwidth needs to be accounted or sized to account for only globally unique changes. In some cases, actually eliminating the need to deploy any WAN accelerators. I'll show an example of that later on. And you can free up this bandwidth for other applications, or you can actually increase your RPO or replicate other data that you previously weren't able to replicate before. Now let's see where this metadata awareness actually shines. So Extreme.io's metadata-aware replication also supports a fan-in configuration of 4:1, where 4 single source arrays can replicate to a single target. So in this particular example, we have the 5 arrays are fully in sync with data blocks A, B, C, and D. And again, any of the 4 source arrays are fully aware of the content at the target array. So let's say that site 2 writes a new data block. In this case, it's data block E. Even though this data block is unique to site 2, if any of the other sites were to write this same exact data block E, even though it is even unique to these other sites, these sites check with the target before beginning the replication cycle, and they know that this block already exists, so they do not need to replicate this over. So in this particular example, again, you're saving, by doing a fan-in configuration, everything is deduping against each other, so you're saving both from a storage perspective and from a WAN utilization perspective. What Extreme.io's metadata-aware replication allows you to do is replicate high change rate workloads driven by all-flash array performance while maintaining great RPOs. We actually support an RPO of as low as 30 seconds without breaking the bank on WAN upgrades. You can do 4:1 fan-in configuration where you're benefiting from global dedupe across all the single sources and at the target. again, saving both from storage at the target and WAN utilization. And you can make choices like getting the existing replication job done in the same amount of time using less bandwidth and therefore reducing your overall costs. Or you can increase the amount of data that you're replicating using the existing WAN bandwidth that you have while increasing your overall levels of protection. What XtremeIO metadata aware replication allows you to do is protect your workloads in the most efficient way possible. So it uses XtremeIO virtual copies, which I'll explain a little bit later on, and a wizard-based GUI for easy setup and full operational disaster recovery. It supports an RPO of as low as 30 seconds, allowing you to recover from up to 500 different recovery points with a sub-minute RTO. Actually, from a storage perspective, it's actually in a 0 RTO. We support a fade-in configuration of up to 4:1, as I showed before. From a performance standpoint, it's built around being able to support the high-performing use cases that XtremeIO supports today, with efficiencies that include being both dedupe and compression aware. So you keep hearing me mention this metadata-aware replication. So what does that really mean? Before we do that, let's take a look at some of the architecture of XtremeIO, specifically in it being referred to as CAS, Content-Aware Storage. What content-aware storage means in the perspective of XtremeIO is that as an incoming data block comes in, we create a hash of that data block, and we keep it in memory. For every single data block, we have this mapping of a hash to where it's actually stored in an SSD perspective. If a duplicate data block comes in, it means it will simply result in a duplicate hash, and we can simply dedupe it in memory. So as you can see, as a part of this, deduplication is simply a byproduct of doing the content awareness of XtremeIO. So it allows us to do deduplication very, very efficiently, always on and in memory. Next, let's talk about XtremeIO virtual copies. So XtremeIO virtual copies are very different from any other copy or snapshot solution available in the industry today. And what you have, the reason why is with the traditional snapshots, there's a lot of baggage associated with them. So first, they're never immediate. They take up some time. Second, they're not very space efficient. So best case scenario, you're only copying metadata. Worst case scenario, you're copying both metadata and doing a bit for bit copy. And last, you never get the same performance as the original source volume. In some cases, it actually negatively impacts the performance of that source volume, where as long as you have this copy created and mounted, it will actually negatively impact the performance of the original source. With XtremeIO virtual copies, it's completely different than any of that, and it has no baggage associated with it. So first, the snapshot operation is absolutely instantaneous. Second, it's both space efficient and metadata efficient. Even when mounting a snapshot, we are never copying any metadata or any blocks at the SSD layer. And last, we don't really distinguish between a source volume and a snapshot, or a production volume and a snapshot, other than a little icon in the GUI. For us, they're treated exactly the same, where the snapshot gets the exact same high performance as the original source volume without negatively impacting that source volume. And this is exactly what this shows. So this is XtremeIO virtual snapshot versus a traditional snapshot implementation, which what you can see is that in this is that at the moment that a snapshot is taken, the performance of that original source volume starts to go completely wild and becomes unpredictable. In that case, where it's actually getting performance that is really, really very, very bad, to the point that it's not even behaving like an all-flash array, it's actually getting the performance of a spinning hard disk drive array. With XtremeIO, again, we have no performance penalty when you take a snapshot, neither on the source or the snapshot volume. Another great feature of XtremeIO virtual copy technology is that we provide you the ability to instantly refresh or restore any volume or snapshot with any other volume or snapshot within its tree. So I can take a snapshot of a snapshot of a snapshot, and I can refresh between the snapshots. I can refresh back to production, or for production, I can pick any specific snapshot to refresh to the possibilities are really endless. But you can do all this, all these refresh operations while keeping the same SCSI face. So that means you don't need to do a host rescan, which usually takes some time, which I'll explain to you soon why this is very important and enables a very fast RTO from a replication standpoint. So put them all together and you have the basis for our replication solution. So first we begin by only replicating change data blocks. So in this example, again, we have a source array replicating to a target. And the first step in beginning the replication cycle is getting the source in sync with the target. So we create a snapshot to do the initial sync. We remove any duplicate data blocks, and then we send that snapshot over as a fully recoverable point in time. Then, based on the user-defined RPO, so again, we support an RPO of as low as 30 seconds. So let's say that the next cycle kicks off 30 seconds later. We take a snapshot, and we do a snap diff operation, which basically analyzes any changed data blocks from the current snapshot to the snapshot 30 seconds ago. So it's kind of like right folding. Rather than have to replicate all the different changes, we only replicate the latest ones. Then, once we've done the snap diff operation, we send that snapshot over, which again becomes a fully recoverable point in time for you to do a failover to. Now let's take a look at how the efficiencies come into play. Again, we have a source replicating to a target where the source currently has data blocks A, B, C, D, and E. At 12, we do a snapshot for the initial sync to move these exact data blocks over to the target, where now we have the source in sync with the target. The source volume is your production volume, so obviously it's changing, you're writing data to it. So let's say that it writes brand new data blocks, D, F, B, G, and C. And at 12:05, we kick off the first replica cycle. So in this example, the user specified their RPO is 5 minutes. So again, what we do is, as part of the first replica cycle, we take a snapshot, we do a snap diff to change, to analyze any changed data blocks from the current snapshot to the one 5 minutes ago. In this case, it's again those data blocks D, F, B, G, and C. Next, the source checks with the target to see if any of these data blocks are unique or already exist at the target. In this case, data blocks D, B, and C already exist at the target, so they do not need to be replicated. And last, the unique data blocks, which are blocks F and G, are compressed, and then the replication cycle is completed. Again, replicating all these data blocks and making that full volume available as a point in time for the user to recover from. So with this, what you can see is that the metadata-aware replication solution for XtremIO truly is the most efficient storage replication available in the industry today. From a failover perspective, I'll show you how it works. But first, you need to recall what I was mentioning before. Part of the flexibility with XtremIO virtual copies is the ability to instantly refresh or restore while keeping the same SCSI face. So in this particular example, let's say the production site goes down, and at the DR site, I have 4 different point in times that I want to recover from. At the DR site 2, I have my the failover volumes already exposed and mapped to my host. So all that needs to happen is a refresh operation of the point in time that I want to failover to, handled internally as a refresh operation to the host. So what happens is when I pick the point in time, we simply do the XVC refresh operation, which is instantaneous, which simply refreshes the content of the mapped volume to the point in time, again, without needing to do a host rescan. So from a storage perspective, the RTO is instantaneous. It's really, from a user perspective, how fast you can bring over your application over on the other hosts. So really, the architectural advantages of XtremIO in being content aware really lend itself to replication efficiencies in the solution. So what we have, again, is first we replicate changes only. We benefit from right folding. Again, we don't need to replicate all the change data. We only replicate the change data blocks that happen at the end of the at the end of each cycle. We have global across-site deduplication, where again, the source is fully aware of the target. If a data block already exists on the target, we do not need to replicate it over. This is what truly makes the solution unique. And last, the unique data blocks that do in fact get replicated over are done so compressed. So let's take a look at how this benefits the solution from a performance standpoint. So this is a single XtremeIO XBrick using 2 replication ports, so 2 of the 10 gig base T interface, where theoretically the max throughput that you can get with this is about 2 gigs per second. So here we've ran tests across 4 different latencies. So one is at 0 millisecond latency, which is replication within the same data center. Next is at 40 millisecond latency, which is, to give you an example, is intra-Europe replication, or from a US perspective, it's from Seattle to Chicago. Next is at 80 millisecond, which is US East Coast to West Coast, or Europe to North America. And last is 200 millisecond latency, which is intercontinental replication. So what you can see as part of this is that we're very close to reaching the theoretical limit of the 2 gigs per second from a average throughput perspective, but also as we are increasing latency, we are really getting almost no penalty in terms of throughput because of the way that the replication solution works. Now imagine that you're able to get 4-to-1 dedupe across the link. That means that your WAN bandwidth is actually just multiplying by 4x. So again, you're getting much more efficient replication solution at much higher throughput speed. Again, all made possible by this, the replication of metadata rather than just sending over the full data blocks. From a VMware standpoint, we have full integration with VMware's SRM through an SRA adapter. And one of the really cool, unique things that we offer is the ability to pick our recovery point from SRA. So SRM today only allows you to fail over to the latest point in time, which is actually kind of backwards thinking, because if you have some type of data corruption, or for example, you have a virus with a very low RPO, that same data corruption is going to get replicated over to the target site. So if I only have the ability to fail over to the latest point in time, that same exact corruption is going to happen at the target, at the DR site as well. So with our VSI plugin, which is a free plugin which exposes storage functionality over to VMware from a vSphere perspective, you can actually go ahead and trick the SRM to actually fail over to a specific point in time that you can select. So this is a very unique implementation that we have with SRM that's available as part of this replication solution. So in summary, with XtremeIO's metadata-aware replication, it plays around the theme of XtremeIO's being a consistent and predictable storage array, and the same with all the data services. So first, it's very efficient. In fact, it's the most efficient storage replication solution available in the industry today, where we only send unique data to minimize WAN bandwidth requirements. And again, the source is fully aware of the content of the target. You can have 4 source arrays replicating to a single target, where all 4 of those arrays are fully aware of the target, never needing to replicate duplicate data blocks. It's consistent with minimal to no performance impact with a scale-out architecture that is XtremeIO, allowing you to add compute as you're scaling with capacity. And it's extremely reliable with fast recovery across sites, supporting an RPO of as low as 30 seconds. With that too, with all the Dell EMC storage arrays, we have the future-proof program, which basically is a type of guarantee allowing you to have faith, basically show commitment in your investment. So we have a 3-year satisfaction guarantee, a hardware investment protection plan, which will buy back existing hardware for refreshes at a very competitive, from a very competitive cost. We have predictable support pricing, where you can lock in your maintenance at day one, locking it for the lifetime of the array. A 4-to-1 all-flash storage efficiency guarantee, where we'll actually guarantee you that you're able to achieve at minimum 4-to-1 efficiency with your storage arrays. We have never worried data migration, which is also very good, because from a hardware upgradability standpoint or tech refresh standpoint, we'll actually guarantee you the ability to easily migrate to these new generations. And we also have all-inclusive software, where any of these features with Extreme I/O, the deduplication, compression, and even the native replication feature, it's available at no additional cost. It's simply a data service that's built into the DNA of the array. So with that, thank you very much. I'm available to take any questions if anyone has any. Thank you.
Good afternoon. This talk is supposed to be about how Power CLI is used to shut down a StarWind 2-node cluster when you have a power outage. It is, and it's not. So first, let's talk about StarWind. It should be noted that although this session description stated that it's a critical flaw, that the workaround is now formally documented via a white paper that StarWind has published. You can email support@starwind.com for the official document, or if you want to know my specific tweaks that we've come up with for their white paper, you can email me at starwindshutdown@gmail.com or reach out to me on Twitter at GSXESX. For those of you here in the audience today, I'd be happy to meet with you individually after the talk concludes to discuss the specifics of the fix, or for those of you watching this remotely, please feel free to reach out directly. I'd like to add that myself nor my employer is receiving any benefits from StarWind for giving this talk. I'm just trying to share what I've learned with the community. Now for the remaining time. I think it's important to tell the story of how I got here, how we came up with the fix, and why I'm speaking to you now. I don't have much of a slide deck, so bear with me. If I had a chance to retitle the session, I'd call it StarWind and Superheroes. Let me explain. I'm going to take a big rewind. We're going to go back to 2002. I was fresh out of college, and I had moved back home to chase a girl, of all things. I had no job prospects, and an opening just happened to come up at a company whose controller lived down the street from my parents. The controller and my mom were friends. They had the opening for an IT project coordinator. I didn't know what that really meant, nor what I would be doing, but I applied anyway. Somehow I got the job. Fast forward a couple of years, and this particular retailer is growing. I hear about this thing called VMware. I don't know what it was, but I installed GSX on an old box that was laying around. Thought it was pretty neat. I ended up installing ESX on bare metal and thought it was really neat. And eventually did vMotion, and I had what Amy Lewis would call or refer to as, and as many of you have stated, a software-defining moment. I knew this was really something special, software that I knew I was going to be using for a real long time. So let's fast forward a little bit more. I've been promoted to an IT director with staff, and the retailer is growing yet again. They had an ERP app that needed move off of dumb terminals to Win32. The new Win32 app didn't play with Citrix, and it wouldn't run on a terminal server. We need to deploy hundreds of new floor terminals, and I thought there was going to be a better way than physical desktops. Did a Google search. somehow stumbled on VDI and started reading the early blogs of people like Scott Lowe, Duncan Epping, Cormac Hogan, and Brian Madden. And I thought, wonder if someone's using this locally. So I did a Google search. I found the Western PA VMUG users group. I drove 2 hours from my home for the first meeting. I met guys like Eric Pond. I did my first presentation and eventually get asked to sit on the steering committee. I really enjoyed it. Then the financial crisis hit. And for a lot of different reasons, IT burnout that I didn't handle properly, being one of them, I left the retailer and switched career focuses. Let's skip several chapters ahead. I'm doing some virtualization work, not really happy with what I'm doing. I leave the company number 2 to work for a small manufacturer in central Pennsylvania to be their IT director. I want to get back into the virtualization space. So I start going to VMUG meetings again. And my first VMUG meeting in Pittsburgh, I sit down, and a gentleman by the name of Gabe Mentz comes over to me, who I've never met before, and he introduces himself. And he asks me, am I on Twitter, or do I blog? Never heard of Twitter at that point. Never had done any type of blogging, but it sparked my interest enough to keep me looking into it and to sign up for a Twitter account, which I encourage all of you to do if you don't have one to begin with. I went to the Pittsburgh UserCon that following year. I met Ariel Sanchez. Found more Twitter followers, found more relevant information. Then applied for VMUG leadership for Central Pennsylvania, after which I was awarded the expert status and found out about this particular event. Via that, I was able to have my pass for this event compensated. And because we were limited with funding in getting here, several VCDXs, which I thought was fairly incredible, reached out and even offered hotel rooms and to pay for my meals. The whole overall event has been incredible. On Sunday, I was introduced to Scott Lowe, who's multiple guys I've read and owned, and I met fellow VMUG leaders. Monday, I literally bumped into Duncan Epping. Tuesday, I worked the VMUG booth and talked about VMUG Advantage. I got to meet admins from all over the globe. I also got to meet and shake hands with Brian Madden. And then Wednesday, as I was leaving the Veeam booth, I just happened to literally back into the man that's responsible for the 486 architecture and has a large part of why we're all here today, Pat Gelsinger. So I started to understand why it was that Gabe and Ariel do what they do. And another fact, as I was leaving the show yesterday, I met a fellow admin that didn't know Twitter, didn't have that resource under his belt. So I sat down and I introduced him to what Twitter was. Got to have him sign up for an account and tweeted out a link just to introduce him like Gabe and Ariel had done for me. So what does all of this mean? So we're here today surrounded by people in the audience that may not necessarily even want to know about StarWind, but they're just here to support me and who I am. So if you're here about StarWind, I'd be happy to track directly with you at the conclusion of this talk and share my experience with the software package and anything that I could do to help you. If you're watching online and have StarWind questions, please contact me via email at starwindshutdown@gmail.com or on Twitter, again, at GSXESX. But let's go back to that meeting. The key takeaways that I've come up with out of this event, to make a bad quote from a great movie, is be excellent to one another. And then to quote Pat, is do a great job today and build the skills you want for the job tomorrow. And the focus of the event has always been, or excuse me, one of the VMUG themes this week was be a superhero. Well, in my opinion, superheroes certainly don't wear capes or have x-ray vision. They're the other everyday people all around us at every level that do the right thing when it's easier to choose the actions of the bad guy. Thank you.
Good afternoon. So I'm Michael Cade. I'm a global technologist at Veeam Software. What does that actually mean? So I get to, one, understand what our product is doing and have a say in the feedback that we get from the field and push that into our product management. We have a real good dotted line into that to give feedback into it. But I also get to look at what we have on the truck, what our product looks like, and get to play with cool stuff to make it do more. So that's why we got to do something pretty cool around Chef and automation. For those out here, did anyone come to our session on Monday or whenever Monday? Right, cool. So just to put that into, so that's recorded and that'll be available. But what we did there, we leveraged this cookbook, which we're going to go into a little bit more detail around, and we used that to build out a whole Veeam deployment within VMware and AWS. End-to-end, using AWS EC2 instances, our backup repository, also configuring jobs with vSphere tags and being able to complete the whole solution, and we did that in 45 minutes. And the one caveat that I have to say is, as much as we've got the word Chef and I'm going to go into the detail around what Chef is, I am no way a Chef expert at all. So there's a big shout out that I have to do here, is that the guy that helped me write the concept and idea that I had in my head was a guy called Jeremy Goodrum. And in true community spirit, I have to give him a huge shout out for what he's put together from a Chef cookbook point of view, writing the Ruby code, and also helping me with the Terraform scripts to be able to drive this. And still today, so this is 18 months we've been working around this and developing and adding different features and functionality to that. And still to this day, he has no idea what we do at Veeam, which I think is pretty cool, right? So what we're going to touch on, I'm going to really go through why we did this. I'm then going to go a bit about the basics of Chef. Is anyone, would you consider yourself a Chef expert out there? Okay, cool. We're all on the same level then. So we'll go through the basics of Chef. We're going to go through why configuration management, why desired state from a Veeam perspective. Then we're going to walk through, I've got some video demos that hopefully look good on the screen, and we can walk through actually getting that Chef cookbook and how we can get started. I think one of the things that we want to bring out of this is that just because Chef or Terraform or that whole ecosystem of configuration management, desired state configuration, etc., it sounds pretty scary for us infrastructure guys. It's not. It really isn't. It's a case of someone else has already done the work. It's about now pushing that and using that code to better suit your environment or your use case. Don't be scared of using it. So the why, and this is the same why that we used yesterday, and what we wanted to get out of it was really to be able to deploy that fully configured Veeam backup and replications environment using automation and orchestration. Veeam's not hard to deploy. It's 7 clicks, next, and that's it. It's really simple. But by doing it using infrastructure as code or configuration management, we've got the ability to be more flexible, be more dynamic. So we have the concept of proxies. By being able to deploy those out dynamically at the start and at the end of a job and remove them and destroy them, we obviously can be more dynamic around the flexibility of the components that we have. We're obviously going to do that by leveraging infrastructure as a code, and at the end of that we have this fully built out configuration management tool set that we have. So what was the driving use case around this? And it's really the second one down, so proof of concept. As an SE, when you go out and you install Veeam, it's not the Veeam installation that's the hard part or the tricky part. It's actually getting the customer to build out the environment so that we can install Veeam. So by leveraging automation, we can actually do all of that for the customer, and we can bring up a Windows box from a template, and we can get Veeam up and running in 28. The best I saw on VMware on AWS was 22 minutes. From no virtual machine at all, actually deploying and to be configured to start taking backups. So 22 minutes was the best time that I saw. So from a proof of concept, that's what we want to do. We want to get in there, we want to talk to the customer, and we want to be able to show what the capabilities that we have. And then selfishly, I break so much stuff in my home lab. It's a case of spin it up, spin it down. And so I wanted something that was easy enough to just spin it up, do what I need to do, break it. That's what happens normally. Throw it away, bring it back, be more composable around that, be more dynamic in that use case. But also from service providers, being those resources, those proxies that are lifting and shifting that data, they've got a cost associated to them. So by being able to spin them up, spin them down absolutely when they're needed, then we can make life easier from our Veeam service providers. And scalability. Who wants to be deploying 30, 40 proxies to look after 10,000 virtual machines? I'd rather just put in, I want 40 proxies, and then let something else go and deliver that for me. So before, as I've said about Veeam not being difficult to install or configure, but think about those larger environments and being more dynamic. That was the whole use case around why we did that. So that was pre us putting this chef cookbook together. So let's get into a bit of the componentry or the architecture that we see within Chef. So at the top there, we have the concept of a chef supermarket. This isn't a cooking course. If anyone thought this was going to be a trip like a Gordon Ramsay show and us looking at how we cook something, then yeah, we're in the wrong place. But a concept of a chef supermarket, and this is really where all the cookbooks, where all of those community-driven cookbooks live. And a cookbook consists of a recipe or several recipes to be able to go out and deliver whatever that desired state may be. And then we have our workstation, which ultimately could be our laptop, could be an actual server that we're using. And then we have the concept of a chef client. So the chef client gets installed onto whatever that desired state endpoint is. And then you have the chef server. Now the chef server is that central management that allows us to send and receive requests around where which cookbooks need to be used. And that chef server could be either hosted chef, from a SaaS play, if you will, and that will look after that node management or the chef clients that we're deploying, or it could be on premises. You just spin up a Windows or a Linux box and that runs the chef server, as well as an EC2 instance as well that could do that. So that's really the simple componentry and what that looks like. So what is that configuration management? And I want to get to the videos pretty quickly, but it's established set of rules. It's that desired state. So, for example, we've built out a Veeam backup and replication full standalone runbook or recipe that allows us to go and build that 100%. It's going to be all standalone. It's going to be the Veeam backup and management server. It's going to be the proxy, and it's going to be the repository, all in one. And that's where we get that 22 minutes from to be able to deploy that from start to finish. But then we have a proxy recipe as well. So if we just want to deploy additional proxies, we could go and do that as well. And we choose the recipe to what we want to cook. So I kind of touched on this as well, is that the chef integration in this instance allows us to go inside of the operating system, inside of that Windows box, and do that configuration management against the application. We use Terraform to deploy the infrastructure, and we use Chef to keep that in a lockstep or a desired state within that machine, depending on what recipe we've put to that machine. So what we've got so far, so if we go and look at these mandatory components that we have, I kind of touched on that all being an all-in-one, but they could be scalable and they could be distributed. So what we've got in our recipe today, or in our cookbook today, is the ability to deploy them in a granular fashion or as a whole. We may get it round to doing something around the other components that we have within the set. So just going back to this and how this is going to look as we run through the quick demos, is we're going to download that chef cookbook from the supermarket. We'll show you that chef cookbook. We're going to show you how we're going to send that cookbook to a chef client and deploy that virtual machine out using Terraform. And this is going to be a complete standalone build. And we're obviously not going to sit here for 22 minutes and wait for that to happen. The art of magic and video allows me to show you that. But then what we're going to do is we're going to deploy additional proxies on top of that. So we get to see this distributed environment, dynamic distributed environment. And I think the key message here is around, and it wouldn't be a community session without me putting a picture of a cat and mentioning cattle and not pets, but it's really taking away our backup infrastructure and taking the naming convention of your servers and treating them like pets to actually now let's be more dynamic about what we spin up and spin down and how we use that. So ultimately, and the last video allows us to really go out, and if we know that there's a backup window that we need to achieve, then we can go out and deploy these additional proxies and then destroy them once the backup or the replication job is completed. So when I start this, okay, so first of all, we're going to head over to the chef supermarket. This is all completely community driven. And completely available. What this is saying is there's thousands of cookbooks and different recipes for different application sets. If you go there and you grab if you search in Veeam, you're going to see what's available from a Veeam perspective. Here we've actually just updated this to 2.1.1, which we have a versioning control system that allows us to go and keep this up to date with additional recipes. One thing you'll see, that README gives a much better description to what I'm giving to it right now. It's very in depth. What we're also using, we're going to use the hosted chef. So this is where I'm just logging into this. The download starter kit is the chef DK. So this is what needs to go onto your laptop or whatever's running the cookbook. Again, very simple. It looks like a PowerShell window when we spin that up. It doesn't, it's ultimately that. The knife config is the ability to make sure that the hosted chef or the chef server can speak to that workstation, and it brings down that configuration so they can talk to each other. So we're going to generate that. We've already done that. So now we're going to jump back over to once we've downloaded it, we're going to jump back onto our workstation, and we're going to generate the repo that builds out a generic, like a standard chef config of folders, like basically examples of cookbooks, etc., to get things started. Then we're going to put our knife file in there. I need to kind of speed these up a bit. But so this is out of the box. This is what it looks like. So the example cookbook, etc. So you could start working on that straight away, and you use that as a template to go and start building your own recipes and cookbooks from here. But from our point of view, we've got our own cookbook. So, but what we need is that configuration file, that knife file, to be able to authenticate, if you will, with the hosted chef server. So we're gonna move that over into our chef directory, and yeah, I'm ahead of that. So we're going to copy that downloaded knife file over into here, and then once that, and then we're going to copy the authentication key, the private key, and then now we're ready to test that connection to the chef server. At this point, we've done nothing. This is literally just getting the chef environment up and running. You go and choose now which cookbook you'd like to download and start using. So you'll see in here we've got the generic default policies in there, and now we want to go and install that Veeam cookbook and bring that down to our workstation. So we've installed that. You just saw that, and now what we want to do is actually upload that Veeam cookbook to our hosted chef server. And that's going to do it for us, blah, blah, blah. Now, there's some additional steps that we need, and what we're going to do is the dependencies that rely on some of those chef cookbooks. So for our example, Burke's needs to be installed so that we can leverage that. But again, it's very simple. We need to upload that or install and upload that to our system. And now you're going to see that we've got the Veeam cookbook inside of our hosted chef. We also have the concept of a data bag. Data bags are really there to store the components that we need within our cookbook. So the analogy there is that we keep our license file in there, but you could keep your ISO files, you could keep configuration files, etc., that need to be there for the overall deployment. So the ISO files are there and they're linked, and we've also can go and get the license file. So you drop the license file. If you don't have a license file in that data bag, then from a Veeam point of view, we just install the free version. So you can still play around with it in your lab, and it will still allow you to protect virtual machines in there, but it will just be the free version. But there's still a lot of functionality in there. So that's really the 101 and where the Veeam cookbook looks like, where it is in the chef supermarket, and how to just get that up and running. Now what we're going to do is run through the installation of that and how we get that going. So we've got a Windows template. Everyone's got one in their VMware environment. This is all up to date. It's pretty standard. It's a vanilla. And what we do in our Terraform is we're going to reference that template in there. All of these Terraform are available on the GitHub site so that we can download all of this. This is free to anyone to go and play with. From here, we're going to point it to what we've got, a web server, but ultimately there are obviously the ISOs are available online from veeam.com, so we can download them. We've got the checksum that we need to check against, and you'll see later on how we can perform updates into that as well. So we're going to run Terraform plan to make sure that everything is in line and it's going to run as it should. And what this is going to do is going to go through and it's going to install these everything that we need from that cookbook or from that recipe. So we're happy with that. So let's run that Terraform apply, and that's going to run through, and it's going to start to build that custom spec out that we want. So with that is that if we jump back over to that again, video magic allows us to fast forward this, but you'll see now that we've got this Veeam virtual machine, and it's going to just deploy that template, and it's now going to start running through the code and start connecting over WinRM. It's then going to start the deployment of the Veeam components within that all-in-one machine. So if we log into that virtual machine now, we're going to see that it's a very vanilla machine. You see no icons. There is no Veeam installed on this server, but let's just jump into the add remove programs just to be sure. And you'll see, okay, we don't have anything. We have our VMware tools. We have basically how we left that template. But if we fast forward, so what we're doing here is we've connected over WinRM. We're going to then start to do the chef client installation that we need on there. We're going to then take that cookbook and we're going to download and deploy that within that chef client. And then we're going to start running through that installation process. So next, when we jump back into, so what we've also done here is the ability to download the latest ISO as well. So that web server that I had hosts that ISO for Veeam. Or you could ultimately put that inside of maybe your template, and then you don't have to wait for that to be downloaded. We're going to install all of the Veeam prerequisites as well. So we're going to install the SQL Express for fast reasons, but there's no reason why we couldn't add another step to go to a fully blown out SQL. You saw there that's the add remove programs. You're starting to see things getting populated in there. We're then going to go out and deploy the catalog service within that whole standalone setup. And then the bulk of it is around that Veeam server. So being able to go out there and deploy that. So you see that at 12 minutes, we've already started that well and truly down the line of getting Veeam backup and replication up and running. So again, we're going to run through that, and you see, so install the backup server. That's now finished, and then we get down to the console so that we can actually dive into the Veeam backup and replication management server. We're also going to do the Veeam Explorers. Again, what we could do is we could deploy the catalog on one server, we could deploy the Explorers on another server, the management console on another server. But now, if we dive into that machine again, you'll see that this is just a very standard build of Veeam along with our license. Also notice that 95.0.711. So that's 9.5 update 0 or update 1. I can't remember which one. But that's end to end. That's now Veeam installed, and we could literally point that to our vCenter server and start protecting virtual machines. And you can see what we've done here. It gives you the IP address. Again, because this is a lab, we're just using DHCP that deploys out so you could ultimately start running and protecting those workloads. So another thing that we've added in here is the ability to upgrade Veeam as well. So you saw those lists of ISOs that we put into the README. So we just did this last week. The update 3A came out a month or so ago, and we actually just added in the URL and the checksum, and then we're able to coordinate those updates as part of the whole Chef package. So think about that, is that we can manage that configuration constantly from a Veeam update point of view. So being able to go forward in terms of updates or roll back if anything was to not work. So this is where we're going to go into the no, go back. Now, have I broken it? So with that in mind, so again, I said about that 7.11, you can see that it's all updated, but you'll see that we also flagged that there's missing updates within that system because we know that there's a new update from a Veeam perspective. So if we go back to that, our Terraform script, you see that now we've added this update URL and an update checksum. Our updates are available in a zip file so that we can just inject them into the environment. So now that we've just added that line of code into our Terraform script, we'll then go and check the configuration again against that Veeam server. We'll see that there's an update available. We've just run again a Terraform apply on that. And this is now going to go through, it's going to unzip that update file, and it's going to then start that upgrade process. But we don't really need to sit through all of that. And then it just keeps it in that lockstep, that desired state And again, you'll see that the build number, this is what we're going to do. We're going to go and install build number 1536, which at the time was update 3, but now we're on another build number. I'm not as geeky to remember our build numbers off the top of my head. So that's going to take the time it takes normally to update that software. But we don't really need to sit and watch that. We don't need to click next. We can just let that play itself out. And when we come back from our coffee, we can go back and we can see that we're already updated, and we're simply changing the way we look at updating the Veeam component servers, and we're treating them more like cattle than like our little pets. So now this is the bit that really is the icing on the cake for what we do here, and that's about being able to dynamically add and destroy those Veeam proxies. So our proxies are the muscle that moves the data from A to B, wherever that needs to be. So we're going to take that virtual machine, we're going to take the backup, and we need to put it somewhere. A proxy moves that data. So here, again, we're defining our default username and password for both the VBR server. And what we can do also within the Chef Cookbook, or within the proxy recipe, is actually build out a proxy template. So we're already going to pre-stage the Windows template that we took. We're going to get it to a state with the transport service and dependencies already installed, and then we're going to take a snapshot of that basically, and we're going to have a new template there called Veeam Proxy. So if we then run Terraform apply and we say, I want to put X amount of proxies, I don't know if you saw that, but I put 2 extra proxies. And we're going to call that proxy 01 and proxy 02. That's going to go out and it's going to build them concurrently. So if that VBR server took 25 minutes to build out, then, and we've already pre-staged the majority of the work in these proxies, they generally take, I think it's around 8 to 10 minutes to actually bring them up. So we define that proxy count, we can literally say 10, 20, and it will go and deploy them out for us. And you'll see concurrently as well. So it's also going to check the VBR server and again make sure that the configuration's in play, because what we need, once we've built those proxies, we need to add them into our VBR server. And what they'll also do is connect into the hosted Chef, and we'll keep an eye on that from a Chef point of view to make sure that the configuration doesn't drift or slip, so that and that's really the whole point of that, is that we don't want any of our proxies to fall out of sync with our environment. So let's fast forward, and we should jump back over into VBR, and you're going to start to see now these proxies being deployed and added into VBR. So there's our first one, and before too long you're going to have the second one appear in there. Yeah, so the recipes for each individual one is in there, and the Terraform is on a separate GitHub page as well, but I've got a link. So yeah, that's going to go in. You've seen that it's registered. It's going to install any other dependencies that we've included in that recipe, register it to the Veeam backup and replication server. So now we've got a VBR server plus 2 additional proxies to be able to scale out our backup requirements. You see, I think it takes about, I think I mentioned 8 to 10 minutes, but we've actually got that quicker. But it also depends on your environment as well. But there we go. So 11 minutes and 21 seconds. It also gives this output here so that we can see, and you may want to feed them that information into something else like a JSON file, which we did in our session yesterday, because we're calling different scripts for different functionality. But now you get to see that we've got a fully scaled out, a dynamic deployment of Veeam in what, 25 to 30 minutes. But let's say that we've just finished that backup job and we want to get rid of one of those proxies. So what we're going to do, if you saw that I did a Terraform apply var proxy underscore count equals 1, that means we're going to go and destroy one of those proxies that we just did, because we don't need it anymore, because we've finished our workload, and let's get rid. So again, just quickly running through this. Since we set it to 1, that's going to destroy. It's a lot faster to destroy something than to build it. But if we head back into here, you should see it disappear like that. And then we're there if we need that proxy. But again, we could say proxy 0, so it will just remove that one. We'll always have the Veeam backup and replication server as a configured proxy. Yeah, and make sure that that's in good shape. And then when that job comes around again, we can go, okay, proxy underscore count 2 again. You see there, all in there. So, and that works the same way. So if we want then to scale up and scale out to 5, then we just change that proxy underscore count to whatever number suits and deals with that, the workload that we need to protect. And this can be put into a PowerShell script that we then bolt onto the backup job as a pre-script or a post-script. So we can then say, okay, we know that our backup jobs are going to start at 5 o'clock, or they're going to start every hour. Okay, so at 10 to the hour or 12 minutes to the hour, we're going to say, okay, deploy 10 proxies. And then as soon as that job's finished, let's get rid of them. So think about that from a service provider or from a large-scale environment, is that we could spin up, spin down, rather than leaving them there all day, every day, just consuming your CPU, your memory, and storage on your in your environment. We could actually just be more dynamic about that deployment. So if you just saw there, I'll just head back because I was talking over it. But you can see there that we've just gone proxy count 5, and it's gone out there and it's deployed an additional 4 to the one that we already had there. So just to wrap things up, so this is completely community. It's not an official Veeam thing. So Everything's available either on the Chef Supermarket or within GitHub. The links are, there's a link on the Chef Supermarket that gets you to the GitHub. It will also be in the Veeam Hub GitHub account. So yeah, the more input and the power means that we can do more with this. So as much feedback as we can get allows us to drive different areas. That the whole proxy count was new, and then we've just done the whole proxy template thing. All of that is just evolving as we move forward. So again, the big thing that I want to emphasize is, one, if you haven't already, look up Terraform and see what the power of that is. And two, don't be afraid of things like the Chef, the Terraform. It's going to be the way that us infrastructure guys are definitely going forward from an automation point of view and orchestration. All you need is listed there. This will be available afterwards as well. With that, thank you very much.
All right, so welcome everybody. Thanks for coming out. There's lots of people in the seats. It's great to see for the vBrownBag stage. My name is Mike Preston. I'm a technical marketing engineer with Rubrik. Been there for about 4 months now, and prior to that I spent 12 years as a customer. So hopefully that kind of helps me relate to some of the challenges from IT operations and different things like that. Today, I kind of want to talk to you guys about Rubrik's amazing UI. Right? It's a really nice, clean interface, and hopefully, by the time I'm done, I can convince a few of you guys not to use it, if that makes any sense. So let's just jump right in. And this is sort of my way around not being able to do a demo, but there's going to be lots of crazy GIFs and things going up. This is Rubrik's UI, right? So it's a very intuitive, responsive, clean UI built off of HTML5. As you can see, there's not a lot of nerd knobs, right? Simplicity was really a key design center that we had when our founders took a look at the data protection landscape. They really looked at it and said, we have proxies and repositories and catalogs and all of these things, and it's really complex, right? Complex to set up, complex to maintain, complex to scale. So really what they did when they founded Rubrik was take all that complexity, all of those parts, the proxies, repositories, and converge it into software, right? A software fabric, a scale-out software fabric that runs, on-prem with our Brick appliance. It's a hyper-converged appliance. You can also run it as a virtual appliance or also in the cloud as well. The point is you get the same sort of look and feel no matter where it runs. You get this beautiful HTML5 UI. But this UI, is built on top of an even more powerful API layer, right? So you're going to see developer mode open up in Chrome here. And what I'm showing is, every single click, every single function, every single thing that you're doing within that Rubrik UI is simply just calling an API backend, right? And that API backend it's an open API spec, and it's available to everyone, right? So you can develop and script and do things around Rubrik. Which leads me to this, right? Why would we do something like this? So this is creating what we call an SLA domain, and that's really our data protection policy. And what that is it contains really 4 things. An RPO, right? How often you want to back up. Retention, how long you want to keep this stuff for. Archive, maybe after 30 days you want to ship that data off to, cheaper and deeper storage, whether that be, Amazon S3, Google Cloud, Azure, or on-prem NFS. Right? And we also have a replication policy as well to handle things like DR. But the point is, why do we want to do something like this in the UI when we can do this, right? Since we do have that open API spec, we see a lot of development occurring, right? And one of them is our PowerShell module that we offer. And basically, you can do exactly the same thing, plug in those 8 numbers for your RPO and the archive and whatnot, with a little bit of PowerShell. So just for a couple more examples, right? The next step when you get Rubrik would really be to create those SLA policies and then assign a VM to that policy, right? Or assign what you want to back up to that policy. So you could be Sad Panda and you could go through and do it in the UI, that's okay. Or you could be Crazy Unicorn Panda here and you could just, one line of PowerShell and achieve the same thing. Second example, performing what we call a Rubrik live mount. This is the quickest way, along with instant recovery, to get back up and running with Rubrik. right? And what this does is essentially, rather than provision storage and copy the data from the Rubrik appliance back to your vSphere environment, what happens is the Rubrik appliance becomes an NFS data store, and your VMs get mounted and turned on right directly from the Rubrik appliance, right? So essentially you can recover, as fast as it takes for that VM to boot. But again, why be sad Panda and do this through the UI, when you can be dabbing Panda and do it through PowerShell as well. And these examples are small, right? I get it. It's probably not something you're going to automate, like doing a recovery. It doesn't really make sense. You're probably going to go into the UI to do that. But why I'm really showing this is because, as you start to look at all the corners of the data center and integrate different things, with Rubrik technology, you can really come up with a few, unique use cases, right? And here's number one. As a customer, I looked after a lot of SQL databases, right? So I did a lot of DBCC check DBs, right? And we all know that they're a little I/O intensive on the storage as well as the SQL server. So why not, integrate Rubrik live mount functionality, and integrate, the PowerShell for SQL Server and kind of combine these two together. Right, and this is just a bunch of code. It's nothing really special, but it's basically just grabbing, a backup of a SQL database, live mounting it to a SQL server, and then spawning off that health check on that live mount. So all of a sudden, all that storage I/O isn't being processed on your production database, but you're actually processing that on, the Rubrik appliance instead. So use case number two, VM provisioning. Right, and I was a vSphere administrator as well as a SQL administrator. It's kind of the jack of all trades type position. But this scenario came up more than once where someone would come up to me and say, hey, I really need you to restore VM2. And I'm like, I never even heard of VM2, right? Like people create these VMs, they don't really tell us about them, right? So why not build, that protection right into your provisioning process, right? And this just simply goes up and creates a new VM with the Power CLI modules and then calls off on the APIs to Rubrik to add it to an SLA. Now you can see that around line 20 there's an invoke web request, and that's just because we don't have the ability yet to refresh vCenter with the Rubrik PowerShell module. But we can just make those raw API calls out to the Rubrik APIs. So what if PowerShell's not your thing, right? Maybe we all don't really love PowerShell, right? The thing is, the APIs, they're wide open, right? So you use whatever you want. Most scripting tools now are going to support, connecting into a RESTful API and consuming that. So go ahead and use C# or Python or curl, whatever it is you guys want to use, whatever existing tools you have, go ahead and get that Rubrik integration with that. Or better yet, use some of our supported stuff that we already have built, right? If you're a ServiceNow customer, we pipe all that Rubrik functionality into ServiceNow. We also have a VRO package. So if you like vRealize Orchestrator like me, you can install that and build that VM provisioning workflow, pipe that up to vRealize Automation if you want to, put that in your self-service catalog and go from there. As well as we have, an amazing team of rangers and engineers that have, a lot of different code on GitHub for things like Ansible and Chef and SaltStack and all of this crazy stuff that's out right now for infrastructure as code and things like that. So go ahead and utilize that. And so you might say, how do I get started, right? And I've been consuming APIs for a little while now, and honestly, step one, read the documentation. That's the hardest step. It's hard to find the documentation, right? I've done a lot of work with Google APIs, and there's different versions and different things like that. You're on different websites, and they're saying this is depreciated. The Rubrik documentation, it comes right on the appliance. It's built right into the software. So as you get updates and different things like that, move to different versions, the documentation also gets updated. So if you just go to /docs/v1 on the Rubrik appliance, you'll get all this documentation. It is very, very concise and very, very thorough. If you spend a half an hour reading the introduction section and taking a look at some of the resources, you should be well on your way. There's lots of sample code and different things like that. But if that's not enough, go ahead and practice. We also have a playground where you can get in and you can actually start executing API calls against your production environment, your production Rubrik environment. And this is really, really handy if you're like me and you kind of wake up in the middle of the night in a cold sweat, like dreaming about JSON and squiggly brackets and all this crazy stuff because a lot of times it's hard to form the actual JSON you need, and this will allow you to actually execute those API calls, see what the body request is going to look like, see what your response request is going to look like, and copy and paste that into the scripts that you have. So at the end of the day, really the choice is yours. Go ahead and use our world-class UI. It's a great UI. It's fun to click around in it and do different things like that. But take advantage of the open APIs that we offer, because we have some customers that honestly I'm not even sure if they've logged into the UI. There's some case studies on our website where they've just basically purchased Rubrik to integrate into their already provisioning processes, and it's a great tool. It's great to have that, and it's great to be able to integrate that into what you already have. So with that, that's all I have for today. So thank you. Is there questions? We've got time for questions, I think.
This year, and VMware vSAN came in this year as one of those presenting sponsors. So I want to introduce Ken to everybody and give him a couple minutes to kind of talk about their product, and at the end we'll congratulate and thank them for their support. So go ahead, Ken.
Yeah, it's actually just a real pleasure to be able to offer that sponsorship to the community. I think that this is such a phenomenal event where we get that opportunity to mix and mingle and talk with other peers. And I think particularly, I am going to plummet off of this podium here, I guarantee it. It's fantastic for us to have that opportunity, particularly the products like vSAN coming along. We don't often get that opportunity to talk to customers. These are new and emerging technologies, so having experts within the industry being able to do this sort of communication with each other is just a fantastic opportunity. So thank you for that. So I am Ken Werneberg. I manage the technical marketing group for our storage and availability business unit. And really, we have these few chances to be able to get other people within the industry to take that time to work with each other. vSAN is in a state that reminds me of vSphere probably 12 years ago when I joined VMware. At the time, it was taking off. vSphere was, well, it didn't exist at the time. ESX was doing really well, and GSX was starting to sunset. But the growth of those platforms at that time had nothing really to do with corporate directions. It's not like we sat there and took CIOs out for timeshares and gave them cigars and things like that. It was the community that was using ESXi that said, this product set is fantastic, we need to do more of this. And it was really a groundswell sort of an approach to get those technologies going. vSAN's in the same spot today. We've got 15,000 customers, and that's fantastic. It's a huge growth that we're experiencing, but it's still a very young product set. This is something that's 5 years old. We've only had a very few real iterations on this. It's version 6.7 today, but it's not something that has been around for 30 years like the rest of the storage industry has. So it's really the community at this point that is driving the charge of that product set. And 15,000 may sound like a lot, but even if every one of those customers was here at VMworld, there's still 10,000 people that have never seen it before in their lives. But we have people like AJ, who was on the first panel up there. He's running vSAN. He lives it day and night. So it's a very important opportunity to be able to talk to people that have those experiences. So back to the point, I appreciate the ability to offer the sponsorship for this event because we get those opportunities to talk with people. And I think it's even more important, one of the comments that was made in the last panel session here was that we see a change in roles, that people's roles are shifting in IT, particularly in the cloud space. We're breaking down the silos between the different technology stacks. And I would say that that's the same on-premises in your own data center or in a cloud model or anything. Cloud is really more of an operational thing. It's a model of doing IT. And when we start looking at things like hyperconvergence, we're pulling in network, compute, and storage. So my point is that the traditional vSphere administrator in the future is not going to be a vSphere administrator. He's going to be an SDDC administrator. We're not going to have a network admin and what she knows is the network stack. She's going to have to know everything about all these technologies because this new cloud operational model requires a different skill set than it required when we were managing things just in a traditional legacy sort of a fashion. With hyperconvergence, that blurring is even more, it's a stronger blurring, if that makes any sense, because those roles are no longer fundamentally separate. We're talking about a single stack of technology that anybody who's interacting with it needs to be able to manage. So these opportunities like OpenAX, like VM Underground, these opportunities to communicate with other people who have these skill sets, to be able to push yourself a little bit beyond your comfort zone is very, very important, because in the future, that's what we're all going to be doing. We're not going to be vSphere administrators. We're not going to be storage administrators. We're going to be cloud operators. And I think that's a very important skill set to be able to get from the people at these events. So once more, thank you very much for the opportunity. I really appreciate the chance to help out this sort of very important community event, and I appreciate it. Take care.
Stay right at the podium. Thank you very much for coming here today. I really appreciate it. And my topic is pretty obvious. We've got so many words in my topic that I think Alistair ran out of space, so that little W hanging out at the end, that's a with. All right, in case you were kind of wondering. All right, now that we got past the acronyms, I'm going to try to explain those acronyms, including, I brought props, which is a little unusual for a talk like this. But I want to really drive home. If you remember nothing else from this presentation today, hopefully you'll have some idea what those acronyms mean. All right? Even better, bottom right corner. Take a close look there. You don't need to wait for this to be online, or if you want to look at it moments after I speak, it's all right there. Bit.ly, so bit.ly, whoops, can't roam too much, right? / NVMe on ESXi. It's that simple. It's the only URL you'll need. I imagine it'll go somewhere else at some point, but it's already published. So everything you're seeing here today is right there, including all the links. So that way you can look up at me rather than worrying about writing or taking any pictures. Awesome. You already saw the contact catalog, and actually, here's my screenshot. Yep, okay. You've already read this because you registered and you showed up. So I'm going to skip right past it, but basically the last sentence I do want to highlight. SATA and SAS and 3.5-inch spinning drives are becoming a bit of a thing of the past as we move forward with NVMe. That's been the big acronym, and I'm going to explain a little bit more about NVMe and what makes it faster, better, and a little more expensive, but not as ridiculously expensive as it was 3 years ago when I first started blogging about it. Thank you, Alistair, for getting me here. And Alistair did a recent event, build day, by the way. So this green link under his name, if you click on it, you'll get all kinds of information. For instance, if you're into different servers. This particular server I'm familiar with for part of my day job doing some vSAN work. Okay, so there's a little bit more about me. You're learning more than I've put anywhere on my website in the last 7 years. This gets a little bit personal, but I figure it might connect with someone in the audience who else started with a Commodore product. There we go. There's always around that proportion of every crowd I go to. That's 3 people in this group. That's awesome. Now, I didn't have the money, and I was also earlier than the Commodore 64. So I don't know what you guys had, but that's where it started. And actually, the Atari, that didn't really count, but that had a basic program. What I want to get at with this screen is really bullet 3, playing with Flight Simulator, okay, or writing batch files. I had really small hard drives, 20 meg spinning hard drive at that point, right? So it's like, how do you jam a bunch of games in here? There's no room. Oh, well, WinZip them, write a batch file, extract it to a RAM disk, run the game from there nice and fast. That kind of began my early 20-year-old something tinkering, speeding, actually, yeah, not even still a late teenager then. That led to bullet 4, doing more work with speeding up the Silicon Graphics server I was working on and having more interest in that in a career in IT rather than getting a PhD. Then finally, bullet 5, IBM contractor, so I was at IBM 22 years. And I've only been at VMware about 18, 19 months or so now. Okay? So that background just kind of shows you all of us have a totally different path. Probably none of us in the room, it looks anything like each other. And that's okay. The common thread here is the storage. What do I do with, here we go, the 90s. Raising my family, my kids. Videos, how do you save all that? Do you use a NAS? Do you use a RAID adapter? Is it bad when you use the RAID adapter that's built in the motherboard and it takes a weekend to rebuild if something goes blip? That was a journey that began for me like 12 years ago as an IBMer doing server installs at work, but kind of tinkering with this stuff at night. And that finally became a bigger part of my career. I was doing more and more storage the last 8 or 9 years or so. Let's move into the actual storage stack. There you go. I told you I brought pops, and I've gotten right into the acronym. So SATA you're used to for a long time. Think how long that's been on motherboards. IDE before it, but SATA pretty darn common for way over a decade, but not all that speedy, 540 megabytes per second. I'm going to cover speeds and feeds and all that shortly. But this is just a picture I just took 4 hours before my flight, and The one on the top is what you're used to. And this is the very first consumer Intel X25M SATA-based SSD. My second one, it was $800. I bricked the first one in 2 weeks of putting VMware Workstation on there and banging away with VMs. And I bricked it because too many writes. Anyone with me in the early days of SSDs? That's how it was. It was rough, and that was meant for consumer use, not cloning VMs like crazy until you bricked it in 2 weeks. All right. The middle there, that's where things get interesting. So we move into NVMe, and it has multiple form factors. I can hand some of this stuff around the room too, for those of you who want to see it. And yesterday I had a demo out there where I had the hardware out all afternoon. So I may have met some of you already. All right, I should use the clicker. This screen I like. Let's sit on that for just a moment. First of all, I've defined NVMe. What is it? Non-volatile memory express. Great, you got that acronym knocked off. What does that mean? A protocol built for flash from the beginning. It was never meant for rotating media. Okay, fine. What's the purple goo? The purple stuff there is controller latency. So SAS and SATA controllers all incur quite a penalty on performance. You need to buy an HBA in your server in your data center at work, or at home you have probably not a SAS drive, but more likely a SATA drive. That has an overhead. This graph just tries to show you NVMe is a bit of a game changer when it comes to that overhead. And you now have each NVMe device. Here's 4 of them on a board. Each of these shows up as a individual RAID controller of one drive, one NVMe device. I got a screenshot of that coming up. But if you remember nothing else about the screen, it's just, yeah, it's faster. And here's why. It was written with flash storage in mind at the beginning. Booting from it was a little tricky. I wrote an article about that in the week the Samsung 950 Pro came out. And I was the only thing on Google who had been crazy enough to put VMware and VMFS on there and throw VMs and realize, oh my gosh, this is 5 or 6 times faster than anything I've done for the last decade. I was pretty excited and started blogging about it like crazy. Here we go. There's the speeds. You're not going to remember this eye chart. That's okay. But SATA 3 architecturally is limited to 6 gigabit. SAS, okay, we went to 12. Some of you that had newer servers in the last few years, you might have 12 in your SAS. That'll help your rebuild times a little bit. Still, 1550 megabytes per second, not as amazing as the ridiculous numbers you're seeing in the bottom left. So I tried to pick a representative sample of more home lab focused stuff. So yes, I'm here right now wearing this shirt because I'm here as a blogger and an IT pro, and I've been doing user event presentations for about 7 years, long before I was a VMware employee. But my day job also has me dealing with storage all day long, talking to customers about HP, Dell, Supermicro, Lenovo, whatever brand they already have. I'm talking to them about ready nodes and how to size it and what kind of HBAs to put in there and what drive speeds and interfaces. So there's definitely been a crossover lately on my blogging and my day job. The bottom left corner, it is more expensive stuff. To get to 3,500 megabytes per second and 2,500 megabytes per second writes, that's a key thing there, right? That easily things like this can handle, and the endurance problems are basically gone with Optane. Yeah, you're looking at probably double the cost per gigabyte. And when you put it in the data center, they jack the price up even more. So it's weird. 2013, MacBooks had NVMe in there. You didn't even know it. It wasn't even M.2 standardized spec then on the interface, but it was NVMe. You had NVMe for many years. It's been in a lot of your laptops probably already. You might not know it. And the price is reasonable there. But when you bang away at writing at it all day like you do in a data center with caching writes, that's where something like Optane, where something dramatically different comes in. We'll get into that. And it's getting more affordable even for a home lab to get something like this. So you can see Intel marketing this for Star Citizen gaming. Okay, maybe a slightly faster start time for a game, but more interesting is sticking VMFS on something like this and letting your VMs really fly and bang away at it and not worry about your SQL database run you might want to do for a week or whatever. You're not going to hurt it, all right? So that's PCIe. Examples, we talked about SATA, on the top. SAS, kind of funny, they blurred out the label. They don't want you to see the warranty or make a read the serial number, but that's a Dell part there that I happen to be showing. And finally, typically that's sold in a drive carrier with a little handle on the front, proprietary for Dell versus HP versus Supermicro versus anyone else. You guys are used to that in the data center. Bottom right corner, you're not as used to in the data center. More consumery for M.2. Or home labs like the ZND I was showing, where you have a spot on the motherboard to put in M.2, way faster than anything you're going to put on the SATA bus, right? And queue depth is key. I'm talking fast, and I'm giving you too much that you'll possibly remember, but queue depth is a large part of the reason that SATA basically sucks for VMs. It's not great when you run it on a laptop that's older SATA drive, SSD or not. You run VMware Workstation, you try to boot 2 or 3 VMs at once, it's pretty painful. You put NVMe in there, whether it's M.2, U.2, or PCIe, doesn't matter. The speed is fantastic, and it's the same on all 3 of those. And it's the same driver and the same tools in ESX CLI, and same way it looks in the GUI. So there's not much to learn on the vSphere side. I'm trying to just kind of get you up to speed on what's going on the hardware side. So bottom left is showing you the recent drive, the Samsung 960 EVO. 2 terabyte is kind of the darling with the high ratings in Amazon that most people can sort of afford. Still 6, 7, I got to look at the current pricing, but it's up there. But that's a whole lot you can do with 2 terabytes of VMS. Obviously, you can go down to 512 or smaller size for more affordability. Let's move along to, oh, there we go, clicker. All right, what the heck is M.3? I'm going to just say it's a pudgier M.2. So M.2 I already held up, 4 of them here, gum sticks, you heard them referred to. M.3, little wider. You wouldn't fit 4 in here, you'd fit about 3. I don't have a sample of that. There are adapters starting to ship to handle getting an M.3 on a motherboard that wasn't designed for it, like a stand-up where you just put in a PCI slot. In case you weren't aware of this, there's longer M.2. So that's called 22.110. 110 being the number of millimeters. 2280 is the consumer stuff, much more common. Okay? Supercapacitors here in yellow, that tends to mean, oh, enterprise. I don't mind if you yank the power cord out, I'm not going to corrupt anything. You're not going to find that in a consumer drive, generally. And then finally, M.2 is skinny and tiny and like laptop style. You turn around the back, all it is dumb wire traces in this under $20 card. There's no speed decrement by putting your M.2 in some sort of adapter to get in your 6-year-old motherboard of a Core i7 you have running in your basement or something. So just pointing out these little things that trip people up and about NVMe. Booting from it, you need to turn on UEFI. So if you're thinking, oh, I do have a 7-year-old machine like in my home, like Paul just said, yeah, it's not going to have a UEFI BIOS most likely, or your operating system wasn't installed with it on. You're not going to be getting Windows or ESXi in UEFI mode installed on that old system. If you want to boot from NVMe, you need a more recent vintage system. But if you just want to drive letter D on Windows, sure, stick a PCI card in your old system and you'll have incredible storage speeds, no matter what OS you have on there. Whoops, I breezed right over Ruler. Any of you see the Intel booth out in the Solution Center? That's a third of the people here, yeah. And you might have seen it last year, same hands. I saw it last year, it was the same one, only, okay. So it got your attention this year because they had it right in the front when you walked in the solutions area. So petabyte and 1U, that's interesting, right? And it's all about heat and thermal dissipation. This lovely article, whoa, the top's cut off, but all right. This lovely article in the bottom right, actually in the bottom left, you'll see tinkertry.com/ruler. You can read all about it. Intel did a nice job with pictures of pretty much everything I'm presenting today, right? The form factors, what they look like, advantages and disadvantages. Great. Do you remember I told you NVMe looks like a storage controller, an adapter. So I'm on the adapters page of ESXi. I'm going to stop right there. Little pop quiz. Who knows what interface I'm looking at? What do you call this client GUI we're looking at here? I gave you a hint already. It's got ESXi in the name. Close? Someone raise their hand and say it loud. They used to call, let's see, ESXi host client with the full name, so sure. There you go. This won't hurt you. It's foam. Doesn't weigh down your airplane. All right. See, he asked a question. Those are always good. Or he answered a question. At the end, I'll have a few more little foam houses to give away. All right. NVMe SSD controller. It shows the drive. So what's that? That's an SM961. Oh, that's an OEM drive. Shoot. When you end up with one of those from eBay or whatever, you probably can't flash the firmware on it. So it got pulled out of a Dell laptop or something where you weren't meant to be monkey with it. Just pointing that out. So consumer drives, off the shelf, Optane, like this, a consumer packaging. This is tiny, only 32 gig. Yeah, there's tools for it. They're consumer. They're like Intel's consumer executable to run and look at its firmware and all that. Gets a little tricky when you put consumer stuff in enterprise products like VMware's vSphere ESXi 6.5 or 6.7. It'll look like this from this page, but when you get to the command line, a little different. And then installing VIBs we'll talk about a little bit too. Do you have a question? Okay. All right, so enough of that. That's what it looks like. And that's unique. You're not used to that. You'll see AHCI in the top, but all my 6 SATA drives are attached to that controller there. You don't see each drive enumerated. It's unique for NVMe. Like if I put this in, you'd see this 4 times, each of them enumerated separately. Why is that important? Any of you ever used pass-through at work or in a home lab? There's one head nodding. VTD is one of the acronyms. VM Direct Path is another. Pass-through is another. I've used it. Only one other person. All right. A third of the crowd have used it. Can one of you just tell us what did you use it for? GPU. There you go. Also, hard drive pass-through. So SATA probably. Yeah. So now NVMe, same deal. You can pass through an NVMe. In fact, you can pass each individually through. Why is that cool? Well, what if you had 4 copies of ESXi running nested, like a William Lamb lab or a Alistair Cook automated lab? You stand up 4 nested copies. Each one you can pass through NVMe SSDs to. Pretty much full speed. They just see it as if, oh, I can VMFS format it, or if I can use it for a test vSAN proof of concept. So you have 2 of these, now you have a caching drive and capacity drive times 8. 4 ESXi hosts, each getting 2 drives. That's called the drive group. So it's a quick little diversion into vSAN, but yeah, it's exciting that NVMe lets you pass through like that. Any motherboard, if VMware's product sees it in the host client, the ESXi host client, you're good to go. You're likely to be able to just go to the hardware page and pass it through to VMs or do stuff like you do with GPUs and SATA drives. Yes, U.2 is not bad. This is fun. I was looking for how tall is the U.2 drive, preparing for my presentation today. And this is what Google gave me. How tall is U.2? I should have put U.2 in the quotes. So when you search for U.2, little tip, put it in quotes and you'll do better on the Googles. There you go. 3D Crosspoint. How many of you have heard of that? I won't say anything else till half of you. Great. I didn't go bothering with a nerdy technical description, but basically we've been using NAND since the days of this X25M, which is right around a decade ago when I first bought this. That's a long time we've been on NAND-based SSD solutions at work and at home, didn't matter. 3D Crosspoint is completely different, the way it works, down to how it lays down the bits in the media. And there's some little things like you could fill it to 100%. It doesn't mind. It doesn't get slower when you're at 99% or 98%. Do that to a regular SSD or HDD, not so awesome to do to any drive. There's lots of little things and a whole lot more write endurance we talked about earlier. So Optane just happens to be when they brand it and put it in a box that they can ship to you, Intel calls it Optane. But Micron and Intel developed 3D Crosspoint, the technology that's powering those. All right. So acronym soup, or names, more words to define. 512E, all right, it's probably what your HDD probably is, and it's widely compatible, including some 8 terabyte drives. Now you start getting into 10 terabyte drives, bottom left corner, things get interesting. So for daily backups, Veeam, Nikivo, Bamboo, whatever you guys use, home lab or work, whatever, big drive, right? Going to be slower, especially if it's on SATA. My God, rebuilding 10 terabytes of data takes a really long time over a SATA interface. But anyhow, if you go on Amazon and you just search for like a HGST helium drive, HE10 it's called, helium filled instead of air, cool. You get the drive and you look at the part number and it says, sure, 10 terabytes, and if it's 512E, it's gonna work on anything. Any old operating system you slap in there, including 6.5, fine. But if they accidentally ship you a 4KN like they did with me about a month ago, I got an experiment where I immediately requested return authorization, make sure I can return it until September 10th. And then I went to town on it, realizing that, yeah, they shipped me the wrong product. They pretended it was a 512E. No, 4KN is a different animal. It looked the same, one little digit different in the part number. Amazon just messed up the listing and the partner needs to, return my money. But anyhow, the point there is, it just came out in 6.7. Any of you running 6.7 in a lab or at work or anywhere, you got only 3 hands and myself, 4 or 5 of us, okay. New capability, those same people that just raised their hands. Were any of you aware of this thing about 4KN? And that's a new feature that was just announced in 6.7. There's one head nodding. Okay, 3 people, that's cool. So you have some awareness of that. So yeah, this green underline, awesome article. Jason Masai, guy from Micron, works at VMware now. Really deep dive, he gets into all this. So in 6.7, It was our first step to get 4K and drive supported. I'll say I'm working on looking at the performance right now, but it definitely performs differently than the 512Es I've been used to. And again, the reason you might buy a drive that big is they're under $400 for 10 terabytes these days. So a great way to back up your entire home lab and whatever the heck else you got, videos and whatnot, right? Not your primary data store for VMFS, but for backups of VMs and physical machines, awesome. All right. So ESXi boot devices. I bet a lot of you guys have thought about this at work quite a bit. Yeah, USB. Well, we all know what those look like, including the one I just brought to Alice there with my presentation. You can get very tiny ones, that's 32 gig. ESXi works well, and in a home lab, you're really unlikely to brick it. Hundreds of these are out there with servers, including many in my home lab. I've had no failures. You're not really writing to it much. ESXi just loads into RAM. So I see a lot of people in home labs thinking you're going to do better by installing it like on an expensive NVMe or on an SSD or an Optane drive. Complete overkill because ESXi is just loading into RAM. Now it gets a little more interesting when you've got vSAN in the mix. So look at some of my bullets there. So you get USB would be the first choice home lab, easily cloned. I have an article that shows you how easily you can clone it, which I had to do because I only flew here with one of these and it was in my Gigabyte motherboard demo yesterday and I need to reuse it for Alistair to get this presentation. Like, oh, I'll clone it and image and save my ESXi, put the PowerPoint for today on there. When I get back to my hotel room, I can dump my ESXi image back on it without losing a heartbeat and no time lost. So yes, easy and versatile, but not so great for your data center. Many of my daytime phone call stories are SD cards, bullet number 2, failing. 2, 3, 4 years, quite common. Probably half of my phone calls about vSAN customers that are at 3 to 7-year-old gear looking for a refresh and going hyper-converged infrastructure, they almost all have SD card failure stories. They were never really an awesome boot place for ESXi to live. So we move on to bullet 3. SATA DOM. Not exactly widely adopted, under $100. How many people actually use SATA DOM and work? That's one hand. In this, okay, gives you an idea. Not widely adopted, it would seem. And then finally, and basically it takes up a SATA port. I like using all of my SATA ports for my 6 drives I have at home. I put in SATA DOM and I lose one, kind of a bummer. So the whole point is bullet 4, kind of awesome. Now you go with M.2 drives that look like this. The connector's a little different. It's actually SATA, nice low cost, under $200, even from Dell or whatever. You get 2 of them and you get a RAID 1 mirror. Any of you have that deployed called a BOSS module from, there's one person in the room? Is that in production or just a test? Yep. Is that a Dell BOSS module or something else? It is? Yep. Okay, so for those of you interested, there's a green link. The word BOSS is highlighted. You can check that out later. Quick time check. All right, we're good. Official, this is now a VMware guy writing at VMware.com. And he summarizes everything I just said in a nice table. So for those of you into researching carefully what your next server should look like, yeah, I would suggest you try to study this page. Cisco, HP, Dell, they're all at a different part in their journey on moving from SD or micro SD over to M.2. Not everyone's there yet. So do your homework carefully when you create bills of materials, is my take-home message there. This gets tricky, but I have more props for you. So you're not going to memorize part numbers and 8654 or any of that, right? U.2, that ridiculous name, had a number like that that no one would use. So finally the standards body came up with, okay, we'll finally name it. This is what it looks like on the back of the Optane drive. I had this running live. It gets a little warm. Yesterday I had it out on the table all day. It's got aluminum heatsink, and it's a little thicker than your laptop. So it's 2.5 inch, you're familiar with that. A little thicker, a little taller, and the connector's kind of goofy. A little different than SATA. And here's the thing, you also need power. So it's kind of weird on like a home machine. You're not really gonna see this too common. Certainly not a laptop, so U.2 is not the way to go, but a little kludgy, and there's your U.2 if you have a motherboard that has one of those, other end of the connector. Stuff you might not be used to. But the point here is, more generally, this is going to be sold with a drive carrier for hot swap ability. So NVMe and hot swap, that's where U.2 form factor comes in. So I'm going to hand that around the room. You have something to look at while I'm talking. There you go. Just hand it around. All right. How many of you ever heard of RST? It's on Core i7 and commodity motherboards for a long time. Okay. How about RSTE? Anyone ever heard of that? Only 1 or 2 hands. Yep. It's just More in their Xeon line, right? You'll find on a lower end machine, you go in the BIOS, like, oh, there's RST. Does it support ESXi? No. So that's a very common thing I get on my blog. People leaving a comment, oh shoot, I thought I could do RAID on this motherboard. No, you generally need a controller with a decent queue depth, an HBA, and a PCIe slot, and it costs some real money, and it probably has battery backup cache and all to get decent performance out of a lot of SATA drives you pull together. That's what it takes. The built-in software, hardware RAID that that Intel has had for many years, not going to cut it, and ESXi is not going to be booting from it either. So you're not going to be doing a VMFS partition out of it, making a RAID array, you're not going to be booting from it. VROC is something you're probably less likely to heard of. Think of that as a hardware key, a way to get that motherboard I had on the table yesterday to do a software RAID, kind of, again, the kind of the gamer enthusiast market, like this world. Yep. And again, not going to work with ESXi. Now, VMD, different story. So that same article I told you about core storage from Jason here at the bottom, very second bottom line there. Read the Jason Masai story about all of that to get into what Intel VMD is in volume management, including blinky lights when a drive fails when you have a whole bunch of these in a server, or like the thing I'm handing around, the U.2 drive. Feel free to pull the cable off, put it back on. Yep. All right. So, looking at this, you can see where we're headed with all this. If you have binoculars in the back row, excuse me, but short version, the top row shows an 11 terabyte drive from Micron. Whoa. Notice, it is not SATA form factor. It's U.2. They want you to be able to rebuild it if it's in an array. They want you to be able to pump data in and out of it, a giant 11 terabyte drive. You're going to sell that as an enterprise product. Thank goodness the packaging is U.2 rather than SATA. SATA is really holding you back going forward. And if you can find a price on something that's U.2, PCIe, M.2, one of those interfaces that gets you NVMe goodness on whatever you're buying next, you're doing a whole lot more future-proofing for yourself, because it's pretty clear that's where the industry's headed with new products getting released. So this screen will kind of help you on that. I love that Micron just went and published that. It's awesome. All right, and this is kind of link stuff. I'm going to leave myself all of 3 minutes for Q&A. You can kind of click on this stuff later if you want. But the last article's been too popular, I would say. In other words, I'd rather VMware incorporate some easier ways to check firmware levels on your NVMe devices. So it's kind of cool that finally I'm working at VMware and try to give some of that product feedback. Like, yeah, this article's too popular. This should be easier. There's a lot of people finding me in the Googles. It should be right in the product. Maybe even in the GUI, not even at a command line. So that's what I like to do, is help people with those little hurdles for NVMe. If you search for it, you'll see a lot of me out there, particularly with ESXi, because there is a bit of a learning curve. It's not hard, but it is new. You've been used to SATA or SAS for a long time, maybe your whole IT career's in the data center. So thank you, and now that's just me. Yesterday took a bunch of videos in 4K. If you're interested in some videos that have to do a little more with home labs and things you might actually own in a home lab, cool, check it out. I visited 7 or 8 booths and put them all in 4K video. Thank you, Luxor Hotel. I abused the heck out of your internet the last 2 nights. All right. This really is my favorite part, 3 minutes. All right, who's got a question? Please feel free to ask a question. There's a microphone, or do they have a microphone or not? I'll repeat their questions, all right. Anybody, question? Come on, yes? Great question. So he has a HP product, some sort of home, like high-end home lab, a hand-me-down gear, right? You want to look at the PCI bus. Does he have a slot this long? Is it 16 lanes? And it's also, if you Google the specs for that particular machine you quoted, is it PCI 3.0 by 16 lanes for full speed? That gives each of these 4-lane devices full speed. If you look at this guy, that's 4 lanes, stubby, smaller, okay? So the answer would be it's probably PCI 2 if it's 6, 7 years. How many years old is it, right? It'll work, so you'll get it. You might be able to format it VMFS and use it in your home lab, but the speed might be halved. The top speed. Will you notice that unless you're doing a synthetic benchmark? Probably not. Cloning a VM? Yeah. Cloning a Windows 10 VM is 20 gig, and it takes me about 12 seconds on a rip-roaring home lab with a full PCI spec. On something old, it's probably going to take twice that PC. Any other questions? 1 minute. Come on, foam house to give away. I don't want to fly home with it. No more questions? That means I covered everything, you understand all of it, and you memorized the whole thing? Yeah? All right. Thank you very much for your time. Oh, question, yes? And then iWarp. Yeah, he just went a little beyond and more into the enterprise, less so the blogger. Stay tuned. Our let's see, VMware's website's more likely to have articles about that than me, frankly. I don't tend to cover the enterprise as much, but. Yep. But yes, NVMe over Fabric. How do you connect this over a network of some sort? How do you get to this goodness from a remote machine? That was his question. Yep. Yeah, he was asking about the Intel ruler and how would you connect multiple machines to multiple hosts, right? Time's up. I got to clear my gear. We have live stream going and the next speaker up, so I got to pack up. You can feel free to walk back to the hotel with me, which I got to check out of really soon.
Good. All right, good afternoon, everybody. Welcome to my vBrownBag Tech Talk, Community Involvement for Professional Growth. It's kind of just a real quick little chat. Hope to inspire people to get out and kind of be active in the community. A little bit about me. You can find me on Twitter at ExploreVM. I blog at ExploreVM.com. I also run the ExploreVM podcast. Notice the branding, kind of big, in community involvement. I participated in Virtual Design Master, Tech Field Day, and professionally, I'm a systems engineer with a company called Presidio. So what are we going to talk about? First of all, we're going to talk about the use of social media in IT. A lot of us here have Twitter handles on our badges. That is very important from what I've seen in the V community here. Quick little story, a few years back, before I even got into IT, I started getting into, on Twitter, I started following a bunch of people. Started making those relationships through Twitter, and I developed my blog, and I got out there, and I lost my session. I did the wrong one. Okay. So we're going live. So we don't need, thanks, you threw me off. Started building my blog, I started interviewing people. How do I get into the field? What do I need to know? And one of the guys I chatted with, he's like, cool, whatever. We stayed Twitter friends for a long time. A couple years back, I lost my job as part of a big, kind of restructuring event. Sent this tweet out. I was laid off on Friday, sent this out on Monday. Hey, looking for a job. Within 20 minutes, that guy who I interviewed for my blog said, I've been following your career for a couple of years now. We've got an opening. Why don't you come join us? And so yeah, staying involved, making those relationships was, helped get me to the company I'm at now, which has been, I'd say, incredibly invaluable to helping my career grow. But other aspects of community involvement as well, outside of just social media, is getting up here and doing something like this. How many people here go to your local VMUG meetings? Okay, most people. How many people go to any other meetups, any other technology groups? 1, 2. Stuff like that is huge. Not only just going and listening and making those relationships, but also finally taking the step forward and presenting and getting up there and sharing what you know. I do community sessions all the time at VMUGs, and I'll start like, you know what? I'm not the brightest guy in this room. And honestly, something I might say might be wrong. But this is what I've seen, this is what we've done, this is how I fixed it. Let's have a conversation, like let's all share our knowledge. And through that, we make a lot of really great conversations, and we help everyone out. And then going back to what I talked about with branding, so Explore VMO across everything, being able to be visible really helps out when you're trying to be, when you're trying to be active in the community. I locked down my domain, Twitter handle, I got stickers, stuff like that to give yourself a solid brand across all platforms. So get out there on Twitter, Facebook pages, LinkedIn. LinkedIn is huge for job hunting as well as just sharing your content, your domain, even stuff that you might not even think about like Instagram, Snapchat. I'm snapping Snapchat, and Google Plus is still a thing. I still send my content out on there because Google likes when you can search. It shows up in Google a lot easier. I am a huge proponent of giving back to that community that helps me grow. So I'm here doing this on a speaker pass. And I'm only comfortable on a speaker pass because I spent so much time at VMUGs learning from others and finally getting out and speaking. And so now I'm going to go present in a room with several hundred people, hopefully. Hopefully my content's good and they want to actually come listen to me talk. But so you just got to get out and give back. Also, I mean, we're all technologists at this point. You got to make sure you keep up with the times. See where things are going. When I left school, when I first entered IT, I was a Microsoft server engineer, looking at Active Directory, DNS, your basic infrastructure. I stumbled upon a class for this new emerging virtualization technology, and it blew my mind. I loved doing it. It seemed so cool. And even now, to this point, obviously I'm still very heavily involved with VMware, but I look at other things like backup and recovery, data protection, networking, automation, cloud, Azure, AWS. Like I'm doing more and more of that with my data center career. If you'd ask me 5, 6, 7 years ago what I'd be doing in that time, you just got to be able to roll with the punches and shift. Continuing to train, certify, and grow. I work for VAR. We kind of value the certifications. It helps us show our clients, hey, we know what we're talking about. We've got all these certifications. Your company might not actually, private companies sometimes just don't care about these certifications. But by getting out there and doing those, I look at it as more like helping yourself grow. It keeps you learning. It's a great way to find new content. It's a great way to find new technologies. And you know what? You might not be looking for a job, but you really get into this technology. You say you start diving into AWS, and before you know it, you kind of decide that's where you want to go. Or somebody you're talking to is like, oh, you're doing this with AWS. Why don't we chat? So, keeping up that networking and keeping up your skill set, you'd be surprised what kind of comes your way. I'm also a huge proponent of helping your coworkers strive. I can't imagine everyone here you brought all of your coworkers with. Your company, there's no way they sent everybody. Take what you've learned at this conference, take it back to your office. Help teach everyone else around. Go to your VMUGs. If there's a VMUG session on what's new at VMworld, or if you're in conversations between breakouts, chat, share this knowledge, help people grow. Chris Wall has a quote in one of his posts or one of his podcasts about iron sharpens iron. We're not, as coworkers, we're not here to fight each other. We're all here as the business unit to help the company grow. As much as people don't like to think that IT is part of the business, it absolutely is, because without the full infrastructure of the business, what's the point of IT? That's our goal. So by everybody helping each other out, being great team players, and helping that new guy learn, or being willing to learn from somebody within your company, you get a lot of benefit. And also, another way to get involved, just shameless promotion, Virtual Design Master. This was an online reality contest ran by Angela Luciani, Eric Wright, Melissa Palmer, that pits people from around the world in a VCDX style design contest. You're given a weird scenario. You're given 5 days to write a full design doc, sent in for judging, and then you defend it live on camera as thousands of people around the world were watching. I ended up taking 3rd place the season I participated. My whole goal was to not go out first, and I was rather happy with where it turned out. But by doing this, I learned a bunch of new technologies. It got myself and my brand out there, and people started chatting me up. I was on the train at VMworld here, and I'm sitting there like, on my way back to my hotel, and I hear, hey, Virtual Design Master. I turn around, and somebody's like, yeah, we watched you. That's cool. It opens doors. Shameless plug number 2. vBrownBag. You're all here at the vBrownBag sessions. I recently joined up as a co-host, but there are plenty of opportunities to come on and host. If you're not watching the weekly webinars, give those a look. A lot of cool stuff going on. And then also, don't be afraid to jump on and host. You got to chat for 45 minutes, 40 minutes, an hour. You got a topic. They're always looking for hosts. There's openings for all sorts of stuff. So don't be afraid to get out there and share your knowledge. Any questions, go ahead and grab me. I'll be around the conference. My blog's got a lot of information out there, and I'll also be presenting Wednesday. I don't remember the room, but I'll be presenting on free tools for your VMware environments. Feel free to find me. So thank you all very much.
Olá pessoal, meu nome é Ricardo Conzati, sou especialista em virtualização, possuo algumas certificações técnicas, posso ser encontrado pelo Twitter @Ricardo Conzati. Hoje eu quero falar para você sobre o VCAP Simulator. Passaremos por alguns pontos, que é o que é o VCAP Simulator, de fato, para que ele serve, por que ele foi criado, qual a importância da comunidade nesse processo, ok? Alguns números e, por fim, sobre o acesso. Então, o que é o VCAP Simulator? O VCAP Simulator é um ambiente VMware parcialmente funcional, né? VMware vSphere. O que isso quer dizer? Foram feitas algumas configurações no ambiente seguindo recomendações do fabricante, né? Recomendações da própria VMware, e aí, posteriormente, essas modificações foram necessárias para gerar algumas questões. Então, o ambiente fica parcialmente funcional porque ele sofreu modificações, né, uma espécie de uma bagunçada, digamos assim, né, gerando 17 atividades. E para que fosse um pouco mais similar ao exame real, além das 17 questões, você precisa ainda resolvê-las no tempo máximo de 180 minutos. Né? Então, de uma forma bem simples, o VCAP Simulator é um ambiente VMware vSphere parcialmente funcional, né? Foi parcialmente modificado, né, para não funcionar de forma íntegra, de forma perfeita, digamos assim, gerando 17 questões e 180 minutos. Né? Basicamente isso. Então, o ambiente é composto por um vCenter Server, 2 clusters, 5 hosts SX, 11 máquinas virtuais e muito trabalho a fazer. Né? Basicamente é isso. Ok, entendido o que é o VCAP Simulator, então como ele pode me ajudar? Né? Como isso pode me ajudar? Bom, eu separei 3 casos de uso. Existem pessoas que já me relataram que fizeram algumas outras coisas que eu não coloquei aqui, mas os principais casos são esses 3. Inicialmente ele foi criado como uma espécie de preparatório para o exame VCAP DCV Deployment. Né? Então você pode utilizar o VCAP Simulator para ter uma ideia do que você pode esperar desse exame, certo? Para pelo menos você ter um norte, você conseguir fazer o agendamento do teu exame e assim, ter uma ideia do que pode cair, de como é o ambiente, né, de quão complexo esse ambiente pode ser. O outro caso de uso, que não tem relação direta com certificação, é você testar o seu conhecimento. Né? Você não precisa estar estudando para o VCAP, ter algum certificado VCP ou nenhuma certificação técnica. Você apenas vai acessar o ambiente e tentar resolver as 17 questões. No final dessas 17 questões, ou no final do seu tempo, né, dos seus 180 minutos, você vai descobrir que talvez você teve mais facilidade em resolver questões de storage do que questões de rede. E aí você talvez precise estudar um pouco mais de script, ou um pouco mais alguma configuração avançada de iSCSI ou NFS, por exemplo. Né? Então é um caso de uso bastante interessante também. E por fim eu coloquei aqui diversão. Se assim pensarmos friamente, o VCAP Simulator ele possui 17 questões e possui um tempo. Algumas questões são mais difíceis, outras são mais simples. Então podemos entender que as questões mais difíceis são uma espécie de chefão, por exemplo. E aí, para deixar esse seu jogo um pouco mais interessante, você pode adicionar o tempo também. E aí você entende que é como se fosse um jogo. Você precisa passar por todas as 17 fases no tempo máximo de 180 minutos. Então pode sim, para os nerds, é claro, servir como um pouco de diversão também. Ok, entendemos o que é o VCAP Simulator, para que ele serve, mas por que ele foi criado, né? Qual foi, de fato, a motivação para fazer esse simulador. Então eu tenho alguns números aqui que indicam por que eu resolvi criar o VCAP Simulator, né? Como que tudo isso começou. Logo após eu passar no exame, eu vi em algum blog da VMware alguma informação que nós possuímos no presente momento, né, 2017, 50 pessoas certificadas com o VCAP. E aí eu percebi que nos anos anteriores, 2015 e 2016, possuímos 55. Então, ao contrário de pessoas certificadas com VCP, que tínhamos 787 e passou para 1.400, o número das pessoas certificadas com VCAP diminuiu, né? Então passou de 55 para 50. Então eu, após passar no exame, comecei a pensar o que eu poderia fazer para que esse número melhorasse, crescesse, que mais pessoas conseguissem passar, né, nesse exame. E também motivado por esse número extremamente baixo, onde apenas 4%, né, menos de 4% das pessoas que possuem VCP possuem VCAP, né? Então a ideia era justamente entender aonde que eu poderia ajudar para fazer com que esse número, né, com que essa porcentagem subisse mais e nós tivéssemos mais pessoas certificadas, ok? Então, pensando nisso, óbvio, isso não é uma verdade absoluta, é um ponto que eu entendi que pode ser considerado como uma espécie de justificativa para aqueles números relativamente baixos, digamos assim. O primeiro pode ser a cultura das empresas, né? Hoje no Brasil, né, que é onde esses dados foram extraídos, nós temos pouquíssimas vagas, né? Eu não me recordo de ter visto uma ultimamente que solicita que você tenha VCAP no seu currículo ou algo do gênero, né? A grande maioria pede apenas VCPs. Então, por causa disso, talvez os profissionais eles optam por não estudar, por não continuar essa sua evolução lógica, né? Que seria após o seu VCP você passar pelo VCAP, né? Pode ser um ponto. Outro ponto, né, pode ser o custo. Não é tão mais caro do que o VCP. O VCP custa no Brasil em média de $200, enquanto o VCAP deve ficar próximo de 300 ou 350. Não deve ser problema para empresas arcarem com esse custo, mas pode sim ser algum impeditivo, né? Então, nesses dois primeiros pontos, eu não tinha como fazer nada para ajudar, né? Eu não consigo mudar a cultura das empresas e eu não consigo patrocinar o VCAP Simulator para ninguém, né? Então, o terceiro ponto é sobre a dificuldade, né? Esse é um ponto que eu posso ajudar, porque é um exame de fato difícil, ele é mais complexo do que os exames que a gente costuma fazer, porque ele é um ambiente de laboratório, né? Então, de fato, você precisa acessar um ambiente vSphere, o mesmo ambiente vSphere que você tem no seu ambiente de produção, e precisa fazer configurações nele, né? Então, talvez se você reprova 1, 2, 3 vezes, o custo pode ser de fato algum problema, né? Então, identificando aonde eu poderia ajudar, que eu comecei a trabalhar no simulador em si, ok? Então, uma vez que a ideia do simulador já estava pronta, precisava de fato começar a tirar isso da cabeça e colocar no papel, começar a desenvolver esse simulador como um todo, né? Aí que entra a importância da comunidade, né? Então, inicialmente tive essa ideia, né? A ideia foi minha, mas o desenvolvimento do VCAP Simulator e a forma como ele está hoje, né, não foi apenas minha, foi minha em conjunto com a comunidade. Então teve muita conversa, sugestão, feedbacks, né? Então, seria interessante você fazer isso, pô, você fez aquilo, mas não ficou legal, vamos tentar mudar, vamos melhorar aqui, tenta usar isso, usa aquilo, até que a gente chegou no ponto da criação das questões propriamente dito, né, das 17 questões. E aí, claro, após essa criação, o VCAP Simulator começou a criar corpo, começou a poder ser acessível e você poder começar a fazer testes com ele. E aí, baseado nisso, começaram de fato os testes e as validações, né? Muitas das pessoas que estão hoje aqui no evento comigo já participaram também desses testes, dessas validações. E baseado nisso a gente teve feedbacks e conseguimos melhorar de fato o VCAP Simulator até que saiu a primeira versão, né? Então essa primeira versão, esse ambiente vSphere, né, rodava no meu servidor dentro da minha casa e utilizava praticamente todo o poder de processamento dele, né? Então era basicamente processos manuais, né, bem manuais inclusive, e pouca automação, praticamente nenhuma, né? Então esse foi o começo do vCAP Simulator, né, com ajuda, né, bem forte, bem presente da comunidade. Então, após essa versão inicial, o vCAP Simulator teve uma repercussão muito grande, né? Muitas pessoas compartilhando, o acesso vinha de blogs de outras pessoas, vinha de redes sociais da própria VMware, e eu comecei a perceber que eu precisaria fazer algumas modificações, né, algumas mudanças para garantir a continuidade do vCAP Simulator. Então, claro, tiveram várias mudanças, mas eu posso destacar 3 delas que foram as principais, né? Então, a primeira delas foi a migração para Ravelo. A primeira versão, o vCAP Simulator rodava no meu servidor dentro de casa. Eu comecei a perceber que era muito acesso, muitas pessoas solicitando, e eu tinha perdido o meu servidor. Eu não podia mais utilizá-lo. Eu queria fazer um lab, queria fazer um teste, e eu tinha que disponibilizar esse meu hardware para as pessoas fazerem acessar o simulador e fazer os seus testes. Então, a migração para Ravelo, no primeiro momento, ela me devolveu o meu servidor para que eu pudesse utilizar, né? Afinal de contas, ele é meu e eu também gosto de fazer laboratório e estudar com ele, né? Mas não só isso, a migração para Ravelo também, ela trouxe automação. Então, devido à grande quantidade de pessoas solicitando acesso a esse ambiente, eu comecei a ficar com uma séria dificuldade de disponibilizar tempo para criar o ambiente e disponibilizar para essas pessoas. Então, a automação, utilizando Power CLI, PowerShell, por exemplo, foram fundamentais, né, para que o vCAP Simulator conseguisse manter a sua continuidade. E não só a automação da parte técnica, né, falando sobre scripts ou algo do gênero, mas a automação dos processos, né, a forma que você faz o cadastro no site, recebe os seus e-mails, né? Então, esses 2 pontos foram fundamentais. E o terceiro e último ponto que eu quero destacar aqui é a questão da doação, né? A ideia não é, de fato, ficar milionário com o vCAP Simulator, né? É muito pelo contrário, na verdade. Mas muitas pessoas faziam o agendamento, recebiam o seu acesso e não realizavam o acesso, acabavam dando no-show. Isso tinha 2 problemas. O primeiro, eu perdia tempo para provisionar o ambiente e essa pessoa ocupava o slot que poderia ser utilizado para outra pessoa fazer o acesso. Então, eram 2 problemas que foram corrigidos, não 100%, porque 100% é praticamente impossível, mas muito próximo disso, né, foram corrigidos colocando um valor definido para você fazer uma espécie de doação e ter acesso ao ambiente do vCAP Simulator. Então, esses foram os 3 pontos fundamentais para garantir que o vCAP Simulator continuasse funcionando, né, até os dias de hoje. Bom, aqui só exemplificando um pouco, né, nós temos um exemplo de como que o usuário recebe esse e-mail de acesso. Então, ele vai receber um arquivo RDP. Esse arquivo já está contendo as credenciais de acesso, que são únicas dele, né? Um script que faz randômico as senhas. Ele vai receber o IP, que é o RDP público do computador lá na Ravelo, e baseado com isso ele consegue fazer o acesso, né? Na tela ao lado nós temos a console da Ravelo, né, com o ambiente, e um pouquinho abaixo a parte de rede, né, configurado na Ravelo. Para esse exemplo, nós usamos, né, o tão querido Homer J. Simpson, obviamente. Então, eu quero compartilhar um pouco sobre os números do VCAP Simulator. Esses próximos slides são algo que me deixam extremamente feliz e assim torna bastante gratificante todo o esforço que eu tive para fazer o VCAP Simulator, para manter ele, as atualizações. Então, gostaria de compartilhar eles com vocês. Estes números, eles são do último ano, né? Agosto de 2017 até agosto de 2018. Então, nesse ano, tivemos mais de 200 solicitações, né? Então, são números que, para mim, são números gigantes, saber que eu consegui ajudar mais de 200 pessoas, né? Não consigo garantir que todas essas mais de 200 solicitações passaram nesse exame, mas eu consigo garantir que, de alguma forma, né, tecnicamente, elas cresceram. Então, eu consegui ajudá-las de fato, né, e isso é algo que me deixa extremamente feliz. E essas mais de 200 pessoas, elas vêm de mais de 40 países, né? Assim, sinceramente falando, países que eu nem sabia que existiam. Então, você não só ajuda pessoas do seu país, como era inicialmente a ideia, mas você consegue ajudar pessoas de trocentos outros países, né? Isso é uma coisa realmente sensacional. E aí, por fim, dessas mais de 200 solicitações, né, nós tivemos 18 vindo do Brasil, inclusive diversos amigos meus, que eu sei porque eu tenho contato com eles, conseguiram passar no exame, né? Então, fico feliz também por saber que não só ajudo pessoas do mundo inteiro, mas pessoas do Brasil, pessoas que são meus amigos e que foram ajudados pelo VCAP Simulator também. Então, de fato, esse slide especificamente é algo que me deixa extremamente orgulhoso e feliz, né? O dever de missão cumprida. Aqui só ilustrando, né, a parte azul, são pessoas que já fizeram pelo menos um acesso ao VCAP Simulator, né? Não é o mundo inteiro, mas está próximo disso. E aqui temos alguns países, né? Países conhecidos, alguns nem tanto, né? Temos o Brasil aí no meio, Estados Unidos, Catar, Sudão, Filipinas, Colômbia, Chile, Paquistão, né? E vários outros. Aqui eu gostaria de falar um pouco sobre os números do VCAP Simulator com relação aos países que mais fizeram solicitações, né? Então montei uma espécie de um top 5. Não é surpresa para nenhum de nós que os Estados Unidos e a Índia estão liderando, né? É uma coisa até bem comum. O Brasil está em terceiro lugar, né? Com 8,7%, que são as 18 solicitações. A República Tcheca vem em quarto e o Reino Unido em quinto lugar. Então esse é o top 5 das solicitações. Fora esses 5 países, tem mais 35 que fizeram ao menos uma solicitação. Bom, como eu posso fazer um acesso? Eu quero entender como é o VCAP Simulator, como ele pode me ajudar, como eu consigo fazer esse acesso e de fato solicitar o VCAP Simulator. Então eu posso entrar nesse endereço e lá vai ter tudo o que você precisa saber sobre isso, né? Como agendar, perguntas frequentes. É pouquíssimo provável que após ler este endereço, este link, você terá alguma dúvida. Mas se mesmo assim tiver, basta mandar alguma mensagem pelo Twitter ou na própria página do blog, né? Não tem problema nenhum, eu respondo sempre que possível. E aí, por fim, uma vez que você já leu aquelas informações básicas para entender como é o processo, como que pode funcionar isso, aí de fato você acessa solutionforcrowds.com.br/VCAP Simulator. E aí você consegue escolher o seu slot, né, a sua data, o seu horário, né, um horário que fica mais interessante para você, e aí você segue com o agendamento. Bom, pessoal, basicamente é isso que eu tenho para falar. Agradeço imensamente poder estar aqui e compartilhar essa história de sucesso com vocês. Muito obrigado e até a próxima.
Hello everyone. So I will try to explain about the Ansible. So my name is Rodrigo. So it's the first time here, and I try to explain something about Ansible. Okay. I'm not an expert in Ansible, so I try to learn and do anything inside of my job because it's easier to make some configurations about these tasks that I made day by day. So the idea is just to make introductions and the motivations to make this and the conclusion about the tool, okay? So I'm a CCE, so I get my certification in 2016. So when I finish my certification, I try to verify what's the best idea to make this. For example, to configure some devices on the same time because, for example, I need to make the configuration on the router or switch, so I need to do each one. Okay, so here I'm trying to verify what's the challenge that need to do inside of this because I'm a native CLI, so I just access the device and make the configuration there. Okay, so my challenge to work in these tools regarding Learn Linux, virtualizations, and some things. Okay, my motivation to make this, for example, regarding a cloud scale. So in most time you have a lot of devices that need to do the configuration. So I put here an idea about network devices. So most of the time you have a different operation system. So this idea here is made to inside of the Cisco. Okay, so are different iOS. So iOS XR, iOS XE, and it's NXOS. So it's a different to do the configuration by the CLI. So the command line, it's totally different when I use do or another, okay? So in most time in the company, the team it's so small. So it's difficult to make this quickly. So the idea here that to make a rapid deployment using this inside of the data center or on the branch office or something like that. Inside of the enterprise scale, so I have repetitive tasks. For example, to make a configuration inside of the management tools regarding SNMP or change the NTP servers or something like that. So you need to make in all devices on the same time, and the in time window is so short because it's a critical environment. So that's my motivation to learn more about Ansible. Okay. This tools is based on the DevOps terms. So I believe that all guys here listen about this term. Okay. So the idea about this that you can follow this way inside of the test and the release and deploy your configuration, or for example to operate or to plan another code and so on. So this cycle is continuous. So you need to make better codes or better configurations in order to deploy this. Okay. Here there is an example that you can use inside of each step. So, for example, Ansible inside of the deploy, but you can use in another tasks, for example. Okay. So just to example, that is different tools that you work inside of the terminology. Okay, of the DevOps. So just to explain a little about the Ansible. Okay. So it's a open source, but is sponsored by Red Hat. Okay, and in this case, it's a simple way to automate IT infrastructure. Okay, and this language all the teams can use this. The idea that I put here, for example, the developer teams, the network administrator, system administrator, okay, sysadmin, the term that you listen, okay. These tools, there are different logo if you see. The first one is an open project, and down the head Ansible engine. So these tools had support on the environment, or can give you some support if you have some problem to make some configuration or something like that, okay? But the open project is so good because the people or the community can support a lot of things if you need the doubles to make this, okay? I put here, for example, the provides enterprise-ready solution to apply in your life cycle. For example, servers to cloud, containers, and some other infrastructure that needs to do, okay? The most important is agentless. So it's not necessary to install something in your device or in infrastructure or in your server, because about the devices, all the codes running inside of node control. That's the machine will execute Python, for example, in order to make a configuration on the device. So it's good because it's not necessary to install in all devices a specific client, okay? So it's a simple language. It's YAML. So YAML, it's easy to read this, what I needed to do, okay? And the background of the Ansible, all modules running inside of the Python, okay? Here I put another idea in order to management your playbooks, for example, or in order to monitoring what's needed to do. For example, the open source project regarding a name AWX, so it's an open source, okay? You can download from the GitHub, for example, and install in your machine and try to execute this, okay? There is a quickly acceptance inside of the community to help you if you need to make something, for example. And another example that I put here about Ansible Tower. So this is a Red Hat product, okay? So the Red Hat will support on this, for example, to make an installation or to make a support about the project that you need to do, okay? So there's more stable, there's more security because Red Hat all the time that has less version than the project of the open source, okay? So there is something that you need to analyze with the better for you, okay? So it's more reliability, it's stable. Just to explain something about the YAML structure, so it's a dictionary that you do inside of the playbook. It's unordered because it's not necessary to put all the things in the list of the sequence. So there is a value pairs that you need to put there. And on the side I put an example, for this. The name and the job and the skill and the employee or the certifications. So you need to put in sequence or something like that to inform about the data that you need to execute on this. Just to explain about the Ansible in network environment, because it's totally different when you make on the Linux or Windows, for example. If you're using inside of the network hosting, so it's not necessary that I mentioned before to install anything in the device. Okay, so all the code executing node control. So just to access the device and try to execute the configuration that you plan inside of this. But if you use Linux, for example, all the codes that you execute, you go through on the device. So there is a total difference here that the Python code is executed on the server machine or host that you need to do, okay? So, and there is a difference when you mention about the connections. So when you execute on the network hosts, you need to execute by RESTconf, for example, or network CLI. And you execute on the Linux, just to mention about a local, okay? I mentioned that I will do a demo on the code on Thursday, so I try to explain more about this. So I have some codes in GitHub that you can verify about this, and the additional library that I use in order to develop my codes to make something about a configuration in Cisco devices, okay? So all the libraries, it's totally free. We can access by GitHub, for example, and it depends of you need to do on the environment. For example, SNMP, it's good because sometimes you don't have access on the device. You don't need to make a telnet or a SSH. You just getting by SNMP. So sometimes it's good for you. Okay? Okay, guys, I finish. I don't know if I quickly, but I don't have time to deep dive about this. But on Thursday, I will go through on code and I will give it a demo, okay? Thank you so much.
Hi guys, my name is Russ Hamker. I wrote a PowerShell application called vDeploy, and this session is about Power CLI only method to fully deploy a VM using vDeploy. So, what's this whole presentation about here? It's all about vDeploy and how to use it. I made this to simplify my VM deployment. I designed it to be modular. I designed it to use it for all kinds of different use cases. Why PowerShell? So it's written to standardize all the different VM deployments by using one single code language. So one of the frustration points that I've had in the past is that other applications for doing VM deployment will use many different languages to end up getting you to where you need to be at the end of the game, which is deploying your virtual machine with applications and configurations on them. With that said there, so vDeploy is written in PowerShell. It includes GUIs. So I'll kind of talk about my GUIs. Some of the modules that are already included with it too, Power CLI, Power NSX, Active Directory. One of the big things about this though, being so modular, is you can add literally any other PowerShell module you want to it, and it's just an add-on. Very simple. Why did I write it though? That's a lot of people ask me this question. So I wasn't happy with the way our VMs were being deployed at the office with nothing against VMware Orchestrator, great product. It's just complicated. It's also not as fast as I wanted it to be. So our average deployment process was about an hour and 15 minutes of virtual machine, which is pretty time consuming when you think about it. You want it as fast as you can, as you want to move at the speed of business. They don't want, management does not want you to dilly-dally on things. So anyway, I also did this to help better my understanding of PowerShell and Power CLI. Coding gave me a greater control over the deployment process as well when you do the entire thing in code. So some of the goals I had in mind here with doing vDeploy was to simplify VM deployment, obviously, as I talked about. Common language, again, PowerShell. Better security for password management is actually a big one a lot of people don't think about. So some of the other VM deployment options on the market there, they do a lot of passwords. They store them in clear text. It might be in the database, and the database might be encrypted, but you open it and you have access. Well, guess what? The passwords are just legible right there anytime you want. I also wanted a lot of really good logging for this. That's one of the other frustration points I have, is that even with Orchestrator, our problem was you could get to a point, they give you an error, but it didn't give you really fine detail about certain scenarios, especially when you're trying to call PowerShell to do certain things, because as we all know, no application's perfect, and Orchestrator, you have to do PowerShell for quite a few functions because it doesn't have everything built in. And I also wanted to do email reporting. Email reporting was a big one to me. I wanted to have a lot of detail in email reporting. I wanted to know a lot of information about my deployment process. I didn't want to just know this VM got deployed on this day by this person, it's on this data store. That wasn't enough information to me. So that was one of my other goals too, was to help figure that out. So real briefly on comparisons here. So Orchestrator, we use it today in my company and vDeploy as well. My biggest frustration point, honestly, with Orchestrator has always been JavaScript coding. You had to do a lot of JavaScript coding. You still had to have a PowerShell host as well. The passwords are stored in clear text. I was talking about that earlier. It does have some great functionalities. It integrates with the APIs for VMware, obviously, really well. But it does have a lot of missing functionality out of the box. It makes you have to do a lot of custom coding. And that's very time-consuming for a lot of people. There's VMware Automation. Again, it's a great interface. Costs money, though, unfortunately. And PowerShell host is still required. Orchestrator is still required for some stuff. It does have better reporting. It does have better logging. vDeploy, in comparison, it's all 100% PowerShell. It is a simple to use interface though. There is no cost. I have it on GitHub. Anybody that wants it, you can download it right now and you can deploy it in your environment in about 10 minutes. It does require one Windows-based virtual machine that has PowerCLI, PowerShell, and all that set up on it. It does store passwords. All passwords are stored in AES 256 based encrypted files. I have really great logging set up with it. PowerShell does a really good job of that by itself. I'll show you guys some of the reporting here towards the end of the presentation. It's very, very, and I can't stress this enough, very modular. So if you can write a PowerShell script to install an application on a local box, well, guess what? You're done for adding that application to vDeploy, to be deployed on tens of thousands of virtual machines with a couple of clicks. Now it is only currently designed for doing Windows VMs, and I'm going to work on that here at some point and try to do Linux as well. But presently today, it's really more aimed at the Microsoft world. How does this thing make it simple for you? Is what it. And as I talked about, the simple GUI is a big deal for me. Standardizing the deployment process is also a big thing in general, and a frustration point that a lot of us have. It also integrates with NSX, so it uses NSX security tags to deploy applications and configure things on the VMs themselves to help lock them down. It also does VM tags. So VM tags are used for organization and management of the virtual machines, especially for VROps. This is really good. I also have a couple extra requirements I've added in, the pet peeves I have. So like VM notes is one of them. I want to know details about this virtual machine. You can't just deploy a virtual machine and I don't know what's this thing for, right? I also want to know who did it and when they did it. I also want to have, I also want to know who the server owners are. So obviously, they're going to contact me when they have a problem. Hey, I need more space, right? Well, sometimes we see, hey, they're out of space. What do you got to do? You got to find out who they are. So having that information on the virtual machine for notes is really big to me. The other big thing about my script is it's a single script. You don't have to have it for different Windows domains. It is one script that will cover every domain in your environment in the way it's designed. I talked about security a little bit already, but AES 256 encryption is a big deal. You can also lock down your PowerShell scripts using NTFS-based permissions. It also uses HTTPS Secure WinRAM for doing the application deployment for Windows. I also talked a little bit too about NSX security tags. The idea is that before the VM actually comes up, the NSX security tags actually get applied before the VM's turned on. And then when you power it on, it literally is locked down as far as it gets. So the zero trust model is the way I try to think about how to build this whole process here. vDeploy does use domain-based authentication to do management and configuration. So there are some user accounts you have to create, one in each domain specifically for helping with application deployment, configuration management, that sort of thing. I've also put some stuff in the code to help protect me from myself. I know that sounds kind of funny, right? But all of us get lazy sometimes when we forget to click on something, or we decide we don't want to type the name of the virtual machine, you know, uppercase or lowercase every time. So things like that have been put in to make sure that the VM names are the same across the board, size-wise, caps specifically. VM also it checks for duplicates. It also checks an Active Directory to make sure there's no duplicate computer objects as well. I talked a little bit about requiring notes as well. That's a big deal. A lot of stuff about IP address information. I wanted to make sure that you weren't putting in some IP that wasn't real. So trying to code for that was a big deal. I also wanted to make sure I standardized naming conventions based on net BIOS requirements. Unfortunately, Microsoft, as you guys know, the naming convention is still 15 characters, unfortunately. If you select an application, the other big thing too about making it simple for me was I didn't want to have to think about how do I make sure that if I install WinZip as an example on a server that, you know, it puts some kind of VM tag saying, hey, this server has WinZip on it, or maybe it's a web-based application like IIS, and you want to make sure that it has an IIS tag on it, so that way you open ports up automatically on the network. I talked about being modular a little bit, so you run your main script, and the script will, and then I'll demo it here in a second, will present you with a GUI. The GUI will allow you to select multiple different checkboxes for applications, configurations, all sorts of different things. I'm almost done with version 3.0 of this. I'll have it up on GitHub shortly, and there'll be some new features. I'll talk about that at the end as well. A lot of different example use cases for this as well. Let's get on to the demo though, because I want to make sure I have enough time for this. And it's not playing. Oh, there we go. All right, so I'm going to try to talk about what is actually happening on the screen here. So you're running the PowerShell module, or get vDeploy for the first time here. It's creating log files and storing them to the computer. It connects to NSX and vCenter automatically. It's a GUI I've made here. It's all in PowerShell only. The nice thing is you can customize this yourself. I've included the code for actually developing your own version of this. As you notice, it also talks about NSX Manager at the top of the screen as well. If you don't have NSX Manager, it knows about that, and it presents you with different information depending upon if you have NSX or not. You can control pretty much every aspect of, you know, what host you're putting this on, what data center you're putting this on. This is also designed for metro clusters. At the top about VM site, one of the things we do is we put virtual machines to a specific site as well, just to make sure that they run one place or the other. Data store wise, we also make sure that you list out, you know, what's the one with the most space on it to begin with. That's what everybody always looks for usually, right? One of the other big things too is you see OS configuration. Literally, it'll read off every OS configuration you have in vCenter. So the idea is you can have as many domains as you want. You also have a hard drive configuration as well. That hard drive configuration can be multiple different configurations. There's like 10 or 15 of them I have now in this. And you can add your own for any different template type configuration you want. But the idea is that you just have basic VMs here when you start out. And the other big things is too, I wanted to make sure hard drive configurations, you could do them on the fly, and it would actually format your hard drive and resize it if necessary as well. So all you do is you type in the information you want for that and you hit OK. So now it's going to clone the virtual machine here. And then after this process here, and I apologize, I've got to shorten the video here. But the idea is that there's a lot of different things that are going to go on in here. So it puts it on the specific VLAN I wanted to have it on. It adds the notes as a requirement. It puts DRS group settings on the VM immediately for metro clusters. It then after that expands the hard drive if necessary, adds another hard drive if necessary. It also does best practices for adding the individual storage controllers to each of your virtual machines. So depending upon how many drives you've selected, it'll auto-configure all that for you as well. After that, it adds NSX and VM tags And again, this is all in an off state at this point. And then after that, it disables automatic VMware tools updates, and then it does a sysprep. And that sysprep is what you guys saw there, waiting for it to come up. After this is completed here, it makes sure DNS is functional. That's one of the big things outside of our control, right? DNS. And after that here, it we'll start rolling through a process automatically to read through your PowerShell scripts for installing an application. So I'm getting told I need to kind of tighten this thing up here. So I'm going to kind of go over the report at the end of this and show you guys. It's really very quick, but it's very detailed, the information it gives you. And the nice thing is it gives you rate management information. Again, it talks about NSX, it talks about the applications that got deployed, it verifies if the applications got deployed correctly, and tells you that in the documentation. And it also tells you how long each application and configuration took, including even sysprep, your script run times, all kinds of great details. So that way, someone asks, why is this taking so long? Well, your one application takes too long to install, and that's what's really happening here. It's not my VM deployment process. There's also some great logging, as it really quickly scrolled through on the screen, that you can also save along with your change management tickets. And then there's also a CSV file that kind of goes over the main configuration when you deploy the virtual machine. Do we have time for questions? Nope, wrapping up. Okay, well, and that's pretty much it for vDeploy for me. So I want to make sure I talk about GitHub. So you guys can find it on GitHub right here under Butch7903/vDeploy. I'm also on Twitter. People all over the world talk to me about this and ask questions. So feel free to reach out, talk to me. I'm happy to talk anytime. Thank you.
All right, good afternoon, everybody. Thank you for coming. My name is Scott Delandy. I am with Dell Technologies, and I am part of the storage division based out of corporate headquarters in Hopkinton, Massachusetts. And today, we're going to talk about everybody's favorite subject, and that is traditional, high-end, external storage. So here we are at VMware, and I know that there's a lot of discussions around different deployment options for storage. A lot of people looking at hyper-converged, a lot of people looking at software-defined. But what I can tell you is that we've talked to many, many customers that still continue to rely on traditional storage infrastructure for their mission-critical applications. So it is definitely something that's not going away and something that actually we're seeing people continue to invest in. And what I want to do is I want to spend a couple of minutes talking about what some of those reasons are in terms of why people continue to invest heavily in that part of the infrastructure. And then I want to show you some of the cool new features that we've introduced to help make your VM environments not just more efficient, but more reliable, more stable, and provide higher levels of availability. So let's get started, right? So from a platform perspective, when you look at the things that people do with PowerMax, one of the big ones is the ability to consolidate. Okay, at the high end, we have users out there that put dozens, hundreds, in some cases thousands of ESX clusters on a single storage array. So that gives them the ability to scale into thousands, tens of thousands of virtual machines. And one of the big drivers for that type of a deployment is the ability to consolidate and standardize the way the storage infrastructure is being managed across all of those applications and across all of those different workloads, right? So still continues to be one of the strong value points that we have with traditional infrastructure for storage with things like PowerMax. The second reason is because of the ability to provide better performance, and not just high performance because of all flash goodness, but performance that's very predictable and very consistent. So whether you're booting up VMs, or whether you're moving things around, or whether you're seeing applications spiking in terms of activity and workload, we're able to drive consistent, predictable levels of performance because of the flash technology that we have under the covers. One of the things that I hear very common from users out there that have all flash systems deployed in their environment is the day-to-day management of those systems is basically boring. Right? The old days of having to go in and do performance tuning and analysis and tweaking the environment and playing with tiering policies and things like that, it just doesn't exist. So in a lot of cases, the amount of administration required for these systems is a fraction of what it used to be. So if you're a storage admin out there, you've got a lot more free time on your hands, hopefully, to focus on other things that are important to the business. The third thing is around data efficiency. Okay, we've introduced a range of space efficiency technologies, things like data reduction with dedupe and compression, but there's also other space efficiency technologies, things like thin provisioning, things like snapshots, the ability to do zero space reclaim, which allow us to be able to present much more capacity to the applications and to the host than what's actually physically required within the array. The fourth reason is around availability, right? When you look at the systems and the redundancy and the serviceability and just the high availability features that we build into the platform, it really is one of the big trusted components within the environment to be able to support your most mission critical types of applications. Now, when it comes to VMware, we've got a number of integration points. We've invested actually heavily over many years to make sure that deploying PowerMax and VMax in environments with VMware, we can plug in very seamlessly, very transparently as part of that overall ecosystem. A couple things that I want to point out here. So for years we've had VAAI integration, which basically allows us to take things that would normally run at the host level, at the cluster level, and offload that off onto the storage array, freeing up resources on the host, one thing, but more importantly, taking advantage of the array-based features that are optimized for doing things like copying data around, for things like being able to go in and reclaim space as you're deleting things out of the environment. So these are real important things that we're able to do. The other thing that we've done recently with this latest release is we've introduced a new version of Unisphere, which is our user interface into the storage array. One of the things that we've always done is we've had the ability to basically look into the VM environment and drill down into the individual VMs for things like reporting, for masking views, for understanding performance metrics, to do troubleshooting. So these are things that we've always had the ability to do, but one of the new features is how we can actually plug into that and being able to do that at a much broader level. So rather than having to go in and add in individual VMs to be under Unisphere control, we now have the ability to do that at the ESX cluster or even at the vCenter level. So it's much more easier to be able to take large environments and to use Unisphere as a way of being able to get visibility into what's happening on the virtual side. One of the new features that we introduced, actually not new anymore I should say, is this feature around SRDF Metro. So that's our remote replication solution, and we've had remote replication available for a number of years. What's different about this is we no longer run active-passive when doing replication. What we now can do is we can run active-active. So this gives us the ability to have both sites being able to access data simultaneously. So if something happens at one location or another, the time recovered to failover is much faster, and the recovery point in terms of data loss is 0. Right? But there's some other things that we're able to do with Metro, and what I wanted to do is I wanted to bring up one of our corporate systems engineers, Mr. James Salona, to come in and show you guys. Who wants to see a demo? All right, here we go. Let's we'll geek out with a demo. So what we have here is we've got an environment set up in the lab. And we've got two VMax systems, actually a PowerMax and a VMax system in this environment, and we're using SRDF Metro to replicate over about 26 miles of distance between the two sites. So James, what are we going to look at here?
So right now we're looking at the vCenter client, and what we're going to do is we'll take a quick look at what's going on here. Again, we have those two data centers, right, surprisingly right about a marathon apart. So we have Boston, it's got a cluster there, and we have Hopkinton.
So talk about what you do in your lab environment. What are some of the things that go on inside the lab?
So we do a lot of demos, POCs. We're constantly kind of playing around with different equipment, and a lot of that requires a lot of maintenance. So I'm often migrating VMs from one site to the other to do some standard maintenance.
It's a very dynamic environment. You're moving equipment out, you're moving equipment in, you're making upgrades, you're doing certification testing, you've got all these types of things. Yeah. So why do you guys use SRDF Metro?
Well, it makes my life just a little bit easier. I think so when we first started, when I was migrating VMs the old-fashioned way, we're looking at about 3 hours or so. And now with SRDF Metro and SRM, now it's down to total 3 minutes.
Total 3 minutes, and that's all the administration time as well, right? So one of the things that you're able to do is now, because you've got SRDF Metro, when it comes time to move something from one cluster to another cluster, the ability to have Metro actually move that data for you while keeping that application up and running means that you're going from hours in terms of move time down to minutes, actually in some cases sub-minutes to be able to do that.
Yeah.
All right, so show us how it works.
Huge benefits there. So we'll jump into Site Recovery Manager over here. So we'll jump into that. So this is going to link us to the new one. So we open this.
So one of the things that's important I want to point out here is the fact that you're doing all of this and you're doing it through vCenter using Site Recovery Manager. So you're not going outside of the VMware management tools in order to make this happen. Part of the reason why we're able to do that is we have an SRA, a storage replication adapter, that understands SRDF Metro running active-active under the covers. It's really one of the only and the first SRA adapters to be able to support active-active replication. Exactly. And that's why you can control all of this from vCenter.
Nope, I'm not jumping between the management interfaces, nothing like that. It's all clicks within the same UI. So like Scott said, in Boston, we have our all-new PowerMax 8000, and in Hopkinton, we have a VMAX 250F, which is an all-flash system. So we'll look at, earlier on, we created the protection group. That's kind of the policy in place for what we want to do in the event of a failure or in a planned migration.
And just so to understand, how long did it take you to set up that SRDF Metro relationship?
I mean, I was using Unisphere, so it's just a couple of clicks.
So a couple clicks.
Not a process,
right.
Not at all.
So if you've used the replication tools in the past, you may have been experienced to the world where you needed kind of a PhD in terms of the technology to understand it, but it's changed greatly with the latest management tools.
It's very easy, yep. And with the new HTML5 Unisphere, it makes life even easier. So we'll take a look at this. We want to see, we set up this recovery policy. Boston is our protected site, and we're going to be migrating over to Hopkinton. So we'll click on this, we'll go here, and what we're going to do is run this. And this is going to automate all that migration from Boston to Hopkinton. And here, why SRDF Metro is so good is because right here we can click that, and we're going to be leveraging vMotion. So we're not going to be powering up those VMs, moving to a new data store, because as far as this cluster is concerned, it's just a single devices.
And from here, if I wanted to do a failover, I could go in and I could select that environment. And what that would do is that would basically restart the applications all at one of the other sides. So right here, you're just doing a move.
Exactly. So if we had some sort of disaster, but this is a planned migration just for some maintenance. Okay. Next, this is just asking you all the finalizations of it. Finish this. What's going to happen is it already has that failover plan in place, so it's going to start that. It's relocating the virtual machines. Again, we're not turning anything off, we're just moving them over. We're going to rescan the HBAs, rescan the data center, the VMFS.
And this is all basically happening in real time. I understand it's not a live demo, but the recording and the time that it takes to do this is basically what you would experience as a user.
Exactly. And just to get some of the more details about the steps that are going on, you can see at step number 10, we're skipping shutting down the protected VMs because this is using vMotion.
So everything's up and running.
Yep. And so that's it. We're migrated over to the new site. What we want to do right